Chapter 7. The Evidence of Astronomy, the Privileged Planet. As we survey all the evidence, the thought insistently arises that some supernatural agency or, rather, agency must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof of the existence of a supreme being? Was it God who stepped in and so providentially crafted the cosmos for our benefit? Astronomer George Greenstein. Astronomy leads us to a unique event, a universe which was created out of nothing, one with the very delicate balance needed to provide exactly the conditions required to permit life, and one which has an underlying, one might say supernatural, plan. Nobel laureate Arno Penzias. There's nothing unusual about Earth. It's an average, unassuming rock that's spinning mindlessly around an unremarkable star in a run-of-the-mill galaxy — a lonely speck in the great enveloping cosmic dark, as the late Carl Sagan put it. The fact that life flourishes on our planet isn't exceptional. Creatures of all kinds undoubtedly abound, we're told, in countless locations among the 10 trillion billion stars in the universe. Some scientists have estimated there are up to 10 trillion advanced civilizations. Sagan put the number at 1 million for our Milky Way galaxy alone. After all, the forces of nature are so automatic that life is sure to have evolved wherever water exists. That's why whenever scientists raise new speculation about liquid water being present on another celestial body, the underground worlds of Jupiter's frozen moons Europa and Ganymede are currently the most fashionable examples, then the automatic assumption is that living organisms must necessarily and inexorably follow. If life can emerge from non-life so quickly and efficiently on a planet as undistinguished as ours, they reason, then why not throughout the universe's hundreds of billions of galaxies? To them, life is like a soup mix, just add water. The very title of astrobiologist David Darling's recent book nicely encapsulates this optimistic philosophy: life everywhere. He's enthusiastic about claims that life may arise inevitably whenever a suitable energy source, a concentrated supply of organic, carbon-based material and water occur together. These ingredients, he said, are starting to look ubiquitous in space. Consequently, he believes microbial life, at least, is widespread. In short, Earth has no privileged status. Polish scientist Nicholas Copernicus deflated our oversized ego by putting us in our place long ago. The universe doesn't revolve around us, instead, we're just living in a humdrum hamlet off the beaten path in a nondescript suburb of the vast Milky Way. We have no grand role, no meaning, no significance, no reason for being other than, well, just being. The universe that we observe, said Oxford's Richard Dawkins, has precisely the properties we should expect if there is, at bottom, no design, no purpose, no evil and no good, nothing but blind, pitiless indifference. This is the essence of what I was taught as I studied science. Of course, these conclusions neatly bolstered my atheistic values. Somehow I managed to avoid getting too depressed by the personal implications of all of this, strangely finding hope and inspiration in the belief that we are not alone in the universe. Even if God didn't exist, at least there were millions of advanced civilizations out there. Beaming messages to Hercules. Ever since I first watched the classic movie The Day the Earth Stood Still as a child, I'd been enthralled by the fanciful images of teeming intergalactic life portrayed in science fiction. Sure, Star Trek and Star Wars were silly, but still, the idea of other exotic creatures living in the strange nooks and crannies of the universe was always intriguing and even comforting to me. Later I became fascinated by the Drake equation, an attempt by astronomer Frank Drake to quantify the number of civilizations that might exist in our galaxy. The equation factors in such variables as how many of the 200 to 300 billion stars in our Milky Way might resemble our own sun, the percentage of stars that may have planets in habitable zones, and so forth. Though the specific numbers that scientists then plugged into Drake's equation mostly amounted to rank conjecture fueled by their own biases, one scientist admitted it was a way of compressing a large amount of ignorance into a small space. This did lend an air of scientific certainty to a highly speculative issue. Then I cheered from afar in the mid-1970s as Drake and Sagan beamed a message of greeting to the Great Globular Cluster M13, which is a concentration of 250,000 stars in the constellation Hercules. While I knew there wasn't much practical science involved with this intragalactic phone call, it would take more than 22,000 years for the message to reach its destination. Nevertheless, there was something romantic and adventurous about trying to communicate with the civilizations that most assuredly populated those distant stars. All of this helped form my perspective as I would gaze over the years at the twinkling stars in the dark heavens. But now my attitude was changing. After studying the latest evidence from various scientific disciplines, from astronomy to cosmology to geology to oceanography to microbiology, my conclusions were being tugged in the opposite direction. It's turning out that the Earth is anything but ordinary, that our Sun is far from average, and that even the position of our planet in the galaxy is eerily fortuitous. The idea that the universe is a flourishing hothouse of advanced civilizations is now being undermined by surprising new scientific discoveries and fresh thinking. In short, new findings are suggesting that we are special. More and more scientists are studying the mind-boggling convergence of scores of extraordinary coincidences that make intelligent life possible on Earth, and concluding that this can't possibly be an accident. They are seeing signs of design, a kind of unlikely fine-tuning for life similar to the fine-tuning of physics that we explored in the previous chapter. In fact, said one noted researcher, new evidence which could potentially have refuted the design hypothesis has only ended up confirming it. Once again, we find the evidence of science pointing in the direction of a creator. And rather than our lives being purposeless, scientists for the first time are uncovering concrete evidence that suggests at least one surprising purpose for which we were created, that is, to discover and learn about the surroundings in which we have been placed. In other words, as we'll see in this chapter, one purpose for which we were designed is to do science itself. Right place, right time. As the new millennium dawned, geologist Peter D. Ward and astronomer Donald Brownlee, both professors at the University of Washington in Seattle, published a provocative and highly successful book that raised this disquieting question about Earth: what if it is utterly unique, the only planet with animals in this galaxy or even in the visible universe? Their book, Rare Earth, marshals evidence from a wide range of scientific disciplines to build its case that not only intelligent life, but even the simplest of animal life, is exceedingly rare in our galaxy and in the universe. They called the conclusion inescapable that Earth is a rare place indeed. Although Ward and Brownlee uncritically buy into the idea that microbial life may very well be more prevalent, a view they draw from the way life seemed to have effortlessly developed on Earth about as soon as environmental conditions allowed its survival, their conviction that the existence of complex life is extraordinarily rare is bolstered by convincing data divorced from any theological framework. Calling their book carefully reasoned and scientifically astute, Don Johanson, director of the Institute of Human Origins at Arizona State University, remarked, "In spite of our wishful thinking, there just may not be other Mozarts or Monets." David Levy, of Comet Shoemaker-Levy fame, added, "As we know it on Earth, complex life might be very rare, and very precious." Said the Times of London, "If they are right, it could be time to reverse a process that has been going on since Copernicus." More and more scientists are observing the stunning ways in which our planet against all odds manages to fulfill a large number of finely balanced criteria that are absolutely crucial to supporting a habitat suitable for humankind. Rather than being one planet among billions, Earth now appears to be the uncommon Earth, said science educators Jimmy H. Davis and Harry L. Poe. The data imply that Earth may be the only planet in the right place at the right time. A bold and audacious claim. Earth's location, its size, its composition, its structure, its atmosphere, its temperature, its internal dynamics, and its many intricate cycles that are essential to life: the carbon cycle, the oxygen cycle, the nitrogen cycle, the phosphorus cycle, the sulfur cycle, the calcium cycle, the sodium cycle, and so on, testify to the degree to which our planet is exquisitely and precariously balanced. As they begin their influential textbook Earth, Frank Press of the National Academy of Sciences and Raymond Seaver of Harvard University write about what they call the uniqueness of planet Earth. They note how its atmosphere filters out harmful ultraviolet radiation while working with the oceans to moderate the climate through the storing and redistributing of solar energy, and how the Earth is just large enough so that its gravity retains the atmosphere and yet just small enough not to keep too many harmful gases. Then they describe the Earth's interior as a gigantic but delicately balanced heat engine fueled by radioactivity. Were it running more slowly, the continents might not have evolved to their present form. iron may never have melted and sunk to the liquid core, and the magnetic field would never have developed. If there had been more radioactive fuel, and therefore a faster running engine, volcanic dust would have blotted out the sun, the atmosphere would have been oppressively dense, and the surface would have been racked by daily earthquakes and volcanic explosions. These kind of highly choreographed geological processes, and there are lots of them, leave me shaking my head at the astounding ways in which our biosphere is precisely tuned for life. Even more interesting, though, is the why question behind them. What accounts for all of these astounding coincidences? Press and Seaver, while marveling that Earth is a very special place, don't broach the possibility of design. Ward and Brownlee skirt the issue in Rare Earth, preferring instead to occasionally pepper in words like sheer luck and a rare chance happening. At a conference, Ward remarked, "We are just incredibly lucky. Somebody had to win the big lottery, and we were it." But does luck really explain why Earth enjoys this incredible convergence of extremely unlikely circumstances that have allowed human beings to flourish? Going far back into time, Christians have reached a far different conclusion. Earth was created by God as the stage upon which the human drama would be played out. What's amazing about modern science, including new discoveries just within the last few years, is that this view of the universe seems to be far better supported today than in ancient times. Consider the conclusion of Michael J. Denton, a senior research fellow in human molecular genetics at the University of Otago in New Zealand, in his 1998 book Nature's Destiny. No other theory or concept ever imagined by man can equal in boldness and audacity this great claim, that all the starry heavens, that every species of life, that every characteristic of reality exists, to create a livable habitat for mankind. But most remarkably, given its audacity, it is a claim which is very far from a discredited pre-scientific myth. In fact, no observation has ever laid the presumption to rest. And today, for centuries after the scientific revolution, the doctrine is again re-emerging. In these last decades of the 20th century, its credibility is being enhanced by discoveries in several branches of fundamental science. How true are those words? Do the special conditions that allow for life on Earth demand a designer? To pursue reliable answers, I arranged a rendezvous at O'Hare International Airport in Chicago with two experts who had just collaborated on a groundbreaking book concerning this very topic. This would be a perfect opportunity to explore the stunning uniqueness of our planet. Interview number 5, Guillermo Gonzalez, Ph.D., and J. Wesley Richards, Ph.D. Tall, blonde J. Wesley Richards, dressed in a navy blazer, is an Ivy League philosopher who speaks in rapid-fire bursts with unflagging enthusiasm. Guillermo Gonzalez, clad in a short-sleeve shirt, his thinning hair cropped short, is a nuts-and-bolts astronomer who talks in professorial tones on such topics as chemical abundance trends among RV stars. Together, they authored The Privileged Planet, which documents astonishing evidence pointing toward a designer for Earth and toward at least one apparent purpose for humankind. Gonzalez is informally known as a star guy. After graduating summa cum laude with degrees in astronomy and physics from the University of Arizona, he later earned his master's degree and doctorate in astronomy from the University of Washington at Seattle. Now an assistant professor at Iowa State University, his research centers on low and intermediate mass stars and theories about stellar and planetary evolution. He's a hands-on and yet conceptually sophisticated scientist, having logged countless hours doing research through telescopes at Cerro Tololo International Observatory, located at an altitude of 6,600 feet in Chile, and 4 other locations. He is adept at analyzing photometric and spectroscopic data. A member of the International Astronomical Union and the American Scientific Affiliation, the LOCI, but engaging Gonzalez has seen dozens of his articles published in technical journals and featured on the covers of such popular magazines as Scientific American. An academic overachiever with a sincere, self-effacing personality, Richards holds 3 advanced degrees in philosophy and theology, including a doctorate from Princeton Theological Seminary. He authored The Untamed God and has edited or contributed to such books as Unapologetic Apologetic, Signs of Intelligence, and Are We Spiritual Machines? His articles have appeared in publications ranging from Perspectives on Science and Christian Faith to The Washington Post to the Princeton Theological Review. As vice president of the Discovery Institute, Richards is considered a bright star in the burgeoning intelligent design movement. Each of us clutching a soft drink, we met in an airline's hospitality suite, with Richards and Gonzalez sitting across from me at a granite conference table under fluorescent lights in a simple room devoid of character. Anxious to proceed, I barely let them settle into their chairs before unleashing my first question. The Copernican Principle. I turned toward Richards. I was taught in school that our planet is unexceptional, that we revolve around a typical star in an average, mundane part of the universe, and that there's nothing particularly unusual or special about Earth, I began. Isn't that the view of most scientists today? Yes, that's the so-called principle of mediocrity, or the Copernican Principle, Richards replied. Open any introductory astronomy textbook and you'll see it stated over and over that we should assume there's nothing special about our situation, our location in the universe, or the particular features of the Earth, the solar system, or humans themselves. But, I interjected, isn't that appropriate in some sense? Yes, of course, he said. We shouldn't assume that the Earth, our solar system, or our Sun is unique in every possible way. We wouldn't be able to do science if every place in the universe had a different law of gravity or atoms had a different mass. That's fine. Then where does the problem come in? I asked. The problem is that the Copernican principle has taken a metaphysically bloated form, which essentially says our metaphysical status is as insignificant as our astronomical location. In other words, we're not here for a purpose, we're not special in any way, and we don't occupy a privileged place in the cosmos. I interrupted again. Yet isn't it true that Copernicus's discovery that the Sun doesn't revolve around the Earth, but that the Earth revolves around the Sun quite naturally demoted humankind? Richards nodded wearily as if he had heard that comment a lot. Let's go back to the beginning, he said. He stood, removed his jacket, and draped it over an unoccupied chair. Sitting back down, he continued. The story is that the ancients Aristotle, Ptolemy, medieval Christians all thought we were at the center of the universe, sort of the throne of the cosmos, the most important place that everything revolved around. Then Copernicus and Kepler came along and said they can explain the movement of the planets better by assuming that the Sun is at the center and that the planets including Earth revolve around it. So we've been displaced from the center and removed from our position of privilege. This was the start of a long march of science that continued to demote us. Scientists later determined the Sun isn't at the center of the universe, that we aren't at the center of the galaxy, and that the universe ultimately had no center, because scientists came to believe in the 19th century that it was infinite and eternal. You can see how this trend helped us to see ourselves as less and less significant, less and less at the center of things. So the Copernican revolution came to represent the conflict between science and religion. Religious superstition maintained the Earth and humankind are the center of the universe, both physically and metaphysically, but modern science has disproved that. Humans have been stripped of their false sense of uniqueness and importance. While religious folk continue to insist there is something unique, special, intentional, and purposeful about our existence, scientists maintain that the material world is all there is, and that chance and impersonal natural law alone explain its existence. I was following along in full agreement. Richards's assessment was entirely consistent with what I had been taught in school. But then he added the clincher. The problem, he said, a slight smile playing at the corner of his mouth, is that this historical description is simply false. Setting the record straight. Richards's claim startled me. False? I declared. What do you mean? In what way? Read Ptolemy, Galileo, Copernicus, Kepler. Read Dante, he said. In Dante's Divine Comedy, the surface of the Earth is an intermediate place. This was true in Aristotelian cosmology, which was Christianized in the Middle Ages. For Aristotle, the world was made of air, earth, fire, and water. Earth is heaviest, so it naturally falls to the bottom. So the Earth was not so much at the center as it was at the bottom of the universe. It was sort of the cosmic sump. It was the place where things decay and die. Everything above the moon was made of a different type of matter quintessence, and God dwelled in the heavenly sphere outside the celestial sphere of the stars. Man was in an intermediate place. Gonzalez spoke up. Dante then inverted these levels as you go the other way, down to hell. He said. Exactly, continued Richards. You had 9 levels going up toward God and getting closer to perfection, and then there were 9 levels getting closer to absolute depravity, down to hell. Thus, in medieval cosmology, what we would call the center of the universe is Satan's throne. That's a very important point. If you imagine the center of the universe is Satan's throne and that the Earth itself is the cosmic sump, then clearly this is not the stereotype that we've been given that the center of the universe prior to Copernicus was the preeminent spot. Gonzalez added, the Enlightenment later retold the story by saying the Church, because of its arrogance, put humans in the center. Richards nodded. That's the irony, he said. It was the Enlightenment that made man the measure of all things. When you really think about it, Christian theology never actually put man literally in the center. We have a very important role to play in this cosmic drama, so much so that God even becomes incarnate. But it was never the case that everything was literally created solely for us. Many centuries ago, Augustine said God didn't create the world for man or because of some sort of compulsion, but because he wanted to. In the Divine Comedy, the reader learns that the actual sense of us being in the center was merely a bias. We discover, in fact, that everything was arranged so that God is at the metaphysical center, that is, the place of supreme importance. Instead of denigrating Earth, actually Copernicus, Galileo, and Kepler saw their new scheme as exalting it. For instance, Galileo waxes poetic about how the Earth, like the other planets, reflects the glory of the Sun and is no longer just a cosmic sump. So in the transformation from medieval cosmology to the Renaissance view, this new perspective elevated man in some ways. Other historical researchers have come to the same conclusion. Said one, the Copernican system, far from demoting man, destroyed Aristotle's vision of the Earth as a kind of cosmic sink, and if it did anything, it elevated humanity. In making the Earth a planet, a heavenly body, Copernicus infinitely ennobled its status. But something didn't add up to me. Didn't the Church persecute Copernicus, Galileo, and Giordano Bruno for their view that the Earth revolved around the Sun? I asked. First of all, Richards said, some claim Copernicus was persecuted, but history shows he wasn't. In fact, he died of natural causes the same year his ideas were published. As for Galileo, his case can't be reduced to a simple conflict between scientific truth and religious superstition. He insisted the Church immediately endorse his views rather than allow them to gradually gain acceptance. He mocked the Pope, and so forth. Yes, he was censured, but the Church kept giving him his pension for the rest of his life. Indeed, historian William R. Shea said, Galileo's condemnation was the result of the complex interplay of untoward political circumstances, political ambitions, and wounded prides. Historical researcher Philip J. Sampson noted that Galileo himself was convinced that the major cause of his troubles was that he had made fun of His Holiness, that is, Pope Urban VIII, in a 1632 treatise. As for his punishment, Alfred North Whitehead put it this way, Galileo suffered an honorable detention and a mild reproof, before dying peacefully in his bed. Bruno's case was very sad, Richards continued. He was executed in Rome in 1600. Certainly, this is a stain on church history. But again, this was a complicated case. His Copernican views were incidental. He defended pantheism and was actually executed for his heretical views on the Trinity, the Incarnation, and other doctrines that had nothing to do with Copernicanism. Now, here's the point I want to make. It's very important if you're going to advance the Copernican principle that you make it look like it's grounded in the historical march of science. But when you actually look at the data, it's just not true. Writers of astronomy textbooks just keep recycling the myth, sort of like the flat Earth myth, which was the idea that Columbus was told the Earth was flat and he thought it was round. That's just wrong too. Scholars at the time knew it was a sphere, added Gonzalez. Even the ancient Greeks knew it was a sphere. They'd known it for 1,000 years or more, said Richards. I knew they were right about that. David Lindbergh, former professor of the history of science and currently director of the Institute for Research in the Humanities at the University of Wisconsin, said in a recent interview. One obvious myth is that before Columbus, Europeans believed nearly unanimously in a flat earth, a belief allegedly drawn from certain biblical statements and enforced by the medieval church. This myth seems to have had an 18th century origin, elaborated and popularized by Washington Irving, who flagrantly fabricated evidence for it in his 4-volume History of Columbus. The truth is that it's almost impossible to find an educated person after Aristotle who doubts that the earth is a sphere. In the Middle Ages, you couldn't emerge from any kind of education, cathedral school or university, without being perfectly clear about the Earth's sphericity and even its approximate circumference. Now, in addition to the flat Earth myth being exploded, here were Richards and Gonzalez asserting that the Copernican Principle was based on faulty history as well. So, continued Richards, Guillermo and I embarked on a project to document whether there are important ways in which Earth is special or exceptional. To do this, we had to show that there's not this long historical march of science showing how unimportant we are. We had to point out that the history is wrong and that what we're doing stands in the good tradition of science, which says, let's find out what the world is like to the best of our ability. And, I said, what did you find? Richards and Gonzalez exchanged glances. Well, scientists have generally followed the Copernican principle by saying that our planet is ordinary and that therefore life undoubtedly abounds in the universe, Richards began. We believe, however, the evidence is quite to the contrary. He gestured toward his colleague to continue. We found that our location in the universe, in our galaxy, in our solar system, as well as such things as the size and rotation of the Earth, the mass of the moon and sun and so forth, a whole range of factors conspire together in an amazing way to make Earth a habitable planet. Gonzalez said. And even beyond that, we've found that the very same conditions that allow for intelligent life on Earth also make it strangely well suited for viewing and analyzing the universe. And we suspect this is not an accident, Richards added. In fact, we raised the question of whether the universe has been literally designed for discovery. The ingredients for life. With that framework set, I moved ahead to discuss one of the main attitudes of scientists who embrace the Copernican principle. They believe if you can just find a place anywhere in the universe where water stays liquid for a long enough period of time, then life will develop, just as it did on Earth, I said. I assume you don't agree with that. No, I don't, Gonzalez said. It's true that in order to have life you need water, which is the universal solvent for reactions to take place, as well as carbon, which serves as the core atom of the information-carrying structural molecules of life. But you also need a lot more. Humans require 26 essential elements, a bacterium about 16. Intermediate life forms are between those two numbers. The problem is that not just any planetary body will be the source of all those chemical ingredients in the necessary forms and amounts. I interrupted to point out that science fiction writers have managed to speculate about extraterrestrial life that's built in a radically different form, for instance, creatures based on silicon instead of carbon. Gonzalez was shaking his head before I had even finished my question. That just won't work, he insisted. Chemistry is one of the better understood areas of science. We know that you just can't get certain atoms to stick together in sufficient number and complexity to give you large molecules like carbon can. You can't get around it. And you just can't get other types of liquids to dissolve as many different kinds of chemicals as you can with water. There's something like half a dozen different properties of both water and carbon that are optimal for life. Nothing else comes close. Silicon falls far short of carbon. Unfortunately, people see life as being easy to create. They think it's enough merely to have liquid water, because they see life as an epiphenomenon, just a piece of slime mold growing on an inert piece of granite. Actually, the Earth's geology and biology interact very tightly with each other. You can't think of life as being independent of the geophysical and meteorological processes of the planet. They interact in a very intimate way. So you need not only the right chemicals for life, but also a planetary environment that's tuned to life. That sparked a related issue. Scientists have dreamed of terraforming a planet like Mars, essentially making over its environment to create a planet that's more conducive to settlement by humans. Would that be very difficult? I asked. Absolutely. From the magnetic field to plate tectonics to the carbon dioxide cycle, ongoing life depends on a variety of very complicated interactions with the planet, he said. Richards jumped in. People generally think that because they plant a seed and it grows that it's easy to create the right environment for life, but that's misleading, he said. A good example is the hermetically sealed biosphere that some people constructed in Arizona several years ago. They thought it would be relatively easy to create a self-contained environment conducive to life, but they had a devil of a time trying to make it work. But life can also exist in some terribly harsh conditions, I pointed out. For instance, there are life forms that live off of deep-sea thermal vents. They don't seem to need oxygen or any particular support from the broader environment. On the contrary, Gonzalez said, the only things down there that don't need oxygen are some microorganisms that breathe methane. But larger organisms, which need to regulate their metabolism, are invariably oxygen breathers. The oxygen comes from surface life and marine algae. The oxygen gets mixed in with the ocean and transported into deep waters. So those organisms are very directly tied to the surface and the overall ecosystem of the planet. Astounded by the Earth's fine-tuned physical, chemical, and biological interrelationships, some writers have gone so far as to liken our biosphere to a superorganism that is quite literally alive. In fact, James Lovelock's pantheistic Gaia hypothesis even seeks to deify our planet. However, Gonzalez and Richards said it's unnecessary to go that far. Despite these admittedly incredible interrelationships, there's nothing that requires anyone to see the Earth itself as being an organism, especially a god or goddess, Richards said. Then he turned to an image quite familiar to those who see the earmarks of design in Earth's complex and interconnected machinery. That's sort of like deifying a watch because of its amazing properties, he said, rather than looking beyond the watch to the one who made it. The hostile world of M13. I granted the point that only certain kinds of planetary environments can play host to life. On the other hand, the universe is salted with trillions of stars, with countless terrestrial bodies undoubtedly revolving around them. Surely the mathematical odds favor many stars spawning Earth-like habitats, a point that argues against the idea that Earth is special and therefore designed. But while my untrained eyes see each star as having equal potential to preside over a civilization-bearing solar system, I was soon to learn differently as I pursued questions concerning the conditions that are necessary for life to flourish. I turned toward Gonzalez. As we look out at the billions of stars that constitute our Milky Way galaxy, I said, can't we logically assume that planets teeming with life are strewn all over the place? No, he said unequivocally, that's not a logical assumption based on the evidence. Along with Don Brownlee and Peter Ward of the University of Washington, I developed a concept called the Galactic Habitable Zone, that is, a zone in the galaxy where habitable planets might be possible. You see, you just can't form a habitable planet anywhere, there's a large number of threats to life as you go from place to place. My mind flashed back to when Drake and Sagan beamed their message to the large concentration of stars called Globular Cluster M13. Their theory was that by transmitting their greeting toward a place packed with stars, there would be a higher chance of detection by an intelligent civilization. When I asked Gonzalez what he thought of that experiment, his reply was immediately dismissive. The problem is that if the probability of life at any one star is zero, then the probability for all the stars remains zero, he said. Zero? I replied. There are more than 250,000 stars in that globular cluster. Don't you think any of them harbor planets with life? Gonzalez stood his ground. A globular cluster is one of the worst places in the entire galaxy to expect any life, he replied. Why? 2 reasons, he said. First, globular clusters are among the most ancient things in our galaxy. Since they're extremely old, their stars have a very low abundance of heavy elements: carbon, nitrogen, oxygen, phosphorus, calcium, and so on. Instead, they're made up almost entirely of hydrogen and helium. In contrast, Earth is composed of iron, oxygen, magnesium, and silicon. Next comes sulfur. You see, the Big Bang produced basically hydrogen and helium. That's what the earliest stars were made of. The heavier elements were synthesized, cooked, if you will, in the interior of stars. Eventually, when these stars exploded as supernovae, these elements got expelled into the interstellar medium. They coalesced into other stars, where more heavy elements were cooked. Then they were expelled again and again, with stars subsequently containing ever greater amounts of thessemetals, or heavier elements. Now, you need these elements to eventually build terrestrial planets like Earth. Because the very old stars in globular clusters formed so early that they're composed virtually exclusively of hydrogen and helium, they're not going to have planets accompanying them. Maybe there will be dust, or grains, or boulders, but that's about it. You're not going to have Earth-sized planets. The second problem is that globular clusters are so densely packed with stars that they wouldn't allow for stable, circular orbits to exist around them. The gravitational pull of the stars would create elliptical orbits that would take a hypothetical planet into extremes of cold and heat, which would create a life-prohibitive situation. His assessment made sense, but it caused me to wonder why Sagan and Drake, both knowledgeable astronomers, would waste their time trying to communicate with the stars of M13. Gonzalez shook his head when I asked him about it. It's really surprising that they would think there would be any chance of a civilization receiving their message in a globular cluster, Gonzalez said. They should have known better. Frankly, I think they were so deluded by their complete belief in the metaphysical Copernican principle that life was just going to be everywhere in the galaxy that they overlooked the facts. Living in the safe zone. Gonzalez's explanation made me wonder about the suitability of other places to harbor intelligent life. I knew that there are three basic types of galaxies in our universe. First, there are spiral galaxies like our own Milky Way. These are dominated by a central spherical bulge and a disk with spiral arms extending outward from the nucleus in a spiral pattern, resembling a celestial pinwheel. Second, there are elliptical galaxies, which are sort of egg-shaped. And, third, there are irregular galaxies, which appear disorganized and distorted. I asked Gonzalez to assess the life-bearing potential of each one. Certainly, our type of galaxy optimizes habitability, because it provides safe zones, he said, his tone professorial. And Earth happens to be located in a safe area, which is why life has been able to flourish here. You see, galaxies have varying degrees of star formation, where interstellar gases coalesce to form stars, star clusters, and massive stars that blow up as supernovae. Places with active star formation are very dangerous, because that's where you have supernovae exploding at a fairly high rate. In our galaxy, those dangerous places are primarily in the spiral arms, where there are also hazardous giant molecular clouds. Fortunately, though, we happen to be situated safely between the Sagittarius and Perseus spiral arms. Also, we're very far from the nucleus of the galaxy, which is also a dangerous place. We now know that there's a massive black hole at the center of our galaxy. In fact, the Hubble Space Telescope has found that nearly every large nearby galaxy has a giant black hole at its nucleus. And believe me, these are dangerous things. Most black holes, at any given time, are inactive. But whenever anything gets near or falls into one, it gets torn up by the strong tidal forces. Lots of high energy is released. Gamma rays, X-rays, particle radiation, and anything in the inner region of the galaxy would be subjected to high radiation levels. That's very dangerous for life forms. The center of the galaxy is also dangerous because there are more supernovae exploding in that region. One more thing, the composition of a spiral galaxy changes as you go out from the center. The abundance of heavy elements is greater towards the center, because that's where star formation has been more vigorous over the history of the galaxy. So it has been able to cook the hydrogen and helium into heavy elements more quickly, whereas in the outer disk of the galaxy, star formation has been going on more slowly over the years, and so the abundance of heavy elements isn't quite as high. Consequently, the outer regions of the disk are less likely to have Earth-type planets. Now, put all of this together. The inner region of the galaxy is much more dangerous from radiation and other threats. The outer part of the galaxy isn't going to be able to form Earth-like planets because the heavy elements are not abundant enough, and I haven't even mentioned how the thin disk of our galaxy helps our sun stay in its desirable circular orbit. A very eccentric orbit could cause it to cross spiral arms and visit the dangerous inner regions of the galaxy, but being circular it remains in the safe zone. All of this, he said, his voice sounding a bit triumphant, works together to create a narrow safe zone where life-sustaining planets are possible. Scanning the stars for life. Suddenly, the Earth was sounding pretty special, nestled as it is in a sliver of space that gives it safe haven from the otherwise menacing conditions of the Milky Way. But what about other types of galaxies? Might they also provide threat-free neighborhoods for life-populated planets? What about elliptical galaxies? I asked Gonzalez. Do they have the potential to harbor life? Elliptical galaxies look amorphous and are sort of egg-shaped, with stars having very random orbits, like bees swarming a beehive, he explained. The problem for life in these galaxies is that the stars visit every region, which means they'll occasionally visit the dangerous, dense inner regions, where a black hole may be active. In any event, you're less likely to find Earth-like planets in elliptical galaxies because most of them lack the heavy elements needed to form them. This was an important point, because I knew that most galaxies fall into the elliptical category. Most elliptical galaxies are less massive and luminous than our galaxy, Gonzalez continued. Our galaxy is on the top 1 or 2% of the most massive and luminous. The bigger the galaxy, the more heavy elements it can have, because its stronger gravity can attract more hydrogen and helium and cycle them to build heavy elements. In the low-mass galaxies, which make up the vast majority, you can have whole galaxies without a single Earth-like planet. They just don't have enough of the heavy elements to construct Earths. Just like a globular cluster, you can have a whole globular cluster with hundreds of thousands of stars, and yet there won't be a single Earth. If you look at the deepest pictures ever taken by the Hubble Space Telescope, they show literally thousands of galaxies when the universe was really young. People have commented, "Wow, look at all those galaxies. I wonder how many civilizations there are looking back at us." In that picture, I'd say 0. Thousands and thousands and thousands of galaxies but 0 Earths, because the heavier elements haven't built up enough yet. Richards interrupted to say, of course, we're not looking at these galaxies as they exist now, we're looking back in time, say, 9 billion years ago. It's possible that some of those galaxies are now at the state where the Milky Way is. We don't know for sure. But, added Gonzalez, this was back when it was much more dangerous, because it's the era of quasars, supernovae going off, and black holes. Even if you had a few regions in the galaxy where there were sufficient heavy elements to build Earths, they would have been so irradiated that life wouldn't be possible. With elliptical galaxies being unlikely sites for budding civilizations, I turned to the last category of galaxy, called irregulars. What's their potential for life? I asked. Like the ellipticals, they also don't provide a safe harbor. In fact, they're worse. They're distorted and ripped apart, with supernovae going off throughout their volume. There are no safe places where there are fewer supernovae exploding, like we have between our spiral arms. In fact, astronomers keep finding new threats to life. For example, we're learning more about gamma-ray bursts, which are more powerful than a supernova. If one of these goes off near you, the lights go out. So the probability for there being civilizations elsewhere actually keeps declining as we learn about the new threats that we didn't know about before. What's your opinion, then, about where Earth is located in the universe? I asked. In terms of habitability, I think we are in the best possible place, Gonzalez said. That's because our location provides enough building blocks to yield an Earth, while providing a low level of threats to life. I really can't come up with an example of another place in the galaxy that is as friendly to life as our location. Sometimes people claim you can be in any part of any galaxy. Well, I've studied other regions' spiral arms, galactic centers, globular clusters, edge of disks, and no matter where it is, it's worse for life. I can't think of any better place than where we are. That's ironic, I said. It's the reverse of the Copernican Principle. Richards agreed. The propaganda of the Copernican Principle has been that the long march of science has shown how common and ordinary our situation is. But the trend is in the opposite direction. The more you pile on the threats we're discovering in most places in the universe, and you contrast that with the many ways we're in a cocoon of safety, the more our situation appears special. The most famous example is our own solar system, Gonzalez said. At one time or another, scientists have speculated that there are civilizations on just about every body in our solar system: the Moon, Mars, Jupiter. Percival Lowell built his own observatory in Arizona to find these civilizations on Mars. He actually quoted Copernicus to justify his belief that we can't be the only civilization. Now they've backtracked to the point of saying, well, maybe there's some very simple slime mold beneath the surface of Mars or Europa. And even that is extremely questionable. That's how far back they've had to retreat. Very often, observed Richards, the Copernican Principle describes properties that don't matter. Who really cares whether we're in the physical center of the galaxy? It's irrelevant. What really matters is being in the place that's most conducive to life. And that's exactly where Earth finds itself. Planets circling other stars. Within the last few years, astronomers finally have been able to discover planets orbiting other stars, a major confirmation of what was once merely widespread speculation. Doesn't this confirm that there's nothing particularly out of the ordinary about our 9-planet system? I asked. I'll concede, said Gonzalez, that it demonstrates our solar system is not unique when it comes to having planets circling a star. But prior to the detection of the first planet orbiting another Sun-like star in 1995, the expectation was that astronomers would find giant gas planets in large circular orbits, much like Jupiter. Jupiter orbits the Sun in 12 years in a nearly circular orbit, far out from the terrestrial planets Mercury, Venus, Earth, and Mars. However, we're finding that the planets circling other stars are quite different from Jupiter. They orbit over a full range of distances, from just a tiny fraction of an astronomical unit, which is the distance between the Earth and the Sun, out to several astronomical units. Most of their orbits are highly elliptical, very few are circular. These strongly non-circular orbits utterly surprised astronomers. Because they strongly subscribed to the Copernican Principle, they had expected that other planetary systems would be just like ours. And that expectation was basically dashed. What's wrong with an elliptical orbit for those kind of planets? I asked. It poses a problem for the habitability of any terrestrial planets in their system, because it would make them less likely to have stable circular orbits, Gonzalez replied. For example, Earth's orbit is almost a perfect circle. A planet with the mass of the Earth would be sensitive to any of the gas giant planets if they had more eccentric orbits. The Earth-like planet's own orbit would be affected, making it less circular and therefore subjecting the planet to dangerous surface temperature variations. So, I said, if our own Jupiter had a more elliptical orbit, the Earth wouldn't be able to maintain as circular an orbit and have the steady temperature and predictable climate that come with that. That's right, he said. In fact, even small variations in our nearly circular orbit can cause ice ages, because of temperature shifts on the surface of the planet. We have to maintain a circular orbit as much as possible to maintain a relatively steady temperature. That's only possible because Jupiter's orbit isn't very elliptical and therefore doesn't threaten to distort our round orbit, taking hits for Earth. Now that we were discussing our solar system, I wanted to delve into other local factors that make our planet habitable. What is it about our solar system that contributes to life on Earth? I asked. A surprising amount, said Gonzalez. More and more, astronomers are learning how the other planets tie into the habitability of Earth. For example, George Wetherill of the Carnegie Institution showed in 1994 that Jupiter, which is huge, more than 300 times the mass of the Earth, acts as a shield to protect us from too many comet impacts. It actually deflects comets and keeps many of them from coming into the inner solar system, where they could collide with Earth with life-extinguishing consequences. This was illustrated very nicely by the impact of comet Shoemaker-Levy 9 into Jupiter in July 1994. This comet was attracted by Jupiter's tremendous gravitational pull and broke into fragments, with all of their hitting Jupiter. Even Saturn and Uranus participate in that kind of comet catching. In addition, the other planets in our inner solar system protect us from getting bombarded by asteroids from the asteroid belt. The asteroids are mostly between the orbits of Mars and Jupiter. Our first line of defense is Mars, being at the edge of the asteroid belt. It takes a lot of hits for us. Venus does too. If you want to get an idea of the stuff that probably would have hit the Earth, look at the surface of the Moon. The Moon, unfortunately, has too little surface area to provide much protection, but it's a nice record. What about the Earth's position in the solar system? I asked. How much does that contribute to its habitability? There's a concept invented by astrobiologists called the Circumstellar habitable zone. That's the region around a star where you can have liquid water on the surface of a terrestrial planet. This is determined by the amount of light you get from the host star. You can't be too close, otherwise too much water evaporates into the atmosphere and it causes a runaway greenhouse effect, and you boil off the oceans. We think that might be what happened to Venus. But if you get too far out, it gets too cold. Water and carbon dioxide freeze and you eventually develop runaway glaciation. The main point is that as you go further out from the sun, you have to increase the carbon dioxide content of the planet's atmosphere. This is necessary in order to trap the sun's radiation and keep water liquid. The problem is that there wouldn't be enough oxygen to have mammal-like organisms. It's only in the very inner edge of the circumstellar habitable zone where you can have low enough carbon dioxide and high enough oxygen to sustain complex animal life. And that's where we are. So if the Earth's distance from the Sun were moved by, say, 5% either way, what would happen? I asked. Disaster, came his quick reply. Animal life would be impossible. The zone for animal life in the solar system is much narrower than most people think. And that's why you need a circular orbit like the one Earth has, Richards added. You don't just want to be in the circumstellar habitable zone part of the time, you want to be in it continuously. It doesn't do you any good to have melted water for 4 months and then have the whole planet freeze up again. Our overachieving sun. Obviously, the key to continued life on Earth is the sun, whose nuclear fusion, taking place at 27 million degrees Fahrenheit at its core, provides us with consistent warmth and energy 93 million miles away. Ever since witnessing a solar eclipse as a child, carefully protecting my eyes by observing the phenomenon through a projected image inside a cardboard box, I have been fascinated by this fiery behemoth, whose mass is an incomprehensible 300,000 times greater than the Earth's. However, I had always been told that there was nothing out of the ordinary about the sun. As one text says flatly, the sun is a common fixed star. And if the sun is truly so average, so typical, so undistinguished, then the logical implication would be that lots of life-bearing Earths must be orbiting around lots of similar suns throughout the universe. Today, astronomers know a lot more about stars than they did when I was growing up, I said to Gonzalez. Is the consensus still that the sun is just a common star? No, not at all, Gonzalez replied. It's just recently that some new astronomy textbooks are finally starting to say that, well, the sun really is unusual after all. For instance, it's among the 10% most massive stars in the galaxy. In fact, if you pick a star at random, you're likely to pick one that's far less massive than the sun, usually red dwarfs, which make up about 80% of stars. Another 8 or 9% are called G-dwarfs, most of which also are less massive than the sun. The sun is a yellow dwarf. Technically, it has a G2 spectral type. His comment about the ubiquity of red dwarfs piqued my curiosity. Since red dwarfs dominate the universe, let's talk about them for a moment. Are they conducive to having life-bearing planets orbiting them? I asked. I don't think they are, Gonzalez said. Why not? Several reasons. First, red dwarfs emit most of their radiation in the red part of the spectrum, which makes photosynthesis less efficient. To work well, photosynthesis requires blue and red light. But a much greater problem is that as you decrease the mass of a star, you also decrease its luminosity. A planet would have to orbit this kind of star much closer in order to have sufficient heat to maintain liquid water on its surface. The problem is the tidal force between the star and the planet gets stronger as you move in, so the planet will spin down and eventually end up in what's called a tidally locked state. This means it always presents the same face towards the star. That's very bad, because it causes large temperature differences between the lit side and the unlit side. The lit side would be terribly dry and hot, while the unlit side would be prohibitively icy and cold. And there's another problem: red dwarfs have flares. But, I said, the sun has flares too. That's right. And the intensity of flares on red dwarfs is about the same as on our sun. The difference is that red dwarfs as a whole emit much less total light, so they're much less luminous. That means in comparison to the luminosity of the star, the output of the flare is high. Whoa! I said, putting up my hand in protest. You've lost me. Gonzalez regrouped. Okay, let me get to the bottom line. For this kind of star, flares cause the star's total luminosity to vary. In fact, astronomers call them flare stars, and they watch as they get much brighter for a while and then dimmer again. We don't pay too much attention to the solar flares of our sun, because the sun is so luminous that the flares are like a little blip. You barely notice them. And remember, we're 93 million miles from the sun, Richard said. With a red dwarf, your planet would have to be much closer to the star. Right. Right, said Gonzalez. The luminosity increase would cause temperature spikes on the surface of an orbiting planet. But just as bad would be the increased particle radiation that would result from the flares. On Earth, we get a very mild effect called the aurora borealis. This is where there's a flare on the sun, the particles eventually reach the Earth, they're funneled down the magnetic field to the north and south poles, and we see the aurora borealis as these beautiful lights in the northern hemisphere. However, particle radiation has the effect of quickly stripping away the atmosphere, increasing the surface radiation levels, but most importantly, destroying the ozone layer, which we need to protect from radiation. All of this would be deadly for any life on a planet near a red dwarf. And then red dwarfs have one more problem: they don't produce much ultraviolet light, which you need early on to build up oxygen in the atmosphere. Scientists believe that the oxygen in the Earth's atmosphere was built up at first by the ultraviolet radiation that broke up water into oxygen and hydrogen. The oxygen was allowed to build up in the atmosphere, while the hydrogen escaped into space, because it's lighter. But you get very little blue light from a red dwarf, so this phenomenon wouldn't occur as rapidly and you wouldn't get the buildup of the oxygen you need to sustain life. Fortunately, our sun is not only the right mass, but it also emits the right colors, a balance of red and blue. As a matter of fact, if we were orbiting a more massive star, called an F-dwarf, there would be much more blue radiation that would build up the oxygen and ozone layer even faster. But any momentary interruption of the ozone layer would subject the planet to an immediate flood of highly intense ultraviolet radiation, which would be disastrous to life. Also, the more massive stars don't live as long. That's the major problem. Stars that are even just a little more massive than the sun live only a few billion years. Our sun is expected to last a total of about 10 billion years on its main sequence, burning hydrogen steadily, whereas stars just a few tens of % more massive have considerably less lifetime on the main sequence. And while on the main sequence, they change luminosity much faster. Everything on their life cycle happens faster. Anything else that makes our sun unusual? I asked. Yes, the sun is metal-rich, in other words, it has a higher abundance of heavy elements compared to other stars of its age in this region of the galaxy. As it turns out, the sun's metallicity may be near the golden mean for building Earth-size habitable terrestrial planets. And the sun is highly stable, more so than most comparable stars. Its light output only varies by 0.1% over a full sunspot cycle, which is about 11 years. This prevents wild climate swings on Earth. Another way it's anomalous is that the sun's orbit is more nearly circular in the galaxy than most other stars of its age. That helps by keeping us away from the galaxy's dangerous spiral arms. If the sun's orbit were more eccentric, we could be exposed to the kind of galactic dangers I mentioned earlier, such as explosions of supernovae. I realized after Gonzalez's comments that I would never look at the bejeweled night sky as I had in the past. I used to see stars as being fungible, which is a legal term meaning one is just as good as the other. But now I understood why the vast majority of stars would be automatically ruled out as being capable of supporting life-bearing planets. It would take a star with the highly unusual properties of our sun _ the right mass, the right light, the right composition, the right distance, the right orbit, the right galaxy, the right location to nurture living organisms on a circling planet. That makes our sun, and our planet, rare indeed. As much as I have been fascinated by the sun, I've also frequently stared in wonder at the other dominant celestial body in our sky, the moon. Curious to find out whether this barren, rocky satellite contributes anything to its host planet other than inspiration for poets and other romantics, I proceeded to turn our discussion toward lunar issues. Our life-supporting moon. Centuries ago, the dark patches on the moon, low-lying areas that had been flooded with basaltic lava, were thought to be oceans that provided life-giving water to its unseen population. They were called Maria, Latin four seas. The name has stuck. To this day, for example, we still refer to Mare Tranquillitatis, or the Sea of Tranquility. Johannes Kepler, the 17th-century astronomer who fanned the flames of the Copernican revolution, gazed at the moon and believed he discerned caves that were populated by moon people. He even wrote a book in which he fantasized about what their lives might be like. A century later, William Herschel, who gained fame by discovering Uranus, thought he made out cities, highways, and pyramids on the lunar landscape. As scientific knowledge grew, dreams of finding lunar civilizations dissipated. Everyone came to agree that the moon cannot support life. Yet surprising discoveries in recent years have shown the opposite to be true. The moon really does support life. Ours. Scientific evidence confirms how this parched, airless satellite actually contributes in unexpected ways to creating a lush and stable environment 250,000 miles away on Earth. When I asked Gonzalez about how the moon helps support life on our planet, the first thing he brought up was a discovery that only dates back to 1993. There was a remarkable finding that the moon actually stabilizes the tilt of the Earth's axis. He said, "The tilt is responsible for our seasons. During the summer, in the northern hemisphere, the North Pole axis is pointed more toward the sun. 6 months later, when the Earth is on the other side of the sun, then the South Pole is more pointed toward the sun. With the Earth's tilt at 23.5 degrees, this gives us very mild seasons. So in a very real way, the stability of our climate is attributable to the moon." What would happen, I asked, if the moon were not there? Then our tilt could swing wildly over a large range, resulting in major temperature swings. If our tilt were more like 90 degrees, the North Pole would be exposed to the sun for 6 months, while the South Pole would be in darkness, then vice versa. Instead, it varies by only about 1.5 degrees, just a tiny variation, because the gravity from the moon's orbit keeps it stabilized. The moon's large size compared to its host planet is unique in the inner solar system, he continued. Mercury and Venus have no moons. Mars has 2 tiny moons, probably captured asteroids, and they don't do anything to stabilize the axis of Mars. Its axis is pretty close to Earth's right now, but that's only by coincidence. It actually varies over a huge range. In fact, all 3 of these planets have chaotic variations in their tilt. The moon also helps in another crucial way, which is to increase our tides. The moon contributes 60% to the tides, the sun accounts for the other 40%. Tides serve an important role by flushing out nutrients from the continents to the oceans, which keeps them more nutrient-rich than they otherwise would be. Scientists discovered just a few years ago that the lunar tides also help to keep large-scale ocean circulation going. That's important because the oceans carry a lot of heat, which is necessary to keep the temperature of the higher latitudes relatively mild. I asked, what if the moon were larger than it is? If it were more massive and in the same place, the tides would be much too strong, which would create serious difficulties. You see, the moon is slowing down the Earth's rotation. The tides pull on the Earth and slow it down a little bit, while at the same time the moon moves out in its orbit. We can actually measure this. Astronauts left mirrors on the moon and astronomers have been bouncing lasers off them since the early 1970s. They've documented that the moon is moving out in its orbit at 3.82 centimeters a year. If the moon were more massive, it would slow down the Earth much more. That would be a problem because if the days became too long, then you could have large temperature differences between day and night. James Casting, a professor of geosciences and meteorology at Pennsylvania State University, has confirmed that Earth's climatic stability is dependent to a large extent on the existence of the moon. Without the moon, he said, the Earth's tilt could vary chaotically from 0 to 85 degrees on a timescale of tens of millions of years, with devastating results. To me, it was amazing enough that the moon just happens to be the right size and in the right place to help create a habitable environment for Earth. Again, it was piling on more and more coincidences that were making it harder to believe mere chance could be responsible for our life-sustaining biosphere. But then casting made one more intriguing observation that adds yet another mind-blowing improbability to already extraordinary circumstances. The moon is now generally believed to have formed as a consequence of a glancing collision with a Mars-sized body during the later stages of the Earth's formation, he said. If such moon-forming collisions are rare, habitable planets might be equally rare. The dangers of a water world. Having explored the moon's contribution to the Earth's life support system, I decided it was time to focus on our planet itself. I had studied enough geology to know that the Earth is more than just an undifferentiated spinning rock, but that its interior is a dynamic and complex system 8,000 miles in diameter, with a solid iron core surrounded by iron that has been rendered liquid by the heat. At its center, where the pressure is more than 3 million times greater than at the planet's surface, temperatures soar to 9,000 degrees Fahrenheit. What, I said to Gonzalez, are some of the phenomena on Earth that contribute to its ability to sustain life? First, let's talk about the Earth's mass, Gonzalez said. A terrestrial planet must have a minimum mass to retain an atmosphere. You need an atmosphere for the free exchange of the chemicals of life and to protect inhabitants from cosmic radiation. And you need an oxygen-rich atmosphere to support big-brained creatures like humans. Earth's atmosphere is 20% oxygen just right, it turns out. And the planet has to be a minimum size to keep the heat from its interior from being lost too quickly. It's the heat from its radioactive decaying interior that drives the critically important mantle convection inside the Earth. If Earth were smaller, like Mars, it would cool down too quickly. In fact, Mars cooled down and basically is dead. What if the Earth were a little more massive than it is? I asked. The bigger the planet, the higher the surface gravity, and the less surface relief between the ocean basins and the mountains, he said. The rocks at the bases of mountains can only withstand so much weight before they fracture. The higher the surface gravity of a planet, the greater the pull of the gravity on the mountains, and the tendency would be toward creating a smooth sphere. Think what would happen if our planet were a smooth sphere. The Earth has a lot of water in its crust. The only reason we're not a water world right now is because we have continents and mountains to rise above it. If you were to smooth out all the land, water would be at a depth of 2 kilometers. You would have a water world, and a water world is a dead world. That perplexed me. If you need water for life, I said, why doesn't more water mean more life? Gonzalez replied, we have life on Earth because we have the energy-rich sunlit surface of the oceans, which is teeming with mineral nutrients. Tides and weathering wash the nutrients from the continents into the oceans, where they feed organisms. In a water world, many of the life-essential minerals would sink to the bottom. That's the basic problem. Besides, the salt concentration in a water world would be prohibitively high. Life can only tolerate a certain level of saltiness. Our oceans and seas are salty, I said. How does Earth manage to regulate this? We have large, marshy areas along some coasts. Because these are shallow, water comes in from the ocean and evaporates quickly, leaving salt behind. So you get huge salt deposits accumulating on the continents, and the salt content of the ocean doesn't get out of control. But in a water world, eventually the excess salt would saturate the water and settle to the bottom. This would create a supersaturated salt solution that would be inhospitable to life. Even so, I said, some scientists have theorized that life might exist inside Jupiter's frozen moon Europa, where a theoretical ocean might be located. It doesn't sound like you think life would be possible in an environment like that, I said. No, I don't think so, he replied. I don't believe it would be habitable. There would be no way to regulate the salt, so I certainly don't imagine there are any dolphins swimming around in there. Mountains and continents, then, are crucial for a life-flourishing planet. But where did they come from? I soon learned that they are partly the product of elaborate choreography involving radioactive elements and plate tectonics, absolutely essential ingredients for any planet to sustain a thriving biosphere. The engine of the Earth. Scientists over the last several decades have established the surprising centrality of plate tectonics, and the related continental drift, to the sustaining of life on Earth. Continental drift refers to the movement of a dozen or more massive plates in the Earth's lithosphere, which is the outer, rigid shell of the planet. One crucial byproduct of plate tectonics is the development of mountain ranges, which are generally created over long periods of time as the plates collide and buckle. Scientists are finding that the importance of plate tectonics is difficult to overstate. It may be, said Ward and Brownlee in Rare Earth, that plate tectonics is the central requirement for life on a planet. Interestingly, they added that of all the planets and moons in our solar system, plate tectonics is found only on Earth. In fact, any heavenly body would need oceans of water as a prerequisite to having plate tectonics, in order to lubricate and facilitate the movement of the plates. When I asked Gonzalez why plate tectonics is so crucial, he launched into describing an improbable series of highly coordinated natural processes that left me amazed once more at how finely tuned our planet really is. Not only does plate tectonics help with the development of continents and mountains, which prevent a water world, but it also drives the Earth's carbon dioxide rock cycle, he said. This is critical in regulating the environment through the balancing of greenhouse gases and keeping the temperature of the planet at a livable level. You see, greenhouse gases, like carbon dioxide, absorb infrared energy and help warm the planet. So they're absolutely crucial. The problem is that their concentration in the atmosphere needs to be regulated as the sun slowly brightens. Otherwise, the Earth would not be able to stabilize its surface temperature, which would be disastrous. Plate tectonics cycles fragments of the Earth's crust including limestone, which is made up of calcium, carbon dioxide, and oxygen atoms down into the mantle. There, the planet's internal heat releases the carbon dioxide, which is then continually vented to the atmosphere through volcanoes. It's quite an elaborate process, but the end result is a kind of thermostat that keeps the greenhouse gases in balance and our surface temperature under control. What's driving plate tectonics is the internal heat generated by radioactive isotopes potassium-40, uranium-235, uranium-238, thorium-232. These elements deep inside the Earth were originally produced in supernovae, and their production in the galaxy is declining with time because the supernova rate is declining with time. That will limit the production of Earth-like planets in the future, because they won't generate as much internal heat as the Earth does. This radioactive decay also helps drive the convection of the liquid iron surrounding the Earth's core, which results in an amazing phenomenon, the creation of a dynamo that actually generates the planet's magnetic field. The magnetic field is crucial to life on Earth, because it shields us from low-energy cosmic rays. If we didn't have a magnetic shield, there would be more dangerous radiation reaching the atmosphere. Also, solar wind particles would directly interact with the upper atmosphere, stripping it away, especially the molecules of hydrogen and oxygen from water. That would be bad news, because water would be lost more quickly. Now, remember how I said that plate tectonics helps regulate global temperatures by balancing greenhouse gases? Well, there's also another natural thermostat, called the Earth's albedo. Albedo refers to the proportion of sunlight a planet reflects. The Earth has an especially rich variety of albedo sources: oceans, polar ice caps, continental interiors, including deserts, which is good for regulating the climate. Whatever light isn't reflected by Earth is absorbed, which means the surface gets heated. This is self-regulated through one of the Earth's natural feedback mechanisms. To give you an example, some marine algae produce dimethyl sulfide. This helps to build cloud condensation nuclei, or CCN, which are small particles in the atmosphere around which water can condense to form cloud droplets. If the ocean gets too warm, then this algae reproduce more quickly and release more dimethyl sulfide, which leads to a greater concentration of CCN and a higher albedo for the marine stratus clouds. Higher cloud albedo, in turn, cools the ocean below, which then reduces the rate at which the algae reproduce. So this provides a natural thermostat. On the other hand, Mars lacks oceans, so it doesn't have this albedo component. It only has deserts, small polar caps, and very thin, occasional clouds. So Mars is far less capable of adjusting its albedo as its more eccentric orbit takes it closer and then further from the Sun. That's one of the reasons why it experiences larger temperature swings than Earth. Giant plates of shifting rock that precariously balance greenhouse gases, decaying radioactive isotopes acting as a life-sustaining underground furnace, an internal dynamo that generates a magnetic field which deflects cosmic dangers, precision feedback loops that unite biology and meteorology. I had to pause and marvel at the complex and interconnected processes that orchestrate our planet's environment. And that was just the beginning. I knew Gonzalez could go on and on about scores of other fine-tuned phenomena. Among them are the elaborate physical processes that resulted in valuable ores being deposited near the planet's surface, enabling them to be efficiently mined for our technological development. Geologist George Brimhall of the University of California at Berkeley has observed, "The creation of ores and their placement close to the Earth's surface are the result of much more than simple geologic chance. Only an exact series of physical and chemical events, occurring in the right environment and sequence and followed by certain climatic conditions, can give rise to a high concentration of these compounds so crucial to the development of civilization and technology." When I took this together with all of the various serendipitous circumstances involving our privileged location in the universe, I was left without a vocabulary to describe my sense of wonder. The suggestion that all of this was based on fortuitous chance had become absurd to me. The telltale signs of design are evident from the far reaches of the Milky Way down to the inner core of our planet. And yet there was more, a whole new dimension of evidence that suggests this astounding world was created, in part, so we could have the adventure of exploring it. The power of an eclipse. The story begins with an unabashed love for solar and lunar eclipses that helped drive a young Guillermo Gonzalez into a lifelong study of stellar mysteries. Mesmerized by the partial eclipses he had witnessed as an amateur astronomer, Gonzalez longed to see the zenith of them all, a total eclipse of the sun, where the moon just barely covers the sun's photosphere. He finally got his chance in 1995. Aware that an eclipse was going to occur on October 24 of that year, he scheduled his research so he could witness the event in northern India, one of the few places where it was going to be fully visible. One thing about eclipses, he told me, is that a seasoned astronomer could be standing next to someone from a remote village, and they would both have tears in their eyes. They're both in awe. At my eclipse camp, as soon as the total phase of the eclipse ended, when you could see the sun's beautiful corona and it was relatively dark, people spontaneously applauded as if rewarding a show. It was just so beautiful. Gonzalez photographed the eclipse and made scientific measurements. But he wasn't done. His mind wouldn't let go of an insight: eclipses are better viewed on Earth than they would be from any other planet in our solar system. There's a striking convergence of rare properties that allow people on Earth to witness perfect solar eclipses, he said. There's no law of physics that would necessitate this. In fact, of the 9 planets with their more than 63 moons in our solar system, the Earth's surface is the best place where observers can witness a total solar eclipse, and that's only possible for the near-term future. What's really amazing is that total eclipses are possible because the sun is 400 times larger than the moon, but it's also 400 times further away. It's that incredible coincidence that creates a perfect match. Because of this configuration, and because the Earth is the innermost planet with a moon, observers on Earth can discern finer details in the sun's chromosphere and corona than from any other planet, which makes these eclipses scientifically rich. What intrigued me, he said, was that the very time and place where perfect solar eclipses appear in our universe also corresponds to the one time and place where there are observers to see them. That coincidence was so fascinating to me that I asked him to repeat his last statement before we continued. After he did, he added, "What's more, perfect solar eclipses have resulted in important scientific discoveries that would have been difficult if not impossible elsewhere, where eclipses don't happen." "What discoveries?" I asked. "I'll give you just 3 examples," he said. First, perfect solar eclipses helped us learn about the nature of stars. Using spectroscopes, astronomers learned how the sun's color spectrum is produced, and that data helped them later interpret the spectra of distant stars. Second, a perfect solar eclipse in 1919 helped 2 teams of astronomers confirm the fact that gravity bends light, which was a prediction of Einstein's general theory of relativity. That test was only possible during a total solar eclipse, and it led to general acceptance of Einstein's theory. Third, perfect eclipses provided a historical record that has enabled astronomers to calculate the change in the Earth's rotation over the past several thousand years. This enabled us to put ancient calendars on our modem calendar system, which was very significant. Richards, who had been listening intently, spoke up. "What's mysterious," he said, "is that the same conditions that give us a habitable planet also make our location so wonderful for scientific measurement and discovery. So we say there's a correlation between habitability and measurability. Not only does the specific configuration of the Earth, Sun, and Moon allow for perfect eclipses, but that same configuration is also vital to sustaining life on Earth. We've already discussed how the size and location of the Moon stabilizes our tilt and increases our tides, and how the size of the Sun and our distance from it also make life possible here. Our main point," he concluded, "is that there's no obvious reason to assume that the very same rare properties that allow for our existence would also provide the best overall setting to make discoveries about the world around us. In fact, we believe that the conditions for making scientific discoveries on Earth are so fine-tuned that you would need a great amount of faith to attribute them to mere chance." 1. Habitability and measurability. Prompted by the study of perfect solar eclipses, Gonzalez and Richards began to investigate the incredible convergence of habitability and measurability in scores of other settings. They came up with a wide range of examples that merely served to amplify their amazement. "For example," said Gonzalez, "not only do we inhabit a location in the Milky Way that's fortuitously optimal for life, but our location also happens to provide us with the best overall platform for making a diverse range of discoveries for astronomers and cosmologists. Our location away from the galaxy's center and in the flat plane of the disk provides us with a particularly privileged vantage point for observing both nearby and distant stars. We're also in an excellent position to detect the cosmic background radiation, which is critically important because it helped us realize our universe had a beginning in the Big Bang. The background radiation contains invaluable information about the properties of the universe when it was only about 300,000 years old. There's no other way of getting that data. And if we were elsewhere in the galaxy, our ability to detect it would have been greatly hindered." Richards offered a few other illustrations. "The Moon stabilizes the Earth's tilt, which gives us a livable climate, and it also consistently preserves the deep snow deposits in the polar regions. These deposits are a tremendously valuable data recorder for scientists," he said. "By taking core samples from the ice, researchers can gather data going back hundreds of thousands of years. Ice cores can tell us about the history of snowfall, temperatures, winds near the polar regions, and the amount of volcanic dust, methane, and carbon dioxide in the atmosphere. They record the sunspot cycle through variations in the concentration of beryllium-10. They even record the temporary weakening of the Earth's magnetic field 40,000 years ago. In 1979, scientists identified a tentative link between nitrate spikes in an Antarctic ice core with nearby supernovae. By taking deeper cores, it might be possible to catalog all nearby supernovae of the last few 100,000 years, something that would be otherwise impossible." Another example of the strange correlation between habitability and measurability, Richards said, is the clarity of our atmosphere. "The metabolisms of higher organisms require from 10 to 20% oxygen in the atmosphere, which is also the amount needed to facilitate fire, allowing for the development of technology," Richards said. "But it just so happens that the very composition of our atmosphere also gives it transparency, which it wouldn't have if it were rich in carbon-containing atoms, like methane. And a transparent atmosphere allows the science of astronomy and cosmology to flourish." "Wait a second," I said. "Doesn't the water vapor in our atmosphere cause cloudiness that can hinder astronomy? That's why putting a telescope in space has been such a breakthrough. Actually, astronomers prefer a partly cloudy atmosphere to one that's completely cloudy or always windy and dusty," Gonzalez said. "Besides, we're not saying that every condition of measurability is uniquely and individually optimized on Earth. Our argument depends on what's called an optimal negotiation of competing conditions. As Henry Petrosky said in his book Invention by Design, all design involves conflicting objectives and hence compromise, and the best designs will always be those that come up with the best compromise. To come up with discoveries in a wide range of scientific disciplines, our environment must be a good compromise of competing factors, and we find that it is. Another interesting connection between habitability and measurability involves plate tectonics. As Gonzalez and Richards explained earlier, plate tectonics is essential to having a livable planet. One byproduct of the movement of these crustal plates is earthquakes, which, in turn, have provided scientists with research data that would otherwise be difficult to obtain. Thousands of seismographs all over the planet have measured earthquakes through the years, Richards said. In the past few decades, scientists have been able to use the data to produce a three-dimensional map of the structure of the Earth's interior. Over and over again, he said, the extraordinary conditions that create a hospitable environment on Earth also happen to make our planet strangely well-suited for viewing, analyzing, and understanding the universe. Is that merely some sort of cosmic quirk? Richards asked. Are we just lucky? I think wisdom entails the ability to discern the difference between mere coincidence and a meaningful pattern. We have more than a coincidence here. Much more. The trilemma of life. When trying to explain the existence of life, said Gonzalez and Richards, we face a trilemma. One possibility is that some natural necessity, like the laws of physics, inexorably leads to life. Advocates of SETI the search for extraterrestrial intelligence like that possibility. However, more and more scientific discoveries are showing how incredibly improbable it is to marshal the right conditions for life. Many scientists are concluding that intelligent life is, at minimum, far rarer than was once thought. In fact, it may very well be unique to Earth. The second possible explanation is chance. Life is a fluke. Create enough planets circling enough stars and the odds say at least one of them will have life. Brownlee and Ward, who wrote Rare Earth, seem to gravitate toward this explanation. But there's also a third possibility: life was created. After studying all of the extraordinarily rare circumstances that have contributed to life on Earth, and then overlaying the amazing way in which these conditions also open the door to scientific discoveries, Gonzalez and Richards have landed in this camp. To find that we have a universe where the very places where we find observers are also the very best overall places for observing, that's surprising, Richards said. I see design not just in the rarity of life in the universe, but also in this very pattern of habitability and measurability. I turned toward Gonzalez. What's your conclusion? I asked. My conclusion, frankly, is that the universe was designed for observers living in places where they can make scientific discoveries, he replied. There may be other purposes to the universe, but at least we know that scientific discovery was one of them. Ever the theologian, Richards jumped back in. In the Christian tradition, this is quite at home, he said. Christians have always believed that God testifies to his existence through the book of nature and the book of Scripture. In the 19th century, science effectively closed the book of nature. But now, new scientific discoveries are reopening it. But if the universe was designed with us in mind, why is it so incredibly vast? I asked. There's a lot of empty space out there. Isn't that wasteful and unnecessary? Because the universe was designed for discovery, we need something to discover. Richards replied. The universe is vast and we're small, but we have access to it. That's what is amazing. We can see background radiation that has come from more than 10 billion light-years away. Plus, added Gonzalez, we needed supernovae to build up the heavy elements so life-bearing planets could develop. And one particular type of supernovae is incredibly useful as a standard candle. Type La supernovae have calibratable luminosities so we can use them to determine distances and to probe the expansion history of the universe. So, again, we see the connection between habitability and measurability. Richards made one other interesting observation. Darwin once complained that pollen couldn't have been designed. After all, he said, look at the waste. Millions upon millions of particles are produced, but very, very few are used in the development of flowers. However, what he didn't realize was that pollen is one of the most useful tools we have in the scientific exploration of the past, in part, because it can be dated through carbon-14. When we find pollen in lake sediments and ice cores, we can use it to gauge how old the layered deposits are and what the ancient climate was like. Darwin only looked at pollen from a biological standpoint. When we look at the big picture, we see it has another use he never anticipated. Perhaps the same is true in many other instances throughout the universe. A cherished group of creatures. I pushed my chair back from the table as if I had just consumed a hearty meal. In a sense, I had. Gonzalez and Richards had served me a remarkable feast, fact upon fact, evidence upon evidence, discovery upon discovery that compelled an incredible conclusion. As I sat there and digested the data, my mind turned to the book God and the Astronomers, which I had been reading on the airplane just prior to our interview. In one chapter, John A. O'Keefe describes how he went away to school at the age of 14 and began to get into arguments with his roommate about God. These encounters turned him toward astronomy, a field where scientists were beginning to find new and exciting evidence about the possibility of a creator. After earning degrees from Harvard and the University of Chicago, O'Keefe went on to become a renowned astronomer and pioneer in space research. The late Eugene Shoemaker called him the godfather of astrogeology. He was awarded many honors, including the Goddard Space Flight Center's highest award, and is credited with numerous breakthrough discoveries in his scientific research at NASA. It was the discoveries of astronomy that bolstered O'Keefe's faith in God. He once ran calculations estimating the likelihood of the right conditions for life existing elsewhere. He concluded that if his assumptions were correct, then based on the mathematical probabilities, only one planet in the universe is likely to bear intelligent life. We know of one, the Earth, but it is not certain that there are many others, and perhaps there are no others. O'Keefe said he would have no theological problem if, indeed, other civilizations existed. That's the position of many Christians. God certainly could have created other life-populated planets that the Bible doesn't reveal. But it was the sheer improbability of the coincidences that conspired to create life on Earth that led O'Keefe to this conclusion: we are, by astronomical standards, a pampered, cassette, cherished group of creatures. Our Darwinian claim to have done it all ourselves is as ridiculous and as charming as a baby's brave efforts to stand on its own feet and refuse his mother hand. If the universe had not been made with the most exacting precision, we could never have come into existence. It is view that these circumstances indicate the universe was created for man to live in, and for humankind to explore. The findings of Gonzalez and Richards that the cosmos was designed for discovery have added a compelling new dimension to the evidence for a creator. And frankly, their analysis makes sense. If God so precisely and carefully and lovingly and amazingly constructed a mind-boggling habitat for his creatures, then it would be natural for him to want them to explore it, to measure it, to investigate it, to appreciate it, to be inspired by it, and ultimately, and most importantly, to find him through it. Chapter 8. The Evidence of Biochemistry, the Complexity of Molecular Machines. We have always underestimated the cell. The entire cell can be viewed as a factory that contains an elaborate network of interlocking assembly lines, each of which is composed of a set of large protein machines. Why do we call them machines? Precisely because, like machines invented by humans to deal efficiently with the macroscopic world, these protein assemblies contain highly coordinated moving parts. Bruce Alberts, President, National Academy of Sciences. We should reject, as a matter of principle, the substitution of intelligent design for the dialogue of chance and necessity, but we must concede that there are presently no detailed Darwinian accounts of the evolution of any biochemical system, only a variety of wishful speculations. Biochemist Franklin M. Harold. Michael B. was taught in parochial school that God had set up the universe, knew what was going to happen, and intended for life to come into existence, but from our perspective the entire process unfolded through Darwinian evolution. And that pretty much satisfied the young B. Later, as a student in biochemistry, when B would encounter enormously complicated biological systems, his response was to scratch his head and say, "Gee, I wonder how evolution created that." Well, somebody must know. He always moved on, assuming someone did. Then one day, while doing postdoctorate research on DNA at the National Institutes of Health, he and a colleague were pondering what it would take for life to begin by naturalistic processes. As they enumerated the components that would be needed, proteins, a genetic code, a membrane, and so on, they looked at each other and said, "Nah." They knew there was no way life could have sprung into existence unaided. Seeds of skepticism were planted. Subsequently, he read geneticist Michael Denton's groundbreaking book Evolution, A Theory in Crisis. For the first time, B was exposed to a well-reasoned scientific critique of Darwinism, and he was astounded. Until then, he only knew of religious nuts who doubted Darwin. Now, here was a thoughtful, agnostic scientist who was powerfully challenging whether Darwin's mechanism of natural selection could really explain how life started and developed through the ages. Spurred on by Denton's book, B began scouring the scientific literature in search of the detailed Darwinian explanations he had always assumed were there. Time after time, he found scientists describing complex, interlocking biological systems and basically saying, "Isn't it wonderful how natural selection put this together?" The how was always missing. That's when B realized that as a biochemist, he was perfectly situated to investigate whether the evidence points toward Darwinism or God as the source for living organisms. After all, life is essentially a molecular phenomenon. If Darwinian evolution is going to work, it has to succeed at the microscopic level of amino acids, proteins, and DNA. On the other hand, if there really was a designer of the world, then his fingerprints were going to be all over the cell. And the cell is B's world, an incredible, intricate, Lilliputian world where a typical cell takes 10 million atoms to build. One scientist described a single-cell organism as a high-tech factory, complete with artificial languages and their decoding systems, memory banks for information storage and retrieval, elegant control systems regulating the automated assembly of parts and components, error failsafe and proofreading devices utilized for quality control, assembly processes involving the principle of prefabrication and modular construction. And a capacity not equaled in any of our own most advanced machines, for it would be capable of replicating its entire structure within a matter of a few hours. Shaking off his preconceptions as best he could, B began to scrutinize the molecular evidence with new eyes. Ultimately, he would summarize his stunning conclusions in what the National Review would call one of the most important non-fiction books of the 20th century. Interview number 6, Michael J. Behe, Ph.D. Lehigh University's Mountaintop Campus, a 72-acre, 8-building research complex overlooking the hardscrabble city of Bethlehem, Pennsylvania, was littered with brown, brittle leaves when I arrived one autumn afternoon in my search for Michael B. After parking in front of Iacocca Hall, a modern, tan and green glass building, I walked up to the second floor. I strolled down a long hallway with laboratories on both sides: the complex carbohydrate research lab, the core chromatography/electrophoresis lab, the molecular microbiology research lab, the neuroendocrinology lab, the core DNA lab, and the ominous-sounding virology lab, with an orange biohazard sign plastered on its door. The hallway's wall featured scintillating reading an oversized reproduction of a technical article by 2 Lehigh scientists, asking the provocative question, how does testosterone affect hippocampal plasticity in black-capped chickadees? I knocked on the door of a nondescript office and was greeted cheerfully by B, dressed in blue jeans and a lumberjack shirt. He's enthusiastic, energetic, and engaging, with a quick smile and a crackling sense of humor. He always seems to be moving. Even when perched on his swivel chair, he would roll back and forth ever so slightly. Wiry and balding, with wispy gray hair, a beard, and round glasses, he has a gentle and self-effacing manner that tends to put visitors at ease. B credits his casual manner to being the father of 8, at the time, going on 9, children, who keep him from taking himself too seriously. He laughed when I asked if he had any hobbies. Mostly, I drive kids places, he said. B grew up on the other side of Pennsylvania. He received a degree in chemistry with honors from Drexel University and a doctorate in biochemistry at the University of Pennsylvania. After postdoctorate research at the University of Pennsylvania and the National Institutes of Health, he joined Lehigh's faculty in 1985. He also has served on the Molecular Biochemistry Review Panel of the Division of Molecular and Cellular Biosciences at the National Science Foundation. He has authored 40 articles for such scientific journals as DNA Sequence, the Journal of Molecular Biology, Nucleic Acids Research, Biopolymers, Proceedings of the National Academy of Sciences USA, Biophysics, and Biochemistry. He has lectured at the Mayo Clinic and dozens of schools, including Yale, Carnegie Mellon, the University of Aberdeen, Temple, Colgate, Notre Dame, and Princeton. He is a member of the American Society for Biochemistry and Molecular Biology, the Society for Molecular Biology and Evolution, and other professional organizations. Bede has contributed to several books, including Mere Creation, Signs of Intelligence, and Creation and Evolution. He was catapulted into the national spotlight, however, by his enigmatically titled and award-winning bestseller, Darwin's Black Box. According to David Berlinski, author of A Tour of the Calculus, Bede's book makes an overwhelming case against Darwin on the biochemical level through an argument of great originality, elegance, and intellectual power. Added Berlinski, no one has done this before. In fact, it was this book that lured me to Lehigh. I knew that Bede's theories could provide strong support for the idea that a designer created the tiny but complex molecular machines that drive the cellular world, that is, if his arguments could withstand the objections of skeptical Darwinists. Peering inside the black box. The black box in the title of Bede's book is a term scientists use when describing a system or machine that they find interesting but they don't know how it works. As an example, Bede gestured toward the Dell computer on his desk. A computer is a black box for most people, he explained. You type on the keyboard and you can do word processing or play electronic games, but most of us don't have the foggiest idea of how the computer actually works. And to Darwin, the cell was a black box, I commented. That's right, he replied. In Darwin's day, scientists could see the cell under a microscope, but it looked like a little glob of jello, with a dark spot as the nucleus. The cell could do interesting things, it could divide, it could move around, but they didn't know how it did anything. There must have been speculation, I said. Of course, Beale said. Electricity was a big deal back then, and some believed that all you had to do was to zap some gelatinous material and it would come alive. Most scientists speculated that the deeper they delved into the cell, the more simplicity they would find. But the opposite happened. Now we've probed to the bottom of life, so to speak. We're at the level of molecules and there's complexity all the way down. We've learned the cell is horrendously complicated, and that it's actually run by micromachines of the right shape, the right strength, and the right interactions. The existence of these machines challenges a test that Darwin himself provided. A test? A test? I asked. Darwin said in his Origin of Species, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous, successive, slight modifications, my theory would absolutely break down. And that was the basis for my concept of irreducible complexity. You see, a system or device is irreducibly complex if it has a number of different components that all work together to accomplish the task of the system, and if you were to remove one of the components, the system would no longer function. An irreducibly complex system is highly unlikely to be built piece by piece through Darwinian processes, because the system has to be fully present in order for it to function. The illustration I like to use is a mousetrap. I chuckled. Do you have problems with mice at your house? Actually, yes, we do, he said with a laugh. But a mousetrap has turned out to be a great example. He stood and walked over to a filing cabinet, removing a run-of-the-mill mousetrap and putting it down on the desk next to me. You can see the interdependence of the parts for yourself, he said, pointing to each component as he described them. First, there's a flat wooden platform to which the other parts are attached. Second, there's a metal hammer, which does the job of crushing the mouse. Third, there's a spring with extended ends to press against the platform and the hammer when the trap is charged. Fourth, there's a catch that releases when a mouse applies a slight bit of pressure. And, fifth, there's a metal bar that connects to the catch and holds the hammer back when the trap is charged. Now, if you take away any of these parts, the spring or the holding bar or whatever, then it's not like the mousetrap becomes half as efficient as it used to be, or it only catches half as many mice. Instead, it doesn't catch any mice. It's broken. It doesn't work at all. He pointed down at the trap again. And notice that you don't just need to have these 5 parts, but they also have to be matched to each other and have the right spatial relationship to each other. See, the parts are stapled in the right place. An intelligent agent does that for a mousetrap. But in the cell, who tells the parts where they should go? Who staples them together? Nobody. They have to do it on their own. You have to have the information resident in the system to tell the components to get together in the right orientation, otherwise it's useless. BS sat back down. So the Mousetrap does a good job of illustrating how irreducibly complex biological systems defy a Darwinian explanation, he continued. Evolution can't produce an irreducibly complex biological machine suddenly, all at once, because it's much too complicated. The odds against that would be prohibitive. And you can't produce it directly by numerous, successive, slight modifications of a precursor system, because any precursor system would be missing a part and consequently couldn't function. There would be no reason for it to exist. And natural selection chooses systems that are already working. I studied the Mousetrap. You said an irreducibly complex system can't be produced directly by numerous, successive, slight modifications, I said. Does that mean there couldn't be an indirect route? B shook his head. You can't absolutely rule out all theoretical possibilities of a gradual, circuitous route, he said. But the more complex the interacting system, the far less likely an indirect route can account for it. And as we discover more and more of these irreducibly complex biological systems, we can be more and more confident that we've met Darwin's criterion of failure. I asked, are there a lot of different kinds of biological machines at the cellular level? Life is actually based on molecular machines, he replied. They haul cargo from one place in the cell to another, they turn cellular switches on and off, they act as pulleys and cables, electrical machines let current flow through nerves, manufacturing machines build other machines, solar-powered machines capture the energy from light and store it in chemicals. Molecular machinery lets cells move, reproduce, and process food. In fact, every part of the cell's function is controlled by complex, highly calibrated machines. B motioned toward the Mousetrap. And if the creation of a simple device like this requires intelligent design, he said, then we have to ask, what about the finely tuned machines of the cellular world? If evolution can't adequately explain them, then scientists should be free to consider other alternatives. Before I began investigating that issue any further, though, I wanted to stay focused a while longer on B's whimsical use of the Mousetrap to illustrate irreducible complexity. Ever since Darwin's Black Box was published, the lowly rodent catcher has become something of a new icon in the debate over evolution versus design. As such, it has been pelted by opposition from Darwinists, and I needed to know if B could fend off the best challenges. Messing with the Mousetrap. Your Mousetrap has generated quite a bit of controversy, I began. For instance, John MacDonald of the University of Delaware said mousetraps can work well with fewer parts than yours, and he even drew a picture of a trap that's simpler than the one you drew. Doesn't this undermine your point that your mousetrap is irreducibly complex? No, not a bit, he said with a good-natured smile. I agree there are mousetraps with fewer parts than mine. As a matter of fact, I said so in my book. I said you can just prop open a box with a stick, or you can use a glue trap, or you can dig a hole for the mouse to fall into, or you can do any number of things. The point of irreducible complexity is not that one can't make some other system that could work in a different way with fewer parts. The point is that the trap we're considering right now needs all of its parts to function. The challenge to Darwinian gradualism is to get to my trap by means of numerous, successive, slight modifications. You can't do it. Besides, you're using your intelligence as you try. Remember, the audacious claim of Darwinian evolution is that it can put together complex systems with no intelligence at all. B's simple explanation seemed sufficient to defeat MacDonald's critique, but there was a stronger challenge to consider. I reached down into my briefcase and removed a copy of Natural History magazine. Kenneth Miller of Brown University has another objection to your trap, I said. Then I read him Miller's comments. Take away two parts, the catch and the metal bar, and you may not have a mousetrap, but you do have a three-part machine that makes a fully functional tie clip or paper clip. Take away the spring, and you have a two-part keychain. The catch of some mousetraps could be used as a fishhook, and the wooden base as a paperweight. Useful applications of other parts include everything from toothpicks to nutcrackers and clipboard holders. The point, which science has long understood, is that bits and pieces of supposedly irreducibly complex machines may have different but still useful functions. That's a strong point, I said. Maybe an irreducibly complex system could develop gradually over time, because each of its components could have another function that natural selection would preserve on the way toward developing a more argument, he said. I leaned forward. Doesn't this dismantle your case? I asked. Biad didn't flinch. The problem, he replied, is that it's not an argument against anything I've ever said. In my book, I explicitly point out that some of the components of biochemical machines can have other functions. But the issue remains, can you use numerous, slight, successive modifications to get from those other functions to where we are? Some of this objection seems a bit silly. Could a component of a mousetrap function as a paperweight? Well, what do you need to be a paperweight? You need mass. You need to exist. An elephant, or my computer, or a stick can be a paperweight. But suppose you go buy a paperweight. What would it look like? Most of them are nondescript, roundish things. None of them look anything like a precursor to a mousetrap. Besides, look at what he's doing. He's starting from the finished product, the mousetrap, and disassembling it and moving a few things around to use them for other purposes. Again, that's intelligent design. The question for evolution is not whether you can take a mousetrap and use its parts for something else, it's whether you can start with something else and make it into a mousetrap. The problem for evolutionists is to start with a less complex system and build a more complex system. Even if every component could theoretically have a useful function prior to its assembly into the mousetrap, you'd still have the problem of how the mousetrap becomes assembled. Explain further, I said. When people put together a mousetrap, they have the disassembled components in different drawers or something, and they grab one from each drawer and put it together. But in the cell, there's nobody there to do that. In molecular machines, components have portions of their shape that are complementary to each other, so they connect with each other in the right way. A positive charge can attract a negative charge, and an oily region can attract another oily region. So if we use the mousetrap as an analogy, one end of the spring would have to have a certain shape or magnetism that just happened to attract and fit with another component of the trap. They'd all have to fit together that way until you had the whole trap assembled by itself. In other words, if you just had the components themselves without the ability to bring the other pieces into position, you'd be far from having a functioning mousetrap. Nobody ever addresses this problem in the evolutionary literature. If you do any calculations about how likely this could occur by itself, you find it's very improbable. Even with small machines, you wouldn't expect them to self-assemble during the entire lifetime of the Earth. That's a severe problem that evolutionists don't like to address. The amazing, moving psyllium. The mousetrap emerged unscathed. But of course, it was only intended to be an illustration to help people understand irreducibly complex cellular systems. I decided to press forward by asking about some specific examples of molecular machines to see whether they could have developed by the step-by-step evolutionary process envisioned by Darwin. When I asked B for a specimen of irreducible complexity, he quickly cited the psyllium. Cilia are whip-like hairs on the surface of cells. If the cell is stationary, the cilia move fluid across the cell's surface. For instance, he said, pointing toward my throat, you've got cilia lining your respiratory tract. Every cell has about 200 of them, and they beat in synchrony in order to sweep mucus toward your throat for elimination. That's how your body expels little foreign particles that you accidentally inhale. But cilia also have another function. If the cell is mobile, the cilia can row it through a fluid. Sperm cells would be an example. They're propelled forward by the rowing action of cilia. That sounds fairly simple, I remarked. That's what scientists used to think when they examined cilia under a light microscope. They just looked like little hairs. But now that we have electron microscopes, we've found that cilia are, in fact, quite complicated molecular machines. Think about it, most hairs don't beat back and forth. What enables cilia to do this? Well, it turns out a psyllium is made up of about 200 protein parts. How does it function? He smiled. I'll try to keep this basic, he said. There are 9 pairs of microtubules, which are long, thin, flexible rods, which encircle 2 single microtubules. The outer microtubules are connected to each other by what are called necks and linkers. And each microtubule has a motor protein called dynein. The motor protein attaches to one microtubule and has an arm that reaches over, grabs the other one, and pushes it down. So the two rods start to slide lengthwise with respect to each other. As they start to slide, the necks and linkers, which were originally like loose rope, get stretched and become taut. As the dynein pushes farther and farther, it starts to bend the apparatus, then it pushes the other way and bends it back. That's how you get the rowing motion of the cilium. That doesn't begin to do justice to the complexity of the cilium. But my point is that these three parts, the rods, linkers, and motors, are necessary to convert a sliding motion into a bending motion so the cilium can move. If it weren't for the linkers, everything would fall apart when the sliding motion began. If it weren't for the motor protein, it wouldn't move at all. If it weren't for the rods, there would be nothing to move. So like the mousetrap, the cilium is irreducibly complex. Why can't Darwinian evolution account for that? You only get the motion of the cilium when you've got everything together. None of the individual parts can do the trick by themselves. You need them all in place. For evolution to account for that, you would have to imagine how this could develop gradually, but nobody has been able to do that. I ventured a possibility. Maybe these three components were being used for other purposes in the cell and eventually came together for this new function, I said. For instance, microtubules look a bit like girders. Maybe they were used in the structure of primitive cells. Or maybe they formed the cellular highways along which the motor proteins moved material within the cell. Belay didn't look impressed. A motor protein that has been transporting cargo along a cellular highway might not have the strength necessary to push two microtubules relative to each other. He replied. A necks and linker would have to be exactly the right size before it was useful at all. Creating the cilium inside the cell would be counterproductive, it would need to extend from the cell. The necessary components would have to come together at the right place at the right time, even assuming they were all pre-existing in the cell. Isn't it possible that they might all come together by chance? I asked. It's extraordinarily improbable, he replied. Let me illustrate it for you. Say there are 10,000 proteins in a cell. Now, imagine you live in a town of 10,000 people, and everyone goes to the county fair at the same time. Just for fun, everyone is wearing blindfolds and is not allowed to speak. There are two other people named Lee, and your job is to link hands with them. What are the odds that you could go grab two people at random and create a link of Lees? Pretty slim. In fact, it gets worse. In the cell, the mutation rate is extremely low. In our analogy, that would mean you could only change partners at the county fair one time a year. So you link with two other people, sorry, they're not the other Lees. Next year, you link with two other people. Sorry, no Lees again. How long would it take you to link with the other Lees? A very long time, and the same is true in the cell. It would take an enormous amount of time, a prohibitive amount of time even, to get three proteins together. To make it even more difficult, a recent study in Science magazine found that half the proteins in a simple yeast cell don't function alone, but they function as complexes of half a dozen proteins or more. Up to 50 proteins are stuck together like cogs in a machine. Of the other 50%, most are in complexes of 3 or 4. Very few work as single, Lone Ranger proteins. So this is a huge problem not only in cilia but in other cells too. Some scientists have pointed out that there are examples of other cilia that don't have some of the parts that you contend are essential, I said. One said, in nature, we can find scores of cilia lacking one or more of the components supposedly essential to the function of the apparatus. Doesn't the existence of simpler cilia refute your contention that they are irreducibly complex? If you could point to a series of less complex structures that progress from one to the other in order to create the cilia I've described, then, yes, that would refute me. But that isn't the case, he said. What the critics say is that you can take away one of the several microtubules and the cilium would still function. That's fine. You still need all the basic components: microtubules, nexon, and dynein. Let me give you an analogy. Some big mousetraps their rat traps have double springs to make them stronger. You can take one spring away and it would still work to a degree. In a sense, the second spring is a redundant component. The cilium is the same way, it's got some redundant components. You can take one of the microtubules away and it will still function, though maybe not as well. But evolution does not start with the completed trap or completed cilium and take parts away, it has to build things up from the bottom. And all cilia have the three critical components that I've mentioned. There have been experiments where scientists have removed one of the three and the cilium doesn't work. It's broken just like you'd expect it to be, since it's an irreducibly complex machine. The world's most efficient motor. As amazing as the cilium is, I was even more fascinated by another biological machine for propelling cells: the bacterial flagellum. While cilia act like oars to move cells, it was discovered in 1973 that the flagellum performs like a rotary propeller, Behu explained. Only bacteria have them. How does it work? I asked. Extremely efficiently, he said. Just picture an outboard motor on a boat and you get a pretty good idea of how the flagellum functions, only the flagellum is far more incredible. The flagellum's propeller is long and whip-like, made out of a protein called flagellin. This is attached to a drive shaft by hook protein, which acts as a universal joint, allowing the propeller and drive shaft to rotate freely. Several types of proteins act as bushing material to allow the drive shaft to penetrate the bacterial wall and attach to the rotary motor. Where does it get its energy? I asked. That's an interesting phenomenon, he replied. Some other biological systems that generate movement, like muscles, use energy that has been stored in what's called a carrier molecule. But the flagellum uses another system: energy generated by a flow of acid through the bacterial membrane. This is a complex process that scientists are still studying and trying to understand. The whole system works really well. The flagellum's propeller can spin at 10,000 revolutions per minute. As a car aficionado, I was staggered by that statistic. A friend had recently given me a ride in his exotic high-performance sports car, and I knew it wasn't capable of generating that many RPMs. Even the notoriously high-revving Honda Yes 2000, with a state-of-the-art, 4-cylinder, 2-liter, dual-overhead cam aluminum block engine, featuring 4 valves per cylinder and variable intake and exhaust valve timing, has a redline of only 9,000 RPMs. Not only that, Beef continued, but the propeller can stop spinning within a quarter turn and instantly start spinning the other way at 10,000 RPMs. Howard Berg of Harvard University called it the most efficient motor in the universe. It's way beyond anything we can make, especially when you consider its size. How small is it? A flagellum is on the order of a couple of microns. A micron is about 1/20,000 of an inch. Most of its length is the propeller. The motor itself would be maybe 1/100,000 ths of an inch. Even with all of our technology, we can't even begin to create something like this. Sometimes in my lectures I show a drawing of the flagellum from a biochemistry textbook, and people say it looks like something from NASA. If you think about it, we've discovered machines inside ourselves. On Star Trek they had a creature called the Borg, which has tiny machines inside. Well, it turns out everybody does. Drawings of the flagellum are, indeed, very impressive, since they look uncannily like a machine that human beings would construct. I remember a scientist telling me about his father, an accomplished engineer who was highly skeptical about claims of intelligent design. The dad could never understand why his son was so convinced that the world had been designed by an intelligent agent. One day the scientist put a drawing of the bacterial flagellum in front of him. Fascinated, the engineer studied it silently for a while, then looked up and said to his son with a sense of wonder, "Oh, now I get what you've been saying." Think of this too, Bia continued. Imagine a boat with its motor running. Oh. Nobody's steering it. It goes out and crashes, boom. Well, who's steering the bacterial cell? It turns out it has sensory systems that feed into the bacteria flagellum and tell it when to turn on and when to turn off, so that it guides it to food, light, or whatever it's seeking. In a sense, it's like those smart missiles that have guidance systems to help them find their target, except there's no explosion at the end.
And the flagellum is irreducibly complex?
That's right, he said. Genetic studies have shown that between 30 and 35 proteins are needed to create a functional flagellum. I haven't even begun to describe all of its complexities, we don't even know the roles of all its proteins. But at a minimum you need at least 3 parts: a paddle, a rotor, and a motor that are made up of various proteins. Eliminate one of those parts and you don't get a flagellum that only spins at 5,000 rpms, you get a flagellum that simply doesn't work at all.
So it's irreducibly complex and a huge stumbling block to Darwinian theory.
I asked, has anyone been able to propose a step-by-step evolutionary explanation of how a gradual process could have yielded a flagellum? In a word, no, he said with a chuckle. For most irreducibly complex systems, the best you get is a sort of hand-waving, cartoonish explanation, but certainly nothing that approaches being realistic. Even evolutionary biologist Andrew Pomiankowski admitted, pick up any biochemistry textbook, and you will find perhaps 2 or 3 references to evolution. Turn to one of these and you will be lucky to find anything better than evolution selects the fittest molecules for their biological function.
But for the flagellum, there aren't even any cartoon explanations.
The best the Darwinists have been able to muster is to say that the flagellum has components that look like the components of other systems that don't have as many parts, so maybe somehow this other system had something to do with the flagellum. Nobody knows where this subsystem came from in the first place, or how or why the subsystem may have turned into a flagellum. So, no, there's no reasoned explanation anyone has been able to offer. I tried another approach. What about Darwinists who say, maybe it's merely too early for us to come up with a roadmap of how these gradual changes developed? Someday we'll better understand the flagellum, so have patience. In the end, science is going to figure it out.
Biel leaned back in his chair.
You know, Darwinists always accuse folks in the intelligent design movement of making an argument from ignorance.
Well, that's a pure argument from ignorance.
They're saying, we have no idea how this could have happened, but let's assume evolution somehow did it.
You've heard of God off the gaps inserting God when you don't have another explanation? Well, this is evolution of the gaps. Some scientists merely insert evolution when they don't understand something.
Look, we may not understand everything about these biological systems, but we do know some things. We do know that these systems have a number of very specifically matched components that do not lend themselves to a gradualistic explanation. We know that intelligence can assemble complex systems, like computers and mousetraps and things like that. The complexity we see is not going to be alleviated by the more we learn, it can only get more complicated.
We will only discover more details about the systems. Here's an illustration. Let's say you have a car in a dark garage.
You shine a flashlight on one part of the engine and you see all of its components and its obvious complexity.
Shining the flashlight on another part of the motor isn't going to make the first part go away.
It isn't going to make the problem any simpler, it's going to make it more complicated. And as we discover more about the flagellum, it won't negate the complexity we've already found. All we'll have is an even more complicated, more impressive, more interdependent machine and an even greater challenge to Darwinian theory.
Molecular trucks and highways.
According to B, the psyllium and bacterial flagellum are just the beginning of the Darwin-defying complexity in the microscopic world of the cell.
One of his other favorites is the intracellular transport system.
The cell is not a simple bag of soup, with everything sloshing around, he said.
Instead, eukaryotic cells of all organisms except bacteria have a number of compartments, sort of like rooms in a house.
There's the nucleus, where the DNA resides, the mitochondria, which produce energy, the endoplasmic reticulum, which processes proteins, the Golgi apparatus, which is a way station for proteins that are being transported elsewhere, the lysosome, which is a garbage disposal unit. Secretory vesicles, which store cargo before it's sent out of the cell, and the peroxisome, which helps metabolize fats. Each compartment is sealed off by a membrane, just like a room has walls and a door. In fact, the mitochondrion has 4 separate sections.
Counting everything, there are more than 20 different sections in each cell.
Cells are constantly getting rid of old stuff and manufacturing new components, and these components are designed to work in one room but not others. Most new components are made at a central location in the cell on things called ribosomes. Denton has described the ribosome, a collection of some 50 large molecules containing more than 1 million atoms, as an automated factory that can synthesize any protein that it is instructed to make by DNA. Given the correct genetic information, in fact, it can construct any protein-based biological machine, including another ribosome, regardless of the complexity.
Denton marveled.
It is astonishing to think that this remarkable piece of machinery, which possesses the ultimate capacity to construct every living thing that has ever existed on Earth, from a giant redwood to the human brain, can construct all its own components in a matter of minutes and is of the order of several thousand million times smaller than the smallest piece of functional machinery ever constructed by man. Not only is the ribosome amazing, Thea said, but now you're faced with the challenge of getting these new components into the right rooms where they can operate. In order to do that, you need to have another complicated system, just like you need a lot of things in place for a Greyhound bus to take someone from Philadelphia to Pittsburgh. First of all, you've got to have molecular trucks, which are enclosed and have motors attached to them.
You've got to have little highways for them to travel along.
You've got to be able to identify which components are supposed to go into which truck. After all, it doesn't do any good if you just grab any protein that comes along, because each one needs to go to a specific room. So there has to be a signal attached to the protein, sort of a ticket to let the protein onto the right molecular truck. The truck has to know where it's going, which means having a signal on the truck itself and a complementary signal on the compartment where the truck is supposed to unload its cargo. When the truck arrives where it's supposed to go, it's kind of like a big ocean liner that has crossed from London to New York.
It pulls up at the dock and everyone's waving, but, oops, they forgot the gangplank. Now what are you going to do? You see, you've got to have a way for the cargo to get out of the truck and into the compartment, and it turns out this is an active process that involves other components recognizing each other, physically opening things up, and allowing the material to go inside. So you've got numerous components, all of which have to be in place or nothing works. If you don't have the signal, if you don't have the truck, you're pretty much out of luck. Now, does this microscopic transportation system sound like something that's self-assembled by gradual modifications over the years? I don't see how it could have been. To me, it has all the earmarks of being designed. The blood clotting cascade. There was a pause in our conversation as my mind processed the stupefying complexity of the cilium, flagellum, and intracellular transport system. As I began to formulate my next line of questioning, Thea noticed a band-aid on one of my fingers, covering a cut I had received while picking up pieces of broken glass the previous day. Irreducible complexity is a very relevant topic, he commented as he gestured toward the bandage. An irreducibly complex system just saved your life. What do you mean? I asked.
Blood clotting, he said. If your blood hadn't clotted in the right place and in the right amount and at the right time, you would have bled to death. As it turns out, the system of blood clotting involves a highly choreographed cascade of 10 steps that use about 20 different molecular components. Without the whole system in place, it doesn't work. Suddenly, I felt a personal stake in the topic.
Tell me more, I said.
The real trick with blood clotting isn't so much the clot itself, it's just a blob that blocks the flow of blood, but it's the regulation of the system, he continued. If you make a clot in the wrong place, say, the brain or lung, you'll die.
If you make a clot 20 minutes after all the blood has drained from your body, you'll die. If the blood clot isn't confined to the cut, your entire blood system might solidify, and you'll die.
If you make a clot that doesn't cover the entire length of the cut, you'll die. To create a perfectly balanced blood clotting system, clusters of protein components have to be inserted all at once.
That rules out a gradualistic Darwinian approach and fits the hypothesis of an intelligent designer. Surely, I thought to myself, there must be another way.
Some scientists have proposed that a process called gene duplication can account for the creation of new components for complex biological systems, I said.
Why wouldn't that work with blood clotting?
Gene duplication can happen during the process of cell division when DNA is being copied from the original cell for use in the new cell. Occasionally, the process goes awry and a piece of DNA, perhaps a gene, is copied twice.
This creates an extra gene.
While the original gene can go about its pre-assigned role, the extra gene can drift and perhaps create a new function.
Some scientists have theorized that this is how new components might be created for irreducible systems.
Sure, gene duplication happens, B replied.
But what the fans of gene duplication rarely recognize is that when you get a duplicated gene, you don't get a new protein with new properties. You've got the same protein as before. And that's a problem.
I was having difficulty seeing why.
Could you explain that? I asked.
He glanced down at the mousetrap, which was still sitting on his desk.
Let's go back to the mousetrap analogy, he said.
Suppose you have a one-component mousetrap, with two ends of a metal spring being bent and pressing against each other under tension so that if a mouse disturbs them, they'll slip and spring and hopefully catch a paw or tail. And say you wanted to develop a more efficient two-component trap that has a wooden base as well as the spring. According to the concept of gene duplication, you would make a copy of the first spring. Now you've got two springs except the second spring somehow becomes a wooden base.
Do you see the conceptual disconnect?
You can't just say the spring somehow morphs into a wooden base without doing more than just saying, gene duplication did it.
The problem is, Darwinists don't provide the details of how this can actually happen in the real world.
When one scientist tried to come up with a step-by-step scenario of how blood clotting could have developed, he couldn't avoid generalizing by saying a component suddenly appears, or is born, or arises, or springs forth, or is unleashed.
What's causing all of this springing forth and unleashing? There's no meaningful explanation of what could have caused these steps to take place.
These are details that doom these scenarios.
And there are a lot more problems than that.
How can blood clotting develop over time, step by step, when in the meantime the animal has no effective way to stop from bleeding to death whenever it's cut? And when you've only got part of a system in place, the system doesn't work, so you've got the components sitting around doing nothing, and natural selection only works if there is something useful right now, not in the future. Besides, at best the explanations that some people attempt are mere word pictures.
In science we're supposed to do experiments to show something is true.
Nobody has ever done experiments to show how blood clotting could have developed. Nobody has been able to show how a duplicated gene can develop some new function where it starts to make a new and irreducibly complex pathway.
Surviving the acid test.
There is a scientific way, however, to establish through experimental data whether Bely's concept of irreducible complexity is really an insuperable barrier for Darwinism. I was anxious to see whether B's ideas could survive this formidable challenge from Miller, a biology professor who's an ardent and outspoken evolutionist. The true acid test, explained Miller, would be to use the tools of molecular genetics to wipe out an existing multipart system and then see if evolution can come to the rescue with a system to replace it. If the system can be replaced purely by naturalistic evolutionary processes, then B's theory has been disproved.
After describing Miller's challenge, I asked B, "Do you agree this would be a fair test?"
Without hesitation, he said, "Yes, I agree.
That's a terrific test."
Then I said, Miller went on to describe an experiment by scientist Barry Hall of the University of Rochester to show how this apparently was done in the laboratory.
Miller concluded, "No doubt about it, the evolution of biochemical systems, even complex multipart ones, is explicable in terms of evolution." B is wrong.
I faced B squarely. Tell me, has Hall proved through his experiment that your theory is incorrect?
Unflustered, B replied, "No, not really. Actually, Hall is very modest about what his experiment shows. He didn't knock out a complex system and then show how evolution can replace it. Instead, he knocked out one component of a system that has 5 or 6 components. And replacing one component in a complex system is a lot easier than building one from scratch.
For instance, suppose someone told you that natural processes could produce a working television set.
You'd say, "That's interesting. Why don't you show me?"
He would then unplug 1,000 television sets. Eventually, a strong wind would come along and blow one plug back into the outlet, and the TV would come on.
He would say, "See?
I told you that natural processes could produce a working TV."
But that's not exactly what happened.
He wasn't producing a new complex system, there was a glitch introduced, and he showed that on occasion this can be fixed by random processes.
That's a little like what went on with Hall's experiment with the bacterium E. coli.
There was a complex system with a number of different parts, he knocked out one of them, and after a while he showed that random processes came up with a fix for that one part. That's a far cry from producing a brand new system from scratch. But there's something equally important. Hall made it clear that he had intervened to keep the system going while evolution was trying to come up with a replacement for the missing part.
In other words, he added a chemical to the mixture that gave it the time to come up with the mutation that fixed the glitch.
The result never would have actually happened in nature without
his intelligent intervention in the experiment. Here's another analogy. Suppose you say you can make a three-legged stool by random processes.
You take a three-legged stool and break off one leg. Then you hold up the stool so it won't fall over. Finally, a wind comes along, knocks down a tree branch, and it accidentally falls right where the missing leg had been. You're intervening to help the stool through the stage where it would otherwise have fallen over, and you've made it possible for the branch to fit in the right place.
Back to Hall's experiment.
Without going into the technical details, which I've done in more formal responses, in nature you couldn't have gotten just the mutation that he got in the laboratory. You would have had to have simultaneously gotten a second mutation, and the odds of that would have been prohibitive. Hall made it clear that he intervened so that he would get results that would never have actually happened in the natural world. And that is injecting intelligence into the system. When you analyze the entire experiment, the result is exactly what you would expect of irreducible complexity requiring intelligent intervention.
Unintentionally, he has shown the limits of Darwinism and the need for design.
Whirlpools and tornadoes.
What about other alternatives to Darwinian gradualism? I asked. How about self-organization?
Maybe there's some sort of self-organizational property in biochemistry that encourages the parts of molecular machines to self-assemble.
Just like natural selection explains some things, self-organization explains some things too.
The controversy arises when they're used to explain big things or everything, B said. It's true that if you pull out the plug in your bathtub, the water forms a little whirlpool.
That's self-organization. The water is moving in an organized fashion, whereas it wasn't before.
Tornadoes organize themselves. If you mix chemicals together in a certain way, you get a system that acts like a clock. It will turn blue, 5 seconds later it will turn colorless, and it will oscillate back and forth. So it's clear that there is such a thing as self-organization.
The question is, can it explain more complicated phenomena? Can it explain the genetic code?
Scientists trying to solve the riddle of the origin of life have been exploring self-organizational properties for decades.
Yet today they're more confused about the origin of life than 50 years ago.
They haven't come up with any explanation for how self-organization could account for something as complex as even the first primitive living organism. Right now, there's only one principle that we know can come up with complex interactive systems, and that's intelligence. Natural selection has been proposed, but there's little or no evidence backing that claim. Some people had high hopes for self-organizational properties or complexity theory, but there's no evidence that these can explain something as complicated as the cell.
The only force known to be able to make irreducibly complex machines is intelligent design.
So scientists are in the curious position of ignoring something they know to be capable of explaining what they see in biology, in favor of phantom or totally unproven explanations.
Why ignore intelligent design when it's a good match to the data?
Yes, we have to keep an open mind in science, but we shouldn't be ignoring the most obvious explanation for all the evidence we have today.
One reason some scientists are reluctant, I said, is because they claim intelligent design is not falsifiable. I was referring to the belief among many philosophers and scientists that a theory cannot truly be scientific unless there are potential ways to prove it false through experiments or other means.
That's silly, B replied.
But I hear it over and over, I insisted. The National Academy of Sciences said, intelligent design is not science because it's not testable by the methods of science.
Yes, I know, he said, but what's really ironic is that intelligent design is routinely called unfalsifiable by the very people who are busy trying to falsify it. As you just pointed out, Miller proposed a test that would falsify the claim that intelligence is needed to produce an irreducibly complex system.
So I don't see the problem. Intelligent design's strong point is that it's falsifiable, just like a good scientific theory should be. Frankly, I'd say it's more falsifiable than Darwinism is. Come on, I said. Do you really believe that?
Yes, I do, and I'll give you an example, he replied.
My claim is that there is no unintelligent process that could produce the bacterial flagellum. To falsify that claim, all you would have to do would be to find one unintelligent process that could produce that system. On the other hand, Darwinists claim that some unintelligent process could produce the flagellum. To falsify that, you'd have to show that the system could not possibly have been created by any of a potentially infinite number of possible unintelligent processes. That's impossible to do. So which claim is falsifiable? I'd say the claim for intelligent design. That isn't the only objection that B has turned on its head. While Darwinists often accuse intelligent design proponents of letting their religious beliefs color their science, B once told a newspaper reporter, "It has been my experience that the ones who oppose the theory of design most vociferously do so for religious reasons." What did you mean by that? I asked. It seems that the folks who get the most animated when talking about Darwinian evolution are the ones most concerned with the philosophical and theological ramifications of the theory, not the science itself, he explained. Scientists propose hypotheses all the time. No big deal. But if I say, I don't think natural selection is the driving force for the development of life, I think it was intelligent design, people don't just disagree, many of them jump up and down and get red in the face. When you talk to them about it, invariably they're not excited because they disagree with the science, it's because they see the extra scientific implications of intelligent design and they don't like where it's leading. B shrugged. I guess that's okay, he added. These are important issues and people can get emotional about them. But we should not use what we want to be true to dismiss arguments or try to avoid them. The arrow of progress. B's concept of irreducible complexity is at once a negative and a positive argument. First, he has taken Darwin at his own word and demonstrated how these interconnected biological systems could not have been created through the numerous, successive, slight modifications that his theory demands. The result has been a staggering, some say lethal blow to Darwinism. Second, Beale has pointed out that there is an alternative that does sufficiently explain how complex biological machines could have been created. Once again, as with the previous experts I had interviewed on cosmology, physics, and astronomy, the evidence conspires to point toward a transcendent creator. My conclusion can be summed up in a single word, design, Beale said as we came to the end of our interview. I say that based on science. I believe that irreducibly complex systems are strong evidence of a purposeful, intentional design by an intelligent agent. No other theory succeeds, certainly not Darwinism. Based on the empirical evidence which is continuing to mount, I agree with Joseph Cardinal Ratzinger that the great projects of the living creation are not the products of chance and error. They point to a creating reason and show us a creating intelligence, and they do so more luminously and radiantly today than ever before. Your book has been out for several years now, I said. How well do you think it has endured so far? I'm very pleased with how things stand, he said, leaning back in his chair and casually folding his arms over his chest. It has attracted a lot of attention from people who have tried to knock it down, but they haven't been able to do it. Complex biological systems have yet to be explained by naturalistic means. That's a fact. Even Darwinists admit that in their candid moments. And as science advances, we're continuing to find more and more complexity in the cellular world. This, Lee, is the arrow of progress. I do hear occasional complaints that science needs to pretend that everything works by natural law and that intelligent design is giving up. I've never seen the logic of that.
The purpose of science, it seems to me, is to find out how things got here and how they work.
Science should be the search for truth, not merely the search for materialistic explanations.
The great scientists of history, Newton and Einstein, for instance, never thought science's job was to come up with some sort of self-sufficient explanation for nature. This is a recent innovation, and not a good one, especially in light of discoveries during the last 50 years that have pointed in the exact opposite direction. B and I continued to talk for a while, then we shook hands and parted ways. As I lingered in the hallway, peering through the glass into various laboratories where scientists were hard at work, I thought of the concession by microbiologist James Shapiro of the University of Chicago in his review of B's book. There are no detailed Darwinian accounts for the evolution of any fundamental biochemical or cellular system, only a variety of wishful speculations.
Shapiro might not be amenable to B's ultimate conclusions, but personally I wasn't ready to bank on wishful speculations.
Connecting the dots from my interviews with William Lane Craig, Robin Collins, Guillermo Gonzalez, Jay Richards, and now Michael B., I was coming up with a picture that was squarely at odds with the icons that had once led me into atheism. In the words of Alan Sandage, one of the most highly respected scientists of our age, the world is too complicated in all its parts and interconnections to be due to chance alone. I am convinced that the existence of life with all its order in each of its organisms is simply too well put together.
Each part of a living thing depends on all its other parts to function. How does each part know? How is each part specified at conception?
The more one learns of biochemistry, the more unbelievable it becomes unless there is some type of organizing principle and architect for believers, a mystery to be solved by science, even as to why, sometime in the indefinite future for materialist reductionalists.
That mystery was going to take me even deeper inside the awe-inspiring, microscopic realm of the cell.
As I started my rental car and began to drive down the asphalt road from Lehigh's mountaintop campus, I remembered that Stephen Meyer, the philosopher of science I had already interviewed about the relationship between science and faith, has written extensively on DNA. This seemed like a good time for a new chat about where the arrow of genetics might be pointing.
Chapter 9. The evidence of biological information, the challenge of DNA, and the origin of life. Human DNA contains more organized information than the Encyclopedia Britannica.
If the full text of the encyclopedia were to arrive in computer code from outer space, most people would regard this as proof of the existence of extraterrestrial intelligence. But when seen in nature, it is explained as the workings of random forces.
George Sim Johnson. Einstein said, God does not play dice.
He was right, God plays Scrabble. Philip Gould. In 1953, when Francis Crick told his wife Odile that he and a colleague had discovered the secret of life, the chemical structure of DNA, where the instructions for building proteins were encoded, she didn't believe him. Years later, she confessed to her husband, "You were always coming home and saying things like that, so naturally, I thought nothing of it." This time, he wasn't exaggerating.
He and James D. Watson would win the Nobel Prize for discovering the now famous double helix of deoxyribonucleic acid, where the language of life is stored.
For more than 50 years, as scientists have studied the 6 feet of DNA that's tightly coiled inside every one of our body's 100 trillion cells, they have marveled at how it provides the genetic information necessary to create all of the proteins out of which our bodies are built. In fact, each one of the 30,000 genes that are embedded in our 23 pairs of chromosomes can yield as many as 20,500 different kinds of proteins. The astounding capacity of microscopic DNA to harbor this mountain of information, carefully spelled out in a 4-letter chemical alphabet, vastly exceeds that of any other known system, said geneticist Michael Denton. In fact, he said the information needed to build the proteins for all the species of organisms that have ever lived, a number estimated to be approximately 1,000 million, could be held in a teaspoon, and there would still be room left for all the information in every book ever written. DNA serves as the information storehouse for a finely choreographed manufacturing process in which the right amino acids are linked together with the right bonds in the right sequence to produce the right kind of proteins that fold in the right way to build biological systems. The documentary Unlocking the Mystery of Life, which has aired on numerous PBS television stations, describes the elaborate operation this way. In a process known as transcription, a molecular machine first unwinds a section of the DNA helix to expose the genetic instructions needed to assemble a specific protein molecule. Another machine then copies these instructions to form a molecule known as messenger RNA. When transcription is complete, the slender RNA strand carries the genetic information out of the cell nucleus. The messenger RNA strand is directed to a two-part molecular factory called a ribosome. Inside the ribosome, a molecular assembly line builds a specifically sequenced chain of amino acids. These amino acids are transported from other parts of the cell and then linked into chains often hundreds of units long. Their sequential arrangement determines the type of protein manufactured. When the chain is finished, it is moved from the ribosome to a barrel-shaped machine that helps fold it into the precise shape critical to its function. After the chain is folded into a protein, it is then released and shepherded by another molecular machine to the exact location where it is needed. It was this absolutely mind-boggling procedure that helped lead biology professor Dean Kenyon to repudiate the conclusions of his own book on the chemical origin of life and conclude instead that nothing short of an intelligence could have created this intricate cellular apparatus. This new realm of molecular genetics is where we see the most compelling evidence of design on the Earth, he said. It seemed fitting that when scientists announced that they had finally mapped the 3 billion codes of the Human Genome Project that filled the equivalent of 75,490 pages of the New York Times Divine References abounded. President Clinton said scientists were learning the language in which God created life, while geneticist Francis S. Collins, head of the Human Genome Project, said DNA was our own instruction book, previously known only to God. Are such public bows to a creator merely a polite social custom, meant only as a nodding courtesy to a predominantly theistic country? Or does the bounty of information in DNA really warrant the conclusion that an intelligent designer must have infused genetic material with its protein-building instructions? Are there any naturalistic processes that can account for the appearance of biological data in the earliest cells? I knew where to go to get answers. One of the country's leading experts on origin of life issues, who has written extensively on the implications of the information in DNA, resides in Washington state. He and I had already discussed the intersection of faith and science for Chapter 4 of this book. Now it was time to sit down with him again, this time in his new quarters at the Discovery Institute in downtown Seattle. Interview number 7, Stephen C. Meyer, Ph.D. Since our last discussion, philosopher and scientist Stephen Meyer had moved with his wife and 3 children to the outskirts of Seattle so he could focus on his role as director and senior fellow at the Discovery Institute's Center for Science and Culture. He continues to keep one foot in academia, however, as professor of the conceptual foundations of science at Palm Beach Atlantic University. Meyer earned his doctorate at Cambridge University, where he analyzed scientific and methodological issues in origin of life biology. For his master's degree, also from Cambridge, he studied the history of molecular biology and evolutionary theory. He has written about DNA and the problem of the origin of biological information for the books Debating Design, published by Cambridge University Press, Darwinism, Design, and Public Education, published by Michigan State University Press, Science and Evidence for Design in the Universe, Signs of Intelligence, and Mere Creation. Lately he has been finishing a book called DNA by Design, The Signature in the Cell, which further expands on his analysis of biological information. We got together on an unusually sultry summer day, had a pleasant lunch in an avant-garde Asian restaurant, and then settled into an office at the Discovery Institute. Meyer lowered his lanky frame into a plain wooden chair, his back to a half-open window through which random traffic noises could be heard. It was nearly mid-afternoon before we got started with our discussion. It was clear that Meyer likes the give and take of interviews. Although Meyer is typically more professorial than pugnacious, I've never heard of him shying away from tough questions or even rhetorically bloody debates with fervent Darwinists. In fact, I once hosted the videotaping of an intellectual shootout between Meyer and an atheistic anthropologist on the legitimacy of intelligent design theories, and I remember walking away amazed at Meyer's finesse in deftly dismantling the professor's case while at the same time forcefully presenting his own. Maybe that's a throwback to Meyer's earlier years when he trained as a boxer, learning to overcome fears of taking a punch and how to jab away at an opponent's weaknesses. As for me, I wasn't after blood in this interview, I was merely seeking straightforward answers to an issue that has befuddled origin-of-life scientists for the last 5 decades. Even the most Darwinists concede they are stumped on the question of how DNA and life itself came into existence. 1 foot they don't like Mayer's conclusions on the matter.
I didn't care much about that. My criterion was simple: what makes the most sense from a purely scientific perspective? The DNATO design argument.
I began our discussion by reading Mayer a quote that I had encountered in my research and scribbled in my notes. According to Berndolf Kuppers, the author of Information and the Origin of Life, the problem of the origin of life is clearly basically equivalent to the problem of the origin of biological information, I said.
Do you agree with him?
Oh, absolutely, yes, Mayer replied. When I ask students what they would need to get their computer to perform a new function, they reply, you have to give it new lines of code. The same principle is true in living organisms. If you want an organism to acquire a new function or structure, you have to provide information somewhere in the cell. You need instructions for how to build the cell's important components, which are mostly proteins. And we know that DNA is the repository for a digital code containing the instructions for telling the cell's machinery how to build proteins.
Kuppers recognized that this was a critical hurdle in explaining how life began. Where did this genetic information come from? Think of making soup from a recipe.
You can have all the ingredients on hand, but if you don't know the proper proportions, or which items to add in what order, or how long to cook the concoction, you won't get a soup that tastes very good. Well, a lot of people talk about theprobiotic soup, the chemicals that supposedly existed on the primitive Earth prior to life. Even if you had the right chemicals to create a living cell, you would also need information for how to arrange them in very specific configurations in order to perform biological functions. Ever since the 1950s and 1960s, biologists have recognized that the cell's critical functions are usually performed by proteins, and proteins are the product of assembly instructions stored in DNA.
Let's talk about DNA, then, I said. You've written that there's a DNA design argument. What do you mean by that?
Mayer removed a pair of gold-rimmed glasses from his shirt pocket and put them on as he began to give his answer. Very simply, he said, I mean that the origin of information in DNA which is necessary for life to begin is best explained by an intelligent cause rather than any of the types of naturalistic causes that scientists typically use to explain biological phenomena.
When you talk about information in DNA, what exactly do you mean? I asked.
We know from our experience that we can convey information with a 26-letter alphabet, or 22, or 30, or even just 2 characters, like the zeros and ones used in the binary code in computers. One of the most extraordinary discoveries of the 20th century was that DNA actually stores information, that detailed instructions for assembling proteins in the form of a 4-character digital code. The characters happen to be chemicals called adenine, guanine, cytosine, and thymine. Scientists represent them with the letters A, G, C, and T, and that's appropriate because they function as alphabetic characters in the genetic text. Properly arranging those 4 bases, as they're called, will instruct the cell to build different sequences of amino acids, which are the building blocks of proteins. Different arrangements of characters yields different sequences of amino acids. With that, Mayer decided to show me an illustration he often uses with college students. Reaching over to a desk drawer, he took out several oversized plastic snap-lock beads of the sort that young children play with. It says on the box that these are for kids ages 2 to 4, so this is advanced chemistry, he joked. He held up orange, green, blue, red, and purple beads of different shapes. These represent the structure of a protein. Essentially, a protein is a long linear array of amino acids, he said, snapping the beads together in a line. Because of the forces between the amino acids, the proteins fold into very particular 3-dimensional shapes, he added as he bent and twisted the line of beads. These 3-dimensional shapes are highly irregular, sort of like the teeth in a key, and they have a lock-key fit with other molecules in the cell. Often, the proteins will catalyze reactions, or they'll form structural molecules, or linkers, or parts of the molecular machines that Michael B. writes about. This specific 3-dimensional shape, which allows proteins to perform a function, derives directly from the 1-dimensional sequencing of amino acids.
Then he pulled some of the beads apart and began rearranging their order.
If I were to switch a red one and a blue one, I'd be setting up a different combination of force interactions and the protein would fold completely differently. So the sequence of the amino acids is critical to getting the long chain to fold properly to form an actual functional protein.
Wrong sequence, no folding, and the sequence of amino acids is unable to serve its function.
Proteins, of course, are the key functional molecule in the cell. You can't have life without
them. Where do they come from? Well, that question forces a deeper issue. What's the source of the assembly instructions in DNA that are responsible for the one-dimensional sequential arrangements of amino acids that create the three-dimensional shapes of proteins? Ultimately,
he emphasized, the functional attributes of proteins derive from information stored in the DNA molecule.
The library of life.
I was fascinated by the process that Meyer had described. What you're saying is that DNA would be like a blueprint for how to build proteins, I said, using an analogy I had heard many times before.
Meyer hesitated. Actually, I don't like the blueprint metaphor, he said.
You see, there are probably other sources of information in the cell and in organisms.
As important as DNA is, it doesn't build everything.
All it builds are the protein molecules, but they are only subunits of larger structures that themselves are informatively arranged.
Then what's a better analogy? I asked. DNA is more like a library, he said. The organism accesses the information that it needs from DNA so it can build some of its critical components.
And the library analogy is better because of its alphabetic nature.
In DNA, there are long lines of A, C, G, and T's that are precisely arranged in order to create protein structure and folding.
To build one protein, you typically need 1,200 to 2,000 letters or bases, which is a lot of information. And this raises the question again of the origin of that information, I said. It's not just that a question has been raised, he insisted. This issue has caused all naturalistic accounts of the origin of life to break down, because it's the critical and foundational question. If you can't explain where the information comes from, you haven't explained life, because it's the information that makes the molecules into something that actually functions.
I asked, what does the presence of information tell you?
I believe the presence of information in the cell is best explained by the activity of an intelligent agent, he replied.
Bill Gates said, DNA is like a software program, only much more complex than anything we've ever devised. That's highly suggestive, because we know that at Microsoft, Gates uses intelligent programmers to produce software.
Information theorist Henry Quasler said as far back as the 1960s that the creation of new information is habitually associated with conscious activity. But we're talking about something, the origin of information and life, that happened a long time ago, I said.
How can scientists reconstruct what happened in the distant past?
By using a scientific principle of reasoning that's called uniformitarianism, Meyer replied.
This is the idea that our present knowledge of cause and effect relationships should guide our reconstruction of what caused something to arise in the past. For example, I said and paused, hoping to prompt an illustration that would help me follow him. For instance, let's say you find a certain kind of ripple marks preserved from the ancient past in sedimentary strata. And let's say that in the present day you see the same sort of ripple marks being formed in lake beds as the water evaporates. You can reasonably infer, then, using uniformitarian logic, that the ripple marks in the sedimentary strata were produced by a similar process. So let's go back to DNA.
Even the very simplest cell we study today, or find evidence of in the fossil record, requires information that is stored in DNA or some other information carrier. And we know from our experience that information is habitually associated with conscious activity. Using uniformitarian logic, we can reconstruct the cause of that ancient information in the first cell as being the product of intelligence. As my mind tracked his line of reasoning, everything seemed to click into place except one thing.
However, I said, there's a caveat. Meyer cocked an eyebrow. Like what? He asked.
All of that is true unless you can find some better explanation.
Yes, of course, he said. You have to rule out other causes of the same effect. Origin of life scientists have looked at other possibilities for decades and, frankly, they've come up dry.
Before we went any further, though, I needed to satisfy myself that the other major possible scenarios fall short of the intelligent design theory.
The missing soup.
In 1871, Charles Darwin wrote a letter in which he speculated that life might have originated when a protein compound was chemically formed, in some warm little pond, with all sorts of ammonia and phosphoric salts, light, heat, electricity, etc. present.
A few years ago, a scientist summarized the basic theory this way.
The first stage on the road to life is presumed to have been the build-up, by pure chemical synthetic processes occurring on the surface of the early Earth, of all the basic organic compounds necessary for the formation of a living cell. These are supposed to have accumulated in the primeval oceans, creating a nutrient broth, the so-called prebiotic soup. In certain specialized environments, these organic compounds were assembled into large macromolecules, proteins, and nucleic acids. Eventually, over millions of years, combinations of these macromolecules occurred which were then endowed with the property of self-reproduction.
Then, driven by natural selection, ever more efficient and complex self-reproducing molecular systems evolved until finally the first simple cell system emerged.
I hear scientists talk a lot about this prebiotic soup, I said.
How much evidence is there that it actually existed?
That's a very interesting issue, he replied.
The answer is there isn't any evidence.
That's highly significant, because most origin of life theories presuppose the existence of this ancient chemical ocean.
What do you mean, there isn't any?
If this prebiotic soup had really existed, Meyer explained, it would have been rich in amino acids. Therefore, there would have been a lot of nitrogen, because amino acids are nitrogenous. So when we examine the earliest sediments of the Earth, we should find large deposits of nitrogen-rich minerals.
That seemed logical to me. What have scientists found? Those deposits have never been located.
In fact, Jim Brooks wrote in 1985 that the nitrogen content of early organic matter is relatively low, just 0.015%.
He said in Origins of Life.
From this we can be reasonably certain that there never was any substantial amount of primitive soup on Earth when Precambrian sediments were formed. If such a soup ever existed, it was only for a brief period of time.
This was an astounding conclusion. Don't you find that surprising, since scientists routinely talk about the prebiotic soup as if it were a given? I asked.
Yes, certainly it's surprising, he replied. Denton commented on this in Evolution, A Theory in Crisis, when he said, considering the way the prebiotic soup is referred to in so many discussions of the origin of life as an already established reality, it comes as something of a shock to realize that there is absolutely no positive evidence for its existence. And even if we were to assume that the prebiotic soup did exist, there would have been significant problems with cross-reactions.
What do you mean? Take Stanley Miller's origin of life experiment 50 years ago, when he tried to recreate the early Earth's atmosphere and spark it with electricity. He managed to create 2 or 3 of the protein-forming amino acids out of the 22 that exist. I interrupted to let Meyer know that biologist Jonathan Wells had already told me how Miller's experiment used an atmosphere that scientists now recognize was unrealistic, and that using the correct environment doesn't yield any biologically relevant amino acids. That's right, Meyer continued.
What's also interesting, however, is that Miller's amino acids reacted very quickly with the other chemicals in the chamber, resulting in a brown sludge that's not life-friendly at all. That's what I mean by cross-reactions. Even if amino acids existed in the theoretical prebiotic soup, they would have readily reacted with other chemicals.
This would have been another tremendous barrier to the formation of life.
The way that origin of life scientists have dealt with this in their experiments has been to remove these other chemicals in the hope that further reactions could take the experiment in a life-friendly direction. So instead of simulating a natural process, they interfered in order to get the outcome they wanted.
And that, Meyer concluded, is intelligent design.
Undoubtedly, obstacles to the formation of life on the primitive Earth would have been extremely formidable, even if the world were awash with an ocean of biological precursors.
Still, is there any reasonable naturalistic route to life?
Like a homicide detective rounding up the usual suspects, I decided to run down the 3 possible scenarios to see if any of them made sense.
Scenario number 1, random chance.
I began with an observation. I know that the idea of life forming by random chance is out of vogue right now among scientists, I said.
Meyer agreed.
Virtually all origin of life experts have utterly rejected that approach, he said with a wave of his hand. Even so, the idea is still very much alive at the popular level, I pointed out.
For many college students who speculate about these things, chance is still the hero. They think if you let amino acids randomly interact over millions of years, life is somehow going to emerge.
Well, yes, it's true that this scenario is still alive among people who don't know all the facts, but there's no merit to it, Meyer replied.
Imagine trying to generate even a simple book by throwing Scrabble letters onto the floor.
Or imagine closing your eyes and picking Scrabble letters out of a bag.
Are you going to produce Hamlet in anything like the time of the known universe?
Even a simple protein molecule, or the gene to build that molecule, is so rich in information that the entire time since the Big Bang would not give you, as my colleague Bill Dembski likes to say, the probabilistic resources you would need to generate that molecule by chance.
Even, I asked, if the first molecule had been much simpler than those today?
There's a minimal complexity threshold, he replied. There's a certain level of folding that a protein has to have, called tertiary structure, that is necessary for it to perform a function. You don't get tertiary structure in a protein unless you have at least 75 amino acids or so.
That may be conservative.
Now consider what you'd need for a protein molecule to form by chance.
First, you need the right bonds between the amino acids.
Second, amino acids come in right-handed and left-handed versions, and you've got to get only left-handed ones.
Third, the amino acids must link up in a specified sequence, like letters in a sentence.
Run the odds of these things falling into place on their own and you find that the probabilities of forming a rather short functional protein at random would be 1 chance in 100,000 trillion 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 trillion. That's a 10 with 125 zeros after it. And that would only be one protein molecule. A minimally complex cell would need between 300 and 500 protein molecules. Plus, all of this would have to be accomplished in a mere 100 million years, which is the approximate window of time between the Earth cooling and the first microfossils we've found. To suggest chance against those odds is really to invoke a naturalistic miracle.
It's a confession of ignorance. It's another way of saying, we don't know.
And since the 1960s, scientists, to their credit, have been very reluctant to say that chance played any significant role in the origin of DNA or proteins, even though, as you say, it's still unfortunately a live option in popular thinking.
Scenario number 2, natural selection.
Random chance might not account for the origin of life, but zoologist Richard Dawkins says that when natural selection acts on chance variations, then evolution is capable of scaling otherwise impossibly high peaks. In fact, that was the premise of his 1996 book Climbing Mount Improbable. He suggested that a complex biological structure is like a sheer cliff that cannot be scaled in one big bound without intermediate stepping stones, as chance must do. People look at this towering peak and think evolutionary processes could never get them to the top. The backside of that same mountain, however, has a gradual slope that makes for much easier climbing. This represents the Darwinian idea that nature provides small chance variations and then natural selection chooses the ones that are most advantageous. Over long periods of time, little changes accumulate into major differences. So while the mountain looks impossible to climb from the cliffside, it's quite easy to scale via the smaller Darwinian steps of natural selection on the backside.
In light of that insight, I asked Meyer, can natural selection explain how evolution managed to scale the mountain of building the first living cell? Whether natural selection really works at the level of biological evolution is open to debate, but it most certainly does not work at the level of chemical evolution, which tries to explain the origin of the first life from simpler chemicals, Meyer replied. As Theodosius Dobzhansky said, pre-biological natural selection is a contradiction in terms. How so? I asked.
Darwinists admit that natural selection requires a self-replicating organism to work, he explained.
Organisms reproduce, their offspring have variations, the ones that are better adapted to their environment survive better, and so those adaptations are preserved and passed on to the next generation. However, to have reproduction, there has to be cell division. And that presupposes the existence of information-rich DNA and proteins. But that's the problem, those are the very things they're trying to explain. In other words, you've got to have a self-replicating organism for Darwinian evolution to take place, but you can't have a self-replicating organism until you have the information necessary in DNA, which is what you're trying to explain in the first place. It's like the guy who falls into a deep hole and realizes he needs a ladder to get out. So climbs out, goes home, gets a ladder, jumps back into the hole, and climbs out. It begs the question. I raised another possibility. Maybe replication first began in a much simpler way and then natural selection was able to take over, I said. For example, some small viruses use RNA as their genetic material. RNA molecules are simpler than DNA, and they can also store information and even replicate. What about the so-called RNA first hypothesis that says reproductive life originated in a realm that's much less complex than DNA? There's a mountain of problems with that, he said. Just to cite a couple of them, the RNA molecule would need information to function, just as DNA would, and so we're right back to the same problem of where the information came from. Also, for a single strand of RNA to replicate, there must be an identical RNA molecule close by. To have a reasonable chance of having two identical RNA molecules of the right length would require a library of 10 billion RNA molecules, and that effectively rules out any chance origin of a primitive replicating system. Although popular for a while, the RNA theory has generated its share of skeptics. Evolutionist Robert Shapiro, a chemistry professor at New York University, said the idea at this point must be considered either a speculation or a matter of faith. Origin of life researcher Graham Cairns-Smith said that many interesting and detailed experiments in this area have only served to show that the theory is highly implausible. As Jonathan Wells noted in my earlier interview with him, biochemist Gerald Joyce of the Scripps Research Center was even more blunt: you have to build strawman upon strawman to get to the point where RNA is a viable first biomolecule. Jay Roth, former professor of cell and molecular biology at the University of Connecticut and an expert in nucleic acids, said whether the original template for the first living system was RNA or DNA, the same problem exists. Even reduced to the barest essentials, he said, this template must have been very complex indeed. For this template and this template alone, it appears it is reasonable at present to suggest the possibility of a creator. Scenario number 3, chemical affinities and self-ordering. Meyer pointed out that by the early 1970s, most origin of life scientists had become disenchanted with the options of random chance and natural selection. As a result, some explored a third possibility: various self-organizational theories for the origin of information-bearing macromolecules. For example, scientists theorized that chemical attractions may have caused DNA's four-letter alphabet to self-assemble, or that the natural affinities between amino acids prompted them to link together by themselves to create protein. When I broached these possibilities, Meyer's response was to bring up a name I had already encountered during my investigation. One of the first advocates of this approach was Dean Kenyon, who co-authored the textbook Biochemical Predestination, Meyer said. The title tells it all. The idea was that the development of life was inevitable because the amino acids in proteins and the bases, or letters, in the DNA alphabet had self-ordering capacities that accounted for the origin of the information in these molecules. I already knew that Kenyon had repudiated the conclusions of his own book, declaring that we have not the slightest chance of a chemical evolutionary origin for even the simplest of cells, and that intelligent design made a great deal of sense, as it very closely matched the multiple discoveries in molecular biology. Still, I wanted to consider the evidence for myself. How did this chemical attraction supposedly work? I asked. We'll use proteins as an example, he said. Remember, proteins are composed of a long line of amino acids. The hope was that there would be some forces of attraction between the amino acids that would cause them to line up the way they do and then fold so that the protein can perform the functions that keep a cell alive. I interrupted.
You have to admit that there are examples in nature where chemical attractions do result in a kind of self-ordering.
That's right, Meyer said.
Salt crystals are a good illustration. Chemical forces of attraction cause sodium ions, Na+, to bond with chloride ions, Cl-, in order to form highly ordered patterns within a crystal of salt.
You get a nice sequence of Na and Cl repeating over and over again.
So, yes, there are lots of cases in chemistry where bonding affinities of different elements will explain the origin of their molecular structure. Kenyon and others hoped this would be the case for proteins and DNA.
What turned out to be the problem? I asked. As scientists did experiments, they found that amino acids didn't demonstrate these bonding affinities, Meyer replied. None at all?
There were some very, very slight affinities, but they don't correlate to any of the known patterns of sequencing that we find in functional proteins.
Obviously, that's a major problem, but there was an even bigger theoretical difficulty. Information theorist Hubert Yaki and chemist Michael Polanyi raised a deeper issue. What would happen if we could explain the sequencing in DNA and proteins as a result of self-organization properties? Wouldn't we end up with something like a crystal of salt, where there's merely a repetitive sequence? When I asked Meyer to elaborate, he said, consider the genetic information in DNA, which is spelled out by the chemical letters A, C, G, and T. Imagine every time you had an A, it would automatically attract a G. You'd just have a repetitive sequence, AG, 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 AG. Would that give you a gene that could produce a protein? Absolutely not. Self-organization wouldn't yield a genetic message, only a repetitive mantra. To convey information, you need irregularity in sequencing. Open any book, you won't see the word "the" repeating over and over and over.
Instead, you have an irregular sequencing of letters. They convey information because they conform to a certain known independent pattern, that is, the rules of vocabulary and grammar. That's what enables us to communicate, and that's what needs to be explained in DNA. The 4 letters of its alphabet are also highly irregular while at the same time conforming to a functional requirement, that is, the correct arrangement of amino acids to create a working protein.
Here's an example.
If you go north of here into Victoria Harbour in British Columbia, you'll see a pattern on a hillside. As the ferry approaches, you'll realize it's a message. Red and yellow flowers spell out "Welcome to Victoria." That's an example of an informational sequence. Notice you don't have mere repetition, a W followed by an E, followed by another W and another E, and so on. Instead, there's an irregular combination of letters that conform to an independent pattern or specific set of functional requirements, English vocabulary and grammar. So we immediately recognize this as informational. Whenever we encounter these two elements' irregularity that's specified by a set of functional requirements, which is what we call specified complexity, we recognize this as information. And this kind of information is invariably the result of mind, not chance, not natural selection, and not self-organizational processes.
And this is the kind of information we find in DNA? I asked.
That's correct. If all you had were repeating characters in DNA, the assembly instructions would merely tell amino acids to assemble in the same way over and over again. You wouldn't be able to build all the many different kinds of protein molecules you need for a living cell to function. It would be like handing a person an instruction book for how to build an automobile, but all the book said was the.
You couldn't hope to convey all the necessary information with that one-word vocabulary.
Whereas information requires variability, irregularity, and unpredictability, which is what information theorists call complexity. Self-organization gives you repetitive, redundant structure, which is known as simple order. And complexity and order are categorical opposites. Chemical evolutionary theorists are not going to escape this. The laws of nature, by definition, describe regular, repetitive patterns. For that reason, one cannot invoke self-organizing processes to explain the origin of information, because informational sequences are irregular and complex. They exhibit the specified complexity I talked about. Future discoveries aren't going to change this principle. To me, this absolutely doomed the idea of chemical affinities accounting for the information in DNA. But Meyer wasn't through.
There was yet another devastating problem with this theory.
If you study DNA, he continued, you will find that its structure depends on certain bonds that are caused by chemical attractions. For instance, there are hydrogen bonds and bonds between the sugar and phosphate molecules that form the two twisting backbones of the DNA molecule.
However, he stressed, there's one place where there are no chemical bonds, and that's between the nucleotide bases, which are the chemical letters in the DNA's assembly instructions.
In other words, the letters that spell out the text in the DNA message do not interact chemically with each other in any significant way.
Also, they're totally interchangeable.
Each base can attach with equal facility at any site along the DNA backbone.
Sensing the need for an illustration, Meyer stood and reached over to the desk to grab another child's toy metal chalkboard with several magnetic letters sticking to it.
Sitting back down, he put the chalkboard on his lap and maneuvered the letters until they spelled the word information. My kids were young when I was first studying this, so I came up with this example, he said. We know that there are magnetic affinities here, that's why the magnetic letters stick to the metal chalkboard.
To demonstrate, he picked up the letter R and let the magnetism pull it back to the board.
Notice, however, that the magnetic force is the same for each one of the letters, and so they're effectively interchangeable.
You can use the letters to spell whatever you want.
Now, in DNA, each individual base, or letter, is chemically bonded to the sugar-phosphate backbone of the molecule. That's how they're attached to the DNA's structure.
But and here's the key point, there is no attraction or bonding between the individual letters themselves. So there's nothing chemically that forces them into any particular sequence. The sequencing has to come from somewhere else. When I show students the magnetic letters sticking to the metal chalkboard, I ask, how did this word information arise?
The answer, of course, is intelligence that comes from outside the system.
Neither chemistry nor physics arranged the letters this way. It was my choice. And in DNA, neither chemistry nor physics arranges the letters into the assembly instructions for proteins.
Clearly, the cause comes from outside the system. He paused while the implications sunk in. And that cause, he stressed, is intelligence.
Almost a miracle.
Like a skillful boxer picking apart the defenses of his opponent, Meyer had adroitly dismantled the three categories of naturalistic explanations for the origin of life and information in DNA.
We even discussed another option, the possibility that some external force might be responsible for creating organization, much in the same way gravity creates a vortex as water drains from a bathtub.
Meyer quickly dismissed that notion, pointing out that such forces may produce order but they can't manufacture information. These dead ends for naturalistic origin of life theories would not be a surprise to scientists in the field. When prominent origin of life researcher Leslie Orgel ran into another evolutionist at a Detroit conference several years ago, Orgel admitted the overwhelming difficulties he had encountered in trying to figure out how nucleic acids might have been naturally synthesized on the primitive Earth. Then Orgel candidly conceded, there are equally overwhelming difficulties in the way of all theories. In short, no hypothesis has come close to explaining how information necessary to life's origin arose by naturalistic means. As Crick, a philosophical materialist, has conceded, an honest man, armed with all the knowledge available to us now, could only state that in some sense, the origin of life appears at the moment to be almost a miracle, so many are the conditions which would have had to have been satisfied to get it going. For many researchers, the only recourse has been to continue to have faith that, as one scientist put it, some previously unknown magic mineral will be discovered to have had exactly the right properties to cause the necessary reactions to occur to create a nucleic acid. Maybe, I said to Meyer, someday scientists will come up with another hypothesis. Maybe they will, he replied. You can't prove something like this with 100% certainty, because you don't know what new evidence will show. That's why all scientists reason in a way that's provisional. Having said that, though, we do know that some possibilities can be excluded categorically. They're dead ends. For example, I think you can categorically exclude the idea that self-organizational processes can provide new information. More evidence will simply not change that. Some skeptics would claim you're arguing from ignorance, I pointed out. Scientists admit they don't know how life started, so you conclude there must have been an intelligent designer.
No, not at all. I'm not saying intelligent design makes sense simply because other theories fail, he insisted. Instead, I'm making an inference to the best explanation, which is how scientists reason in historical matters. Based on the evidence, the scientist assesses each hypothesis on the basis of its ability to explain the evidence at hand. Typically, the key criterion is whether the explanation has causal power, which is the ability to produce the effect in question. In this case, the effect in question is information. We've seen that neither chance, nor chance combined with natural selection, nor self-organizational processes have the causal power to produce information. But we do know of one entity that does have the required causal powers to produce information, and that's intelligence. We're not inferring to that entity on the basis of what we don't know, but on the basis of what we do know. That's not an argument from ignorance. Isn't there a fundamental weakness to your argument, though? I asked. You're arguing by analogy, comparing the information in DNA to information we find in language. Arguments based on analogies are notoriously weak. Advocates might emphasize the similarities between two things, but opponents will stress the differences. I'll admit that there is a way of speaking about the information in DNA that goes too far and then becomes metaphorical, he began. When people talk about DNA as being a message, that could imply there was a receiver who could understand the message. I'm not saying that DNA is this sort of semantic information. However, I'm not arguing by analogy. The coding regions of DNA have exactly the same relevant properties as a computer code or language. As I said earlier, whenever you find a sequential arrangement that's complex and corresponds to an independent pattern or functional requirement, this kind of information is always the product of intelligence. Books, computer codes, and DNA all have these two properties. We know books and computer codes are designed by intelligence, and the presence of this type of information in DNA also implies an intelligent source. Scientists in many fields recognize this connection between information and intelligence. When archaeologists discovered the Rosetta Stone, they didn't think its inscriptions were the product of random chance or self-organizational processes. Obviously, the sequential arrangements of symbols was conveying information, and it was a reasonable assumption that intelligence created it. The same principle is true for DNA. The biological Big Bang. Meyer had made a convincing case that intelligence and intelligence alone can explain the presence of precise information within genetic material. By itself, this was impressive evidence for the existence of a designer of life. As I looked down at my hand and tried to comprehend the vast quantities of complex and specific information inscribed in each cell, a slight smile formed at the corners of my mouth. The answer to the monumental question of whether there's a creator, I mused, might very well be as close as my own fingertips. Meyer wasn't finished, however. As he mentioned in our previous interview, he is convinced that the so-called Cambrian explosion, in which a dazzling array of new life forms suddenly appears fully formed in the fossil record, without any of the ancestors required by Darwinism, also is powerful evidence of a designer. The reason this phenomenon would have required the sudden infusion of massive amounts of new genetic and other biological information that only could have come from an intelligent source. Among other places, Meyer makes that case in The Cambrian Information Explosion, Evidence for Intelligent Design in Debating Design, recently published by Cambridge University Press. Another extensive piece, The Cambrian Explosion, Biology's Big Bang, appears in Darwinism, Design, and Public Education. Meyer co-authored this analysis with Paul Chien, chairman and professor in the biology department at the University of San Francisco, who worked with leading Chinese scientists on interpreting Cambrian fossils unique to China's Zhejiang region. Paul A. Nelson, a philosopher of biology who earned his doctorate at the University of Chicago, and paleontologist Marcus Ross. The fossils of the Cambrian explosion absolutely cannot be explained by Darwinian theory or even by the concept called punctuated equilibrium, which was specifically formulated in an effort to explain away the embarrassing fossil record, Meyer said. When you look at the issue from the perspective of biological information, the best explanation is that an intelligence was responsible for this otherwise inexplicable phenomenon. I leaned back in my chair and crossed my legs to get comfortable. This sounds fascinating, I said. Explain what you mean. Meyer clearly relished the opportunity to elaborate. New developments in embryology and developmental biology are telling us that DNA, as important as it is not the whole show. Meyer began. DNA provides some, but not all of the information that's needed to build a new organism with a novel form and function. You see, DNA builds proteins, but proteins have to be assembled into larger structures. There are different kinds of cells, and those cells have to be arranged into tissues, and tissues have to be arranged into organs, and organs have to be arranged into overall body plans. According to neo-Darwinism, new biological forms are created from mutations in DNA, with natural selection preserving and building on the favorable ones. But if DNA is only part of the story, then you can mutate it indefinitely and you'll never build a fundamentally new body architecture. So when you encounter the Cambrian explosion, with its huge and sudden appearance of radically new body plans, you realize you need lots of new biological information. Some of it would be encoded for in DNA, although how that occurs is still an insurmountable problem for Darwinists. But on top of that, where does the new information come from that's not attributable to DNA? How does the hierarchical arrangement of cells, tissues, organs, and body plans develop? Darwinists don't have an answer. It's not even on their radar. In the blink of an eye. Using radiometric techniques to date zircon crystals in Siberia, scientists have recently been able to increase their accuracy in pinpointing the time frame of the Cambrian explosion, whose beginning they have determined to be some 530 million years ago. Paleontologists now think that during a 5 million year, or even shorter, window of time, at least 20 and as many as 35 of the world's 40 phyla, the highest category in the animal kingdom, sprang forth with unique body plans. In fact, some experts believe that all living phyla may have originated by the end of the explosion. To put this incredible speed into perspective, if you were to compress all of the Earth's history into 24 hours, the Cambrian explosion would consume only about 1 minute. The Cambrian explosion represents an incredible quantum leap in biological complexity. Meyer said. Before then, life on Earth was pretty simple one-celled bacteria, blue-green algae, and later some sponges and primitive worms or mollusks. Then, without any ancestors in the fossil record, we have a stunning variety of complex creatures appear in the blink of an eye, geologically speaking. For example, the trilobite with an articulated body, complicated nervous system, and compound eye suddenly shows up fully formed at the beginning of the explosion. It's amazing. And this is followed by stasis, which means the basic body plans remain distinct over the eons. All of this totally contradicts Darwinism, which predicted the slow, gradual development in organisms over time. Darwin admitted the Cambrian explosion was inexplicable and a valid argument against his theory. He insisted natura non facit saltum, nature takes no leaps. He thought he would be vindicated, however, as more fossils were discovered, but the picture has only gotten worse. The big issue is, where did the information come from to build all these new proteins, cells, and body plans? For instance, Cambrian animals would have needed complex proteins, such as lysyl oxidase. In animals today, lysyl oxidase molecules require 400 amino acids. Where did the genetic information come from to build those complicated molecules? This would require highly complex, specified genetic information of the sort that neither random chance, nor natural selection, nor self-organization can produce. In my interview for Chapter 3, biologist Jonathan Wells had satisfactorily answered my objections to the Cambrian explosion, one of which was that transitional organisms may have been too small or soft to have left a legacy of fossils. Still, another possibility came to mind. Maybe, I suggested, some unexplained environmental phenomenon caused a sudden spate of mutations that accelerated the creation of new organisms. That doesn't solve the problem, Meyer replied. First, even assuming a generous mutation rate, the Cambrian explosion was far too short to have allowed for the kind of large-scale changes that the fossils reflect. Second, only mutations in the earliest development of organisms have a realistic chance of producing large-scale macroevolutionary change. And scientists have found that mutations at this stage typically have disastrous effects. The embryo usually dies or is crippled. Geneticist John F. MacDonald has called this a great Darwinian paradox.
The kind of mutations that macroevolution needs, namely, large-scale, beneficial ones, don't occur, while the kind it doesn't need, large-scale mutations with harmful effects or small-scale mutations with limited impact, do occur, though infrequently.
I brought up another idea that has been offered by some evolutionists. Why couldn't mutations have occurred in an inactive part of the DNA, sort of a neutral area that wouldn't have had any immediate impact on the organism? I asked. Then, after a long period of time during which these mutations could accumulate, a new gene sequence could have suddenly kicked in and created an entirely new protein. Natural selection would then preserve any beneficial effects this would have on the organism. This theory wasn't new to Meyer. He responded by saying, keep in mind that these mutations would have had to occur by random chance, since natural selection can't preserve anything until it confers a positive benefit on the organism. The problem is that the odds of creating a novel functional protein without the help of natural selection would be vanishingly small. There are now a number of studies in molecular biology that establish this. So this so-called neutral theory of evolution is another dead end. There's really only one explanation that accounts for all the evidence. In any other field of endeavor, it would be obvious, but many scientists shy away from it in biology. The answer, he said, is an intelligent designer. Fitting the top-down pattern. The puzzle of the Cambrian explosion quickly falls into place once the possibility of a purposeful creator is allowed as one of the explanatory options. Even one of the explosion's most vexing features, its so-called top-down pattern of appearances, efficiently explained by intelligent design. Said Meyer, neo-Darwinism predicts a bottom-up pattern in which small differences in form between evolving organisms appear prior to large differences in form and body plan organization. For instance, you might imagine that Precambrian sponges would have given rise to several different varieties. These varieties would have evolved over time to produce different species. As this process continued, wholly different creatures with completely new body plans would have emerged in the Cambrian era. Instead, however, fossils from the Cambrian explosion show a radically different top-down pattern. Major differences in form and body plans appear first, with no simpler transitions before them. Later, some minor variations arise within the framework of these separate and disparate body plans. This has completely stumped neo-Darwinists. Others have tried to explain it away by proposing big leaps of evolutionary change, the so-called punctuated equilibrium idea, but even this can't account for the top-down phenomenon. In fact, punctuated equilibrium predicts a bottom-up pattern. It just asserts that the increments of evolutionary change would be larger. Yet if you postulate intelligent design, the top-down pattern makes sense, because it's the same pattern we see in the history of human technological design. Can you give me an example? I asked. Sure, think about cars or airplanes, Meyer replied. They also manifest a top-down pattern of appearance. In both cases, the major blueprint or plan appears fairly suddenly and remains essentially constant over history. For instance, all cars have a basic organizational plan that includes a motor, a drive shaft, 2 axles, 4 wheels, and so forth. After the basic invention came about, then variations have occurred on the theme over time. That's an example of top-down change. The original blueprint was the product of intelligence, and the continuity through the years is explained by an idea being passed from generation to generation of automotive engineers. In a similar way, why couldn't the body plans of the Cambrian animals have originated as an idea in the mind of a designer? This would explain why the major differences in form appear first and then subsequent small-scale variations only come later. In fact, intelligence is the only cause we know that produces the kind of top-down pattern we see in both the fossil record and in human technology, as illustrated by everything from cars and airplanes to guns and bicycles. Intelligence also explains the origin of the layers of information necessary to create the new body plans in the Cambrian animals. As I mentioned earlier, to build a new animal you need DNA to create the proteins and additional information to arrange the proteins into higher-level structures. We find the same layering or hierarchical form of organization in human technologies, like a computer's circuit board. Humans use intelligence to produce complex components, such as transistors and capacitors, as well as their specific arrangement and connection within an integrated circuit.
Once you allow intelligent design as an option, you can quickly see how it accounts for the key features of the Cambrian phenomenon. No other entity explains the sudden appearance of such complex new creatures. No other entity produces top-down patterns. No other entity can create the complex and functionally specific information needed for new living forms. No other explanation suffices. But intelligent design sounds like such an outmoded concept, I said. William Paley famously compared biological systems to the workings of a watch more than 200 years ago. That's old news. I had struck a nerve. Meyer uncrossed his legs, planted both feet on the floor, and spoke with conviction. I think the opposite is true, he insisted. We've learned a lot about biology since the Civil War. Evolutionists are still trying to apply Darwin's 19th century thinking to a 21st century reality, and it's not working. Explanations from the era of the steamboat are no longer adequate to explain the biological world of the information age. Darwinists say they're under some sort of epistemological obligation to continue trying, because to invoke design would be to give up on science. Well, I say it's time to redefine science. We should not be looking for only the best naturalistic explanation, but the best explanation, period. An intelligent design is the explanation that's most in conformity with how the world works. A hallmark of mind. As our interview was drawing to a close, Meyer's reference to the 21st century prompted one last line of inquiry. Fast forward 10 or 20 years, I said. What do you see? I think the information revolution taking place in biology is sounding the death knell for Darwinism and chemical evolutionary theories, he said as he removed his glasses and slipped them into his pocket. The attempt to explain the origin of life solely from chemical constituents is effectively dead now. Naturalism cannot answer the fundamental problem of how to get from matter and energy to biological function without the infusion of information from an intelligence. Information is not something derived from material properties, in a sense, it transcends matter and energy. Naturalistic theories that rely solely on matter and energy are not going to be able to account for information. Only intelligence can. I think that realization is going to progressively dawn on more and more people, especially younger scientists who have grown up in the age of information technology. Today we buy information, we sell it, we regard it as a commodity, we value it, we send it down wires and bounce it off satellites, and we know it invariably comes from intelligent agents. So what do we make of the fact that there's information in life? What do we make of the fact that DNA stores far more information in a smaller space than the most advanced supercomputer on the planet? Information is the hallmark of mind. And purely from the evidence of genetics and biology, we can infer the existence of a mind that's far greater than our own, a conscious, purposeful, rational, intelligent designer who's amazingly creative. There's no getting around it. The cacophony of street noise coming through the half-open window was getting louder now that rush hour was approaching. Meyer's wife was graciously cooking a salmon dinner for us at their house, and it was time to get on the highway before it got clogged with traffic. As we ended our discussion, Meyer excused himself for a quick meeting in another office, giving me some time to reflect. Meyer's two rhetorical questions near the conclusion of our discussion effectively summed up the issue. The data at the core of life is not disorganized, it's not simply orderly like salt crystals, but it's complex and specific information that can accomplish a bewildering task: the building of biological machines that far outstrip human technological capabilities. What else can generate information but intelligence? What else can account for the rapid appearance of a staggering variety of fully formed, complex creatures that have absolutely no transitional intermediates in the fossil record? The conclusion was compelling: an intelligent entity has quite literally spelled out evidence of his existence through the 4 chemical letters in the genetic code. It's almost as if the creator autographed every cell. I sighed and slumped back in my chair, a bit exhausted from my whirlwind of travel and interviews. The case for a creator was accumulating at a remarkable pace, and I could sense I was approaching the conclusion of my quest. But I also knew there was at least one more expert I needed to consult. In the closing minutes of our conversation, Meyer had mentioned the word mind and referred to conscious activity. As beguiled as I was by DNA, I was equally intrigued by the human brain. Weighing just 3 pounds, it has 10,000 million nerve cells, each sending out enough fibers to create 1,000 million connections. That's equal to the number of leaves in a dense forest covering 1,000,000 square miles. Yet how does all of that circuitry create the unique phenomenon of human consciousness? How does raw biological processing power enable me to reflect, or form beliefs, or make free choices? Is my consciousness only attributable to the physics and chemistry of my brain, or have I also been endowed with an immaterial mind and soul? And if there is persuasive evidence of a soul, what could this tell me about the existence of a creator and an afterlife? I pulled out a small notebook and scribbled myself a note to contact an expert on consciousness as soon as I returned to Los Angeles. I started to slip the pad into my shirt pocket, but instead I stopped and looked at the reminder I had just written. It was also a reminder of something else. Those few words, a fragment of a sentence, represented information that has its source in my intelligence. How intuitively obvious that a dense array of far more complicated biological assembly instructions must, too, have their origin in a mind. Chapter 10. The Evidence of Consciousness, the Enigma of the Mind. Cogito ergo sum, I think, therefore I am. René Descartes. Why should a bunch of atoms have thinking ability? Why should I, even as I write now, be able to reflect on what I am doing, and why should you, even as you read now, be able to ponder my points, agreeing or disagreeing, with pleasure or pain, deciding to refute me or deciding that I am just not worth the effort? No one, certainly not the Darwinian as such, seems to have any answer to this. The point is that there is no scientific answer. Darwinist philosopher Michael Ruse. The intelligence of machines will exceed human intelligence early in this century, predicted technoprophet Ray Kurzweil, recipient of the prestigious National Medal of Technology and called the ultimate thinking machine by Forbes. By intelligence, I include all of the diverse and subtle ways in which humans are intelligent, including musical and artistic aptitude, creativity, physically moving, and even responding to emotion. By 2019, a $1,000 computer will match the processing power of the human brain. By 2050, $1,000 of computing will equal the processing power of all human brains on Earth. Will these future machines be capable of having spiritual experiences? They certainly will claim to. They will claim to be people, and to have the full range of emotional and spiritual experiences that people claim to have. In envisioning the future, Kurzweil's book The Age of Spiritual Machines raises the controversial question of whether computers will not only become smarter than people but might also achieve consciousness and thus become virtually indistinguishable from their biologically based counterparts. In a sense, Kurzweil's theories are a logical extension of Darwinian evolution. According to Darwinists, the physical world is all that there is. At some point, the human brain evolved, with its raw processing power increasing over the eons. When the brain reached a certain level of structure and complexity, people became conscious, that is, they suddenly developed subjectivity, feelings, hopes, a point of view, self-awareness, introspection, that hidden voice of our private selves. As far back as 1871, Darwin advocate Thomas Huxley said, mind, or consciousness, is a function of matter, when that matter has attained a certain degree of organization. Darwinists today agree that conscious experience is a physical and not a supernatural phenomenon, as sociobiologist Edward Zero Wilson said. If consciousness really is the automatic byproduct of increasingly sophisticated brain power, then why couldn't super-smart robots become conscious when they achieve a bigger brain capacity than people? Once the basic Darwinian premise is accepted, then Kurzweil's futuristic scenario suddenly seems possible. If you can get a computer to take on any structure you like, and if consciousness is generated by structure, then by definition that kind of structure is going to eventually give you consciousness, said David Chalmers, co-director of the Center for Consciousness Studies at the University of Arizona. Kurzweil's predictions, however, have been assailed by critics who say computer consciousness is absurd. I cannot recall reading a book in which there is such a huge gulf between the spectacular claims advanced and the weakness of the arguments given in their support, scoffed John Searle, a professor of mind at the University of California at Berkeley. You can expand the power all you want, hooking up as many computers as you think you need, and they still won't be conscious, because all they'll ever do is shuffle symbols.
said William Dembski of the Conceptual Foundations of Science at Baylor University. Kurzweil is peddling science fiction and bad philosophy.
As fascinating as this debate over futuristic computers has been, there still remains a much more important controversy over human consciousness.
Amazingly, many scientists and philosophers are now concluding that the laws of physics and chemistry cannot explain the experience of consciousness in human beings.
They are convinced that there is more than just the physical brain at work, but there also is a non-material reality called the soul, mind, or self. That accounts for our sentience.
In fact, they cite its very existence as strong evidence against the purely naturalistic theory of Darwinian evolution and in favor of a creator who imbued humankind with his image.
The controversy over consciousness. One scientist whose opinions were reversed on the issue is Wilder Penfield, the renowned father of modern neurosurgery. He started out suspecting that consciousness somehow emanated from the neural activities in the brain, where synapses can fire an astounding 10 million billion times a second. Through my own scientific career, I, like other scientists, have struggled to prove that the brain accounts for the mind, he said. 9. But through performing surgery on more than 1,000 epileptic patients, he encountered concrete evidence that the brain and mind are actually distinct from each other, although they clearly interact. Explained one expert in the field. Penfield would stimulate electrically the proper motor cortex of conscious patients and challenge them to keep one hand from moving when the current was applied. The patient would seize this hand with the other hand and struggle to hold it still. Thus one hand under the control of the electrical current and the other hand under the control of the patient's mind fought against each other. Penfield risked the explanation that the patient had not only a physical brain that was stimulated to action but also a non-physical reality that interacted with the brain. In other words, Penfield ended up agreeing with the Bible's assertion that human beings are both body and spirit. To expect the highest brain mechanism or any set of reflexes, however complicated, to carry out what the mind does, and thus perform all the functions of the mind, is quite absurd, he said. What a thrill it is, then, to discover that the scientist, too, can legitimately believe in the existence of the spirit. Similarly, Oxford University professor of physiology Sir Charles Sherrington, a Nobel Prize winner described as a genius who laid the foundations of our knowledge of the functioning of the brain and spinal cord, declared 5 days before his death, "For me now, the only reality is the human soul." As for his one-time student John C. Eccles, himself an eminent neurophysiologist and Nobel laureate, his ultimate conclusion is the same. "I am constrained," he said, "to believe that there is what we might call a supernatural origin of my unique self-conscious mind or my unique selfhood or soul." But is it really rational in the 21st century to believe in John Calvin's 16th century claim that the endowments we possess cannot possibly be from ourselves, but that they must have a divine source? Is the Bible's insistence that people consist of both body and spirit a belief called dualism a defensible assertion? Or is the human brain simply, in the famous words of MIT's Marvin Minsky, a computer made of meat, with conscious thought as its wholly mechanical output? Consciousness, declared Searle, is the single most important fact about our existence, except for life itself. It was clear to me that the answer to the mystery of our mind would either be a powerful confirmation of Darwinian naturalism or a persuasive affirmation of a far greater mind in whose likeness we were created. Surpassing the brain's boundaries. It was a news dispatch from the front lines of the scientific investigation of human consciousness. Published by the journal Resuscitation and presented to scientists at the California Institute of Technology in 2001, the year-long British study provided evidence that consciousness continues after a person's brain has stopped functioning and he or she has been declared clinically dead. It was dramatic new evidence that the brain and mind are not the same, but they're distinct entities. The research, said Reuters journalist Sarah Tippett, resurrects the debate over whether there is life after death and whether there is such a thing as the human soul. In their journal article, physicians Sam Parnia and Peter Fenwick, a neuropsychiatrist at the Institute of Psychiatry in London, described their study of 63 heart attack victims who were declared clinically dead but were later revived and interviewed. About 10% reported having well-structured, lucid thought processes, with memory formation and reasoning, during the time that their brains were not functioning. The effects of oxygen starvation or drugs objections commonly offered by skeptics were ruled out as factors. Later, the researchers found numerous cases that were similar. While large-scale studies are still needed, the once skeptical Parnia said the scientific findings so far would support the view that mind, consciousness, or thesel is a separate entity from the brain. He speculated that the brain might serve as a mechanism to manifest the mind, much in the same way a television set manifests pictures and sounds from waves in the air. If an injury to the brain causes a person to lose some aspects of his mind or personality, this doesn't necessarily prove that the brain was the source of the mind. All it shows is that the apparatus is damaged. He said. Active research is continuing in this area and into other aspects of human consciousness. Meanwhile, the scientists who are committed to finding a purely physical answer, appropriately called physicalists, are candid in admitting that they currently have no explanation for how the brain might spawn consciousness. Conceded Searle, we don't have an adequate theory of how the brain causes conscious states, and we don't have an adequate theory of how consciousness fits into the universe. Still, Searle and many others find refuge in their unshakable faith that science will eventually discover a completely naturalistic explanation. Given Darwinism as a non-negotiable starting point, there's really no other choice. I am firmly in the confident camp a substantial explanation for the mind's emergence from the brain will be produced, and perhaps soon, predicted Professor of Neurology Antonio R. Damasio. The giddy feeling, however, is tempered by the acknowledgement of some sobering difficulties. Eccles calls this kind of attitude promissory materialism, extravagant and unfulfillable. Instead, many researchers are following Eccles's example by pursuing the evidence of science and the logic of philosophy wherever they lead, even if they point toward dualism. Said anthropologist Marilyn Schlitz. I would take the position of a radical empiricist, in that I am driven by data, not theory. And the data I see tell me that there are ways in which people's experience refutes the physicalist position that the mind is the brain and nothing more. There are solid, concrete data that suggest that our consciousness, our mind, may surpass the boundaries of the brain. As for the Bible, both the Old and New Testaments consistently teach that humans are a hyphenate creature, a spirit/body dichotomy, said anthropologist Arthur C. Custance. Then, quite significantly, he added, to this extent there is no quarrel between theology and the findings of recent research. Custance continued. The Bible makes it very clear that when the soul or spirit leaves the body is dead, and that if the spirit is somehow returned to the body, the whole person comes back to life. This duality is repeated in hundreds of places in the Bible. Indeed, the formation of Adam as the first human being is expressly stated as the result of the animation of a body by a spirit, constituting it as a living soul. Do Christianity and contemporary research really support each other, while at the same time contradicting the Darwinian claim that the brain is solely responsible for consciousness? As I went looking for answers, I didn't have to travel far from my home in Southern California. It was just a short drive to the house of a prominent professor trained in science, philosophy, and theology, who has pondered and written about these topics for years. Interview number 8, J. P. Moreland, Ph.D. When I pulled up to J. P. Moreland's house on a cool and foggy morning, he was outside. With a cup of coffee in his hand, having just walked home from a chat with some neighbors. His graying hair was close-cropped, his mustache neatly trimmed, and he was looking natty in a red tie, blue shirt, and dark slacks. Good to see you again, he said as we shook hands. Come on in. We walked into his living room, where he settled into a floral-patterned chair and I eased into an adjacent couch. The setting was familiar to me, since I had previously interviewed him on other challenging topics for the Case for Christ and the Case for Faith. Both times I found him to have an uncanny ability to discuss abstract issues and technical matters in understandable but accurate language. That's unusual for a scientist, uncommon for a theologian, and downright rare for a philosopher. Moreland's science training came at the University of Missouri, where he received a degree in chemistry. He was subsequently awarded the top fellowship for a doctorate in nuclear chemistry at the University of Colorado but declined the honor to pursue a different career path. He then earned a master's degree in theology at Dallas Theological Seminary and a doctorate in philosophy at the University of Southern California. Moreland developed an early interest in issues relating to human consciousness, returning to that theme time after time in his various books. He has written, edited, or co-authored Christianity and the Nature of Science, Body and Soul, The Life and Death Debate, Beyond Death, Does God Exist? Christian Perspectives on Being Human, The Creation Hypothesis, Scaling the Secular City, Love Your God with All Your Mind, Naturalism, A Critical Analysis, and other books. Also, he has authored more than 50 technical articles for Perspectives on Science and Christian Faith, Philosophy and Phenomenological Research, American Philosophical Quarterly, Journal of Psychology and Theology, Metaphilosophy, and a host of other journals. Moreland's memberships include national scientific, philosophical, and theological societies. Currently, he's a professor in the highly respected philosophy program at the Talbot School of Theology, where he teaches on numerous topics, including philosophy of mind. As we began our interview, I thought it would be a good idea to get straight on some key definitions, something that's not always easy when discussing consciousness. Regaining consciousness. U.S. Supreme Court Justice Potter Stewart once said it may be difficult to define pornography, but I know it when I see it. Similarly, consciousness can be a challenging concept to describe, even though our own conscious thoughts are quite tangible to ourselves. As J. R. Smithies of the University of Edinburgh put it, the consciousness of other people may be for me an abstraction, but my own consciousness is for me a reality. What is consciousness? Moreland said, echoing the opening question that I had just posed to him. Well, a simple definition is that consciousness is what you're aware of when you introspect. When you pay attention to what's going on inside of you, that's consciousness. He looked at me and apparently could see from my expression that I needed a fuller description. Think of it like this, he continued. Suppose you were having an operation on your leg, and suddenly you begin to be aware of people talking about you. Someone says, I think he's recovering. You start to feel an ache in your knee. You say to yourself, where am I? What's going on? And you start to remember you were operated on. What you're doing is regaining consciousness. In short, consciousness consists of sensations, thoughts, emotions, desires, beliefs, and free choices that make us alive and aware. What if consciousness didn't exist in the world? I asked. I'll give you an example, Moreland replied. Apples would still be red, but there would be no awareness of red or any sensations of red. What about the soul? I asked. How would you define that? The soul is the ego, the I, or the self, and it contains our consciousness. It also animates our body. That's why when the soul leaves the body becomes a corpse. The soul is immaterial and distinct from the body. At least, I observed, that's what the Bible teaches. Yes, Christians have understood this for 20 centuries, he said. For example, when Jesus was on the cross, he told the thief being crucified next to him that he would be with Jesus immediately after his death and before the final resurrection of his body. Jesus described the body and soul as being separate entities when he said, "Do not be afraid of those who kill the body but cannot kill the soul." The Apostle Paul says that to be absent from the body is to be present with the Lord. I was curious about whether belief in the soul is a universal phenomenon. What about beyond Christianity? I asked. Is this concept present in other cultures as well? We know that dualism was taught by the ancient Greeks, although, unlike Christians, they believed the body and soul were alien toward each other, he explained. In contemporary terms, I'd agree with physicalist Jae-Kwon Kim, who acknowledged that something like this dualism of personhood, I believe, is common lore shared across most cultures and religious traditions. Still, there are those who deny dualism and instead believe we are solely physical beings who are, as geneticist Francis Crick said, no more than the behavior of a vast assembly of nerve cells and their associated molecules. To explore this issue, I decided to take an unusual approach in my interview with Moreland by asking him to imagine for just a few minutes that these physicalists are right. What if physicalism is true? Let's face it, I said, some people flatly deny that we have an immaterial soul. John Searle said, in my worldview, consciousness is caused by brain processes. In other words, they believe consciousness is purely a product of biology. As brain scientist Barry Beierstein said, just as the kidneys produce urine, the brain produces consciousness. Moreland was listening carefully as I spoke, his head slightly cocked.
I continued by saying, "Do me a favor, J.P. Assume for a moment that the physicalists are right. What are the logical implications if physicalism is true?" His eyes widened. "Oh, there would be several key ones," he replied. "Give me 3, I said. Moreland was more than willing. First, if physicalism is true, then consciousness doesn't really exist, because there would be no such thing as conscious states that must be described from a first-person point of view, he said. You see, if everything were matter, then you could capture the entire universe on a graph. You could locate each star, the moon, every mountain, Lee Strobel's brain, Lee Strobel's kidneys, and so forth. That's because if everything is physical, it could be described entirely from a third-person point of view. And yet we know that we have first-person, subjective points of view, so physicalism can't be true. Clearly, Moreland was warming up to this exercise. The second implication, he continued, is that there would be no free will? That's because matter is completely governed by the laws of nature. Take any physical object, he said as he glanced out the window, where the fog was breaking up. For instance, a cloud, he said. It's just a material object, and its movement is completely governed by the laws of air pressure, wind movement, and the like. So if I'm a material object, all of the things I do are fixed by my environment, my genetics, and so forth. That would mean I'm not really free to make choices. Whatever's going to happen is already rigged by my makeup and environment. So how could you hold me responsible for my behavior if I wasn't free to choose how I would act? This is one of the reasons we lost the Vietnam War. I was following him until that last statement, which seemed oddly incongruous to me. What has this got to do with Vietnam? I asked. Moreland explained, I heard a former advisor to the president say that B.F. Skinner's behaviorism influenced the Pentagon strategy. Skinner believed that we're just physical objects, so you can condition people, just like you can condition a laboratory animal by applying electric shocks. Keep doing certain things over and over, and you can change behavior. So in Vietnam, we bombed, we came back, we bombed, we came back, we bombed, and so forth. We assumed that after we gave the North Vietnamese shock after shock, pretty soon we could manipulate their behavior. After all, they're just physical objects responding to stimuli. Eventually they had to give in. But they didn't, I said. That's right. It didn't work. Why? Because there was more to the Vietnamese than their physical brains responding to stimuli. They have souls, desires, feelings, and beliefs, and they could make free choices to suffer and to stand firm for their convictions despite our attempt to condition them by our bombing. So if the materialists are right, kiss free will goodbye. In their view, we're just very complicated computers that behave according to the laws of nature and the programming we receive. But, Lee, obviously they're wrong. We do have free will. We all know that deep down inside, we're more than just a physical brain. Third, if physicalism were true, there would be no disembodied intermediate state. According to Christianity, when we die, our souls leave our bodies and await the later resurrection of our bodies from the dead. We don't cease to exist when we die. Our souls are living on. This happens in near-death experiences. People are clinically dead, but sometimes they have a vantage point from above, where they look down at the operating table that their body is on. Sometimes they gain information they couldn't have known if this were just an illusion happening in their brain. One woman died and she saw a tennis shoe that was on the roof of the hospital. How could she have known this? If I am just my brain, then existing outside the body is utterly impossible. When people hear of near-death experiences, they don't think that if they looked up at the hospital ceiling, they'd see a pulsating brain with a couple of eyeballs dangling down, right? When people hear near-death stories, Lee, they are intuitively attributing to that person a soul that could leave the body. And clearly these stories make sense, even if we're not sure they're true. We've got to be more than our bodies, or else these stories would be ludicrous to us. Moreland seemed to be sidestepping this issue a bit. How about you personally? I asked. Do you think near-death experiences are true? We have to be careful with the data and not overstate things, but I do think they provide at least a minimalist case for consciousness surviving death, he said.
In fact, as far back as 1965, psychologist John Beloff wrote in The Humanist that the evidence of near-death experiences already indicates a dualistic world where mind or spirit has an existence separate from the world
of material things.
He conceded that this could present a challenge to humanism as profound in its own way as that which Darwinian evolution did to Christianity a century ago.
Moreland paused before adding one other comment.
Regardless of what anyone thinks about near-death experiences, we do have confirmation that Jesus was put to death and was later seen alive by credible eyewitnesses, he said. Not only does this provide powerful historical corroboration that it's possible to survive after the death of our physical body, but it also gives Jesus great credibility when he teaches that we have both a body and an immaterial spirit.
The inner and private mind.
At this point, having considered Moreland's critique of physicalism, I wanted to hear his affirmative case that consciousness and the soul are immaterial entities.
What positive evidence is there that consciousness and the self are not merely a physical process of the brain? I asked.
We have experimental data, for one thing, he replied. For example, neurosurgeon Wilder Penfield electrically stimulated the brains of epilepsy patients and found he could cause them to move their arms or legs, turn their heads or eyes, talk, or swallow. Invariably, the patient would respond by saying, "I didn't do that."
You did.
According to Penfield, the patient thinks of himself as having an existence separate from his body. No matter how much Penfield probed the cerebral cortex, he said, there is no place where electrical stimulation will cause a patient to believe or to decide. That's because those functions originate in the conscious self, not the brain. A lot of subsequent research has validated this. When Roger Sperry and his team studied the differences between the brain's right and left hemispheres, they discovered the mind has a causal power independent of the brain's activities. This led Sperry to conclude materialism was false. 4. Another study showed a delay between the time an electric shock was applied to the skin, its reaching the cerebral cortex, and the self-conscious perception of it by the person.
This suggests the self is more than just a machine that reacts to stimuli as it receives them.
In fact, the data from various research projects are so remarkable that Lawrence C. Wood said, many brain scientists have been compelled to postulate the existence of an immaterial mind, even though they may not embrace a belief in an afterlife.
What about beyond the laboratory? I asked.
There are valid philosophical arguments as well, he said. For instance, I know that consciousness isn't a physical phenomenon because there are things that are true of my consciousness that aren't true of anything physical. For instance, I said, prompting him further.
For example, some of my thoughts have the attribute of being true.
Tragically, some of my thoughts have the attribute of being false, like the Chicago Bears are going to go to the Super Bowl, he said with a chuckle.
However, none of my brain states are true or false.
No scientist can look at the state of my brain and say, oh, that particular brain state is true and that one's false. So there's something true of my conscious states that are not true of any of my brain states, and consequently they can't be the same thing.
Nothing in my brain is about anything. You can't open up my head and say, you see this electrical pattern in the left hemisphere of J.P. Moreland's brain? That's about the Bears.
Your brain states aren't about anything, but some of my mental states are.
So they're different.
Furthermore, my consciousness is inner and private to me.
By simply introspecting, I have a
way of knowing about what's happening in my mind that is not available to you, my doctor, or a neuroscientist. A scientist could know more about what's happening in my brain than I do, but he couldn't know more about what's happening in my mind than I do.
He has to ask me.
When I asked Moreland for an illustration of this, he said,
have you heard of rapid eye movement?
Sure, I replied.
What does it indicate? Dreaming. Exactly. How do scientists know that when there is a certain eye movement that people are dreaming? They've had to wake people and ask them.
Scientists could watch the eyes move and read a printout of what was physically happening in the brain, so they could correlate brain states with eye movements.
But they didn't know what was happening in the mind. Why? Because that's inner and private.
So the scientist can know about the brain by studying it, but he can't know about the mind without asking the person to reveal it, because conscious states have the feature of being inner and private, but the brain states don't. The reality of the soul. For centuries, the human soul has enchanted poets, intrigued theologians, challenged philosophers, and dumbfounded scientists. Mystics, like Teresa of Avila in the 16th century, have described it eloquently. I began to think of the soul as if it were a castle made of a single diamond or a very clear crystal, in which there are many rooms, just as in heaven there are many mansions. Moreland was understandably more precise in analyzing the soul, though unfortunately less poetic. He had already clarified that the soul contains our consciousness. Still, he hadn't offered any reason to believe that the soul is an actual entity. It was time, I felt, to press him on this issue. What makes you think that the soul is real? I asked. Moreland replied by saying, first, we're aware that we're different from our consciousness and our body. We know that we're beings who have consciousness and a body, but we're not merely the same thing as our conscious life or our physical life. Let me give you an illustration of how we're not the same thing as our personality traits, our memories, and our consciousness. I had a student a few years ago whose sister had a terrible accident on her honeymoon. She was knocked unconscious and lost all of her memories and a good bit of her personality. She did not believe she had been married. As she began to recover, they showed her videos of the wedding to convince her that she had actually married her husband. She eventually got to the point where she believed it, and she got remarried to him. Now, we all knew this was the same person all along. This was Janie's sister. She was not a different person, though she was behaving differently. But she had totally different memories. She had lost her old memories and she didn't even have the same personality. What that proves is you can be the same person even if you lose old memories and gain new memories, or you lose some of your old personality traits and gain new personality traits. Now, if I were just my consciousness, when my consciousness was different, I'd be a different person. But we know that I can be the same person even though my consciousness changes, so I can't be the same thing as my consciousness. I've got to be the self, or soul, that contains my consciousness. Same with my body. I can't be the same thing as my body or brain. There was a story on television about an epileptic who underwent an operation in which surgeons removed 53% of her brain. When she woke up, nobody said, "We have 47% of a person here." A person can't be divided into pieces. You are either a person or you're not. But your brain and your body can be divided. So that means I can't be the same thing as my body. Those illustrations helped, though I said, the fact that the soul and consciousness are invisible makes it difficult to conceptualize them. Sure, that's true, he replied. My soul and my consciousness are invisible, though my body is visible. That's another distinction. In fact, I remember the time when my daughter was in the 5th grade and we were having family prayers. She said, "Dad, if I could see God, it would help me believe in Him." I said, "Well, honey, the problem isn't that you've never seen God. The problem is that you've never seen your mother." And her mother was sitting right next to her. My daughter said, "What do you mean, Dad?" I said, "Suppose without hurting your mom, we were able to take her apart cell by cell and peek inside each one of them. We would never come to a moment where we would say, 'Look, here's what mommy's thinking about doing the rest of the day.' Or, 'Hey, this cell contains mommy's feelings.' Or, 'So this is what mom believes about pro football.' We couldn't find mommy's thoughts, beliefs, desires, or her feelings. Guess what else we would never find? We'd never find mommy's ego or herself. We would never say, 'Finally, in this particular brain cell, there's mommy. There's her ego, or self.' That's because mommy is a person, and persons are invisible. Mommy's ego and her conscious life are invisible. Now, she's small enough to have a body, while God is too big to have a body, so let's pray. The point is this, Lee, I am a soul, and I have a body. We don't learn about people by studying their bodies. We learn about people by finding out how they feel, what they think, what they're passionate about, what their worldview is, and so forth. Staring at their body might tell us whether they like exercise, but that's not very helpful.
That's why we want to get inside people to learn about them.
So my conclusion is that there's more to me than my conscious life and my body. In fact, I am a self, or an I, that cannot be seen or touched unless I manifest myself through my behavior or my talk. I have free will because I'm a self, or a soul, and I'm not just a brain.
Of computers and bats.
Moreland's denial that the brain produces consciousness made me think of the debate over whether future computers can become sentient. I decided to ask him to weigh in on the issue, although his ultimate conclusion was never in doubt.
If a machine can achieve equal or greater brainpower as human beings, then some physicalists say the computer would become conscious, I said. I assume you would disagree with that.
Moreland chuckled. One atheist said that when computers reach the point of imitating human behavior, only a racist would deny them full human rights. But of course that's absurd.
Nobel winner John Eccles said he's appalled by the naivete of those who foresee computer sentience.
He said there's no evidence whatsoever for the statement made that, at an adequate level of complexity, computers also would achieve self-consciousness.
Look, we have to remember that computers have artificial intelligence, not intelligence.
And there's a huge difference.
There's no what it's like to be a computer.
A computer has no insides, no awareness, no first-person point of view, no insights into problems.
A computer doesn't think, you know what? I now see what this multiplication problem is really like.
A computer can engage in behavior if it's wired properly, but you've got to remember that consciousness is not the same as behavior.
Consciousness is being alive, it's what causes behavior in really conscious beings. But what causes behavior in a computer is electric circuitry. Let me illustrate my point. Suppose we had a computerized bat that we knew absolutely everything about from a physical point of view.
We would have exhaustive knowledge of all its circuitry so that we could predict everything this bat would do when it was released into the environment.
Contrast that with a real bat.
Suppose we knew everything about the organs inside the bat: its blood system, nervous system, brain, heart, lungs.
And suppose that we could predict everything this bat would do when released into the environment. There would still be one thing that we would have no idea about: what it's like to be a bat.
What it's like to hear, to feel, to experience sound and color.
That stuff involves the insides of the bat, its point of view. That's the difference between a conscious, sentient bat and a computerized bat.
So in general, computers might be able to imitate intelligence, but they won't ever have consciousness. We can't confuse behavior with what it's like to be alive, awake, and sentient. A future superintelligent computer might be programmed to say it's conscious or even behave as if it were conscious, but it can never truly become conscious, because consciousness is an immaterial entity apart from the brain.
Moreland's choice of a bat for his illustration was an oblique reference to New York University philosopher Thomas Nagel's famous 1974 essay, What Is It Like to Be a Bat? Thinking about life from a bat's perspective prompted me to briefly pursue another line of inquiry on a tangential topic. What about animals? Do they have souls or consciousness? I asked. Absolutely, came his quick answer.
In several places the Bible uses the word soul or
spirit when discussing animals.
Animals are not simply machines.
They have consciousness and points of view. But the animal soul is much simpler than the human soul. For example, the human soul is capable of free moral action, but I think the animal soul is determined.
Also, Augustine said animals have thoughts, but they don't think about their thinking. And while we have beliefs about our beliefs, animals don't. You see, the human soul is vastly more complicated because it's made in the image of God.
So we have self-reflection and self-thinking.
And while the human soul survives the death of its body, I don't think the animal soul outlives its body. I could be wrong, but I think the animal soul ceases to exist at death.
Bad news, it seems, for the bat. Consciousness and evolution.
Moreland had made a cogent case for consciousness and the soul being independent of our brain and body.
How does this present a problem for Darwinists? I asked.
Moreland glanced down at some notes he had brought along. As philosopher Jeffrey Medell said, the emergence of consciousness, then, is a mystery, and one to which materialism fails to provide an answer.
Atheist Colin McGinn agrees. He asks, how can mere matter originate consciousness? How did evolution convert the water of biological tissue into the wine of consciousness? Consciousness seems like a radical novelty in the universe, not prefigured by the aftereffects of the Big Bang. So how did it contrive to spring into being from what preceded it? Moreland looked squarely at me. Here's the point, you can't get something from nothing, he declared. It's as simple as that.
If there were no God, then the history of the entire universe, up until the appearance of living creatures, would be a history of dead matter with no consciousness. You would not have any thoughts, beliefs, feelings, sensations, free actions, choices, or purposes. There would be simply one physical event after another physical event, behaving according to the laws of physics and chemistry.
Moreland stopped for a moment to make sure this picture was vivid in my mind. Then he leaned forward and asked pointedly, how, then, do you get something totally different conscious, living, thinking, feeling, believing creatures from materials that don't have that? That's getting something from nothing. And that's the main problem.
If you apply a physical process to physical matter, you're going to get a different arrangement of physical materials. For example, if you apply the physical process of heating to a bowl of water, you're going to get a new product steam, which is just a more complicated form of water, but it's still physical. And if the history of the universe is just a story of physical processes being applied to physical materials, you'd end up with increasingly complicated arrangements of physical materials, but you're not going to get something that's completely non-physical.
That is a jump of a totally different kind.
At the end of the day, as Philip Johnson put it, you either have in the beginning were the particles, or in the beginning was the logos, which means divine mind. If you start with particles, and the history of the universe is just a story about the rearrangement of particles, you may end up with a more complicated arrangement of particles, but you're still going to have particles. You're not going to have minds or consciousness. However, and this is really important, if you begin with an infinite mind, then you can explain how finite minds could come into existence.
That makes sense. What doesn't make sense, and which many atheistic evolutionists are conceding, is the idea of getting a mind to squirt into existence by starting with brute, dead, mindless matter. That's why some of them are trying to get rid of consciousness by saying it's not real and that we're just computers.
He smiled after that last statement, then added, however, that's a pretty difficult position to maintain while you're conscious.
The emergence of the mind. Still, I protested, some scientists maintain that consciousness is just something that happens as a natural byproduct of our brain's complexity. They believe that once evolution gave us sufficient brain capacity, consciousness inexorably emerges as a biological process.
Let me mention 4 problems with that, Moreland insisted. First, they are no longer treating matter as atheists and naturalists treat matter, namely, as brute stuff that can be completely described by the laws of chemistry and physics. Now they're attributing spooky, soulish, or mental potentials to matter.
What do you mean by potentials?
They're saying that prior to this level of complexity, matter contained the potential for mind to emerge, and at the right moment, guess what happened?
These potentials were activated and consciousness was sparked into existence. What's wrong with that theory? That is no longer naturalism, he said. That's panpsychism. That was a new term to me. Pan what? Panpsychism, he repeated. It's the view that matter is not just inert physical stuff, but that
it also contains proto-mental states in it.
Suddenly, they've abandoned a strict scientific view of matter and adopted a view that's closer to theism than to atheism.
Now they're saying that the world began not just with matter, but with stuff that's mental and physical at the same time. Yet they can't explain where these pre-emergent mental properties came from in the first place. And this also makes it hard for them to argue against the emergence of God.
The emergence of God? I asked. What do you mean by that? If a finite mind can emerge when matter reaches a certain level of complexity, why couldn't a far greater mind God emerge when millions of brain states reach a greater level of consciousness?
You see, They want to stop the process where they want it to stop at themselves, but you can't logically draw that line. How can they know that a very large God hasn't emerged from matter? Because, after all, haven't a lot of people had religious experiences with God? That wouldn't be the God of Christianity, I pointed out. Granted, he replied. But this is still a problem for atheists. And there's a second problem: they would still be stuck with determinism, because if consciousness is just a function of the brain, then I'm my brain, and my brain functions according to the laws of chemistry and physics. To them, the mind is to the brain as smoke is to fire. Fire causes smoke, but smoke doesn't cause anything. It's just a byproduct. Thus, they're locked into determinism. Third, if mind emerged from matter without the direction of a superior intelligence, why should we trust anything from the mind as being rational or true, especially in the area of theoretical thinking? Let me give you an analogy. Let's say you had a computer that was programmed by random forces or by non-rational laws without a mind being behind it. Would you trust a printout from that machine? Of course not. Well, same with the mind, and that's a problem for Darwinists. And by the way, you can't use evolution as an explanation for why the mind should be considered trustworthy, because theoretical thinking does not contribute to survival value. Moreland's comments reminded me of the famous quote from British evolutionist J.B.S. Haldane: "If my mental processes are determined wholly by the motions of the atoms in my brain, I have no reason to suppose that my beliefs are true, and hence I have no reason for supposing my brain to be composed of atoms." Here's the fourth problem, Moreland went on: if my mind were just a function of the brain, there would be no unified self. Remember, brain function is spread throughout the brain, so if you cut the brain in half, like the girl who lost 53% of her brain, then some of that function is lost. Now you've got 47% of a person. Well, nobody believes that. We all know she's a unified self, because we all know her consciousness and soul are separate entities from her brain. There's one other aspect of this, called Thebending problem. When you look around the room, you see many things at the same time, he said, gesturing around at various objects in our field of vision. You see a table, a couch, a wall, a painting in a frame. Every individual thing has light waves bouncing off of it, and they're striking a different location in your eyeball and sparking electrical activity in a different region of the brain. That means there is no single part of the brain that is activated by all of these experiences. Consequently, if I were simply my physical brain, I would be a crowd of different parts, each having its own awareness of a different piece of my visual field. But that's not what happens. I'm a unified I that has all of these experiences at the same time. There is something that binds all of these experiences and unifies them into the experience of oneself, me, even though there is no region of the brain that has all these activation sites. That's because my consciousness and myself are separate entities from the brain. Moreland was on a roll, but I jumped in anyway. What about recent brain studies that have shown activity in certain areas of the brain during meditation and prayer? I asked. Don't those demonstrate that there's a physical basis for these religious experiences, as opposed to an immaterial basis through the soul? No, it doesn't. All it shows is a physical correlation with religious experiences, he replied. You'll have to explain that, I said. Well, there's no question that when I'm praying, smelling a rose, or thinking about something, my brain still exists. It doesn't pop out of existence when I'm having a conscious life, including prayer. And I would be perfectly happy if scientists were to measure what was going on in my brain while I'm praying, feeling forgiveness, or even thinking about lunch. But remember, just because there is a correlation between two things, that doesn't mean they're the same thing. Just because there's a correlation between fire and smoke, this doesn't mean smoke is the same as fire. Now, sometimes your brain states can cause your conscious states. For example, if you lose brain functioning due to Alzheimer's disease, or you get hit over the head, you lose some of your mental conscious life. But there's also evidence that this goes the other way as well. There are data showing that your conscious life can actually reconfigure your brain. For example, scientists have done studies of the brains of people who worried a lot, and they found that this mental state of worry changed their brain chemistry. They've done studies of the brain patterns of little children who were not nurtured and loved, and their patterns are different than children who have warm experiences of love and nurture. So it's not just the brain that causes things to happen in our conscious life. Conscious states can also cause things to happen to the brain. Consequently, I wouldn't want to say there's a physical basis for religious experiences, even though they might be correlated. Sometimes it could be cause and effect from brain to mind, but it could also be cause and effect from mind to brain. How do the scientists know it isn't actually my prayer life that's causing something to happen in my brain, rather than the other way around? The return of Occam's razor. As we talked about the human mind, mine was drifting back to my first interview with William Lane Craig, during which he brought up a scientific principle called Occam's razor. As I listened to Moreland defend the concept of dualism, it dawned on me that Occam's razor would argue in the opposite direction toward the view that only the brain exists because it says science prefers simpler explanations where possible. It was a challenge I decided to pose to Moreland. "You're familiar with the scientific principle called Occam's razor," I said to him. As soon as the question left my mouth, Moreland knew where I was headed. "Yes, it says that we shouldn't multiply entities beyond what's needed to explain something. And I assume your objection is that Occam's razor would favor a simple alternative, such as the brain accounting for everything, rather than more complicated explanation like the two entities of dualism." "That's right," I said. "Surely this undercuts the case for dualism." He was ready with an answer. "No, it really doesn't. Actually, Occam's razor favors dualism, and here's why," he said. "What's the intent of Occam's razor?" The thrust of this principle is that when you're trying to explain a phenomenon, you should only include the elements that are necessary to explain the phenomenon. And as I've demonstrated through scientific evidence and philosophical reasoning, dualism is necessary to explain the phenomenon of consciousness. Only dualism can account for all of the evidence and, hence, it does not violate Occam's razor. I wasn't ready to give up. "But maybe we just don't have all the evidence yet," I said. "Maybe your conclusions are premature." Physicalists are confident that the day will come when they'll be able to explain consciousness solely in physical terms. Moreland's reply was adamant: there will never, ever be a scientific explanation for mind and consciousness. His forceful and unequivocal statement startled me. "Why not?" I asked. "Think about how scientists go about explaining things. They show that something had to happen due to antecedent conditions. For example, when scientists explain why gases behave the way they do, they show that if you hold the volume constant and increase the temperature, the pressure has to increase. That is, when we heat a pressure cooker, the pressure goes up. When scientists explain that, they don't just correlate temperature and pressure. They don't just say that temperature and pressure tend to go together. They try to show why the pressure has got to increase, why it couldn't have done anything other than that, given the temperature increase. Scientists want to show why something has to happen given the cause. They're not content simply to correlate things and leave it at that. And this will never work with consciousness, because the relationship between the mind and the brain is contingent or dependent. In other words, the mind is not something that had to happen. One atheist asked, how could a series of physical events, little particles jostling against one another, electric currents rushing to and fro, blossom into conscious experience? Why shouldn't pain and itches be switched around? Why should any experience emerge when these neurons fire in the brain? He's pointing out that there's no necessary connection between conscious states and the brain. So in the future scientists will be able to develop more correlations between conscious states and states of the brain, and that's wonderful. But my point is this: correlation is not explanation. To explain something scientifically, you've got to show why the phenomenon had to happen given the causes. And scientists cannot explain theory behind consciousness, because there's no necessary connection between the brain and consciousness. It didn't have to happen this way. Deductions about God. It's no wonder that Alvin Plantinga of Notre Dame University, a dualist who is frequently called the greatest living American philosopher, surveyed the current body-slash-mind debate and concluded, things don't look hopeful for Darwinian naturalists. faced with data and logic that support dualism, and unable to offer a plausible theory for how consciousness could have erupted from mindless matter, atheists are pinning their hopes on some aciaton-determined scientific discovery to justify their faith in physicalism. And some aren't even so sure about that. Physicist and atheist Steven Weinberg said scientists may have to bypass the problem of human consciousness altogether, because it may just be too hard for us. In other words, it's failing to give them the answers they want. As for Moreland, he agrees with Plantinga's bleak assessment for atheists. Darwinian evolution will never be able to explain the origin of consciousness, he told me. Perhaps Darwinists can explain how consciousness was shaped in a certain way over time, because the behavior that consciousness caused had survival value. But it can't explain the origin of consciousness, because it can't explain how you can get something from nothing. In Darwin's notebooks, he said if there was anything his theory can't explain, then there would have to be another explanation, a creationist explanation. Well, he can't explain the origin of mind. He tried to reduce consciousness down to the brain, because he could tell a story about how the brain evolved. But as we've discussed, consciousness cannot be reduced merely to the physical brain. This means the atheist creation story is inadequate and false. And yet there is an alternative explanation that makes sense of all the evidence: our consciousness came from a greater consciousness. You see, the Christian worldview begins with thought and feeling and belief and desire and choice. That is, God is conscious. God has thoughts. He has beliefs, he has desires, he has awareness, he's alive, he acts with purpose. We start there. And because we start with the mind of God, we don't have a problem with explaining the origin of our mind. I asked, what, then, can we deduce about God from this? That he's rational, that he's intelligent, that he's creative, that he's sentient. And that he's invisible, because that's the way conscious beings are. I have no inclination to doubt that this very room is teeming with the presence of God, just because I can't see or touch or smell or hear him. As I explained earlier, I can't even see my own wife. I can't touch, see, smell, or hear the real her. One more thing. The existence of my soul gives me a new way to understand how God can be everywhere. That's because my soul occupies my body without being located in any one part of it. There's no place in my body where you can say, here I am. My soul is not in the left part of my brain, it's not in my nose, it's not in my lungs. My soul is fully present everywhere throughout my body. That's why if I lose part of my body, I don't lose part of my soul. In a similar way, God is fully present everywhere. He isn't located, say, right outside the planet Mars. God occupies space in the same way the soul occupies the body. If space were somehow cut in half, God wouldn't lose half his being. So now I have a new model, based on my own self, for God's omnipresence. And shouldn't we expect this? If we were made in the image of God, wouldn't we expect there to be some parallels between us and God? I asked, do you foresee more scientists coming to the conclusion that the soul, though immaterial, is very real? The answer is yes if they are willing to open themselves up to non-scientific knowledge, he replied. I believe in science, it's wonderful and gives us some very important information. But there are other ways of knowing things as well. Because, remember, most of the evidence for the reality of consciousness and the soul is from our own first-person awareness of ourselves and has nothing to do with the study of the brain. The study of the brain allows us to correlate the brain with conscious states, but it tells us nothing about what consciousness itself is. But, J.P., aren't you asking scientists to do the unthinkable, to ignore scientific knowledge? No, not at all, he insisted. I'm only asking that they become willing to listen to all the evidence and see where it leads, which is what the quest for truth should be about. And if they do that, they will come to believe in the reality of the soul and the immaterial nature of consciousness. And this could open them up personally to something even more important, to a much larger mind and a much bigger consciousness, who in the beginning was the Logos, and who made us in his image. Cogito ergo sum. A ringing telephone ended our conversation, although I was wrapping up the interview anyway. A colleague was calling to remind Moreland of a faculty meeting. I thanked Moreland for his time and insights, gathered my things, and strolled out to my car. I was just about to start the engine, but instead I let go of the key, leaned back in my seat, and took a few moments, as Moreland would say, to introspect. Interestingly, this very act of introspection intuitively affirmed to me what Moreland's facts and logic had already established: my ability to ponder, to reason, to speculate, to imagine, and to feel. The emotional brunt of the interview showed that my mind surely could not have been the evolutionary byproduct of brute, mindless matter. Selfhood is not explicable in material or physical terms, said philosopher Stuart C. Hackett. The essential spiritual selfhood of man has its only adequate ground in the transcendent spiritual selfhood of God as absolute mind. In other words, I am more than just the sum total of a physical brain and body parts. Rather, I am a soul, and I have a body. I think, therefore, I am. Or as Hackett said, with modest apology to Descartes, cogito, ergo Deus est. I think, therefore God is. I found myself wholeheartedly agreeing with philosopher Robert Augrose and physicist George Stanciu, who explored the depths of the mind/body controversy and concluded that physics, neuroscience, and humanistic psychology all converge on the same principle: mind is not reducible to matter. They added, the vain expectation that matter might someday account for mind is like the alchemist's dream of producing gold from lead. I leaned forward and started the car. After months of investigating scientific evidence for God, traveling a total of 26,884 miles, which is the equivalent of making one lap around the Earth at the equator, I had finally reached a critical mass of information. It was time to synthesize and digest what I had learned and ultimately to come to a conclusion that would have vast and life-changing implications. Chapter 11. The Cumulative Case for a Creator. The vast mysteries of the universe should only confirm our belief in the certainty of its creator. I find it as difficult to understand a scientist who does not acknowledge the presence of a superior rationality behind the existence of the universe as it is to comprehend a theologian who would deny the advances of science. Wernher von Braun, the father of space science. Faith does not imply a closed, but an open mind. Quite the opposite of blindness, faith appreciates the vast spiritual realities that materialists overlook by getting trapped in the purely physical. Sir John Templeton. Standing boldly in front of the national media, his posture like a boxer ready to pounce, the cocky prosecutor shook his finger at 5 television cameras and taunted renowned defense attorney William F. Neal. "I defy Mr. Neal," he declared, "to stop that Pinto." His words became a rally cry, challenging Neal to establish that a Ford Pinto containing 3 teenage girls had come to a halt on an Indiana highway before being struck from behind by a Chevy van. It was yet another moment of high drama in a groundbreaking criminal trial that had captivated the nation. In the first case of its kind in U.S. history, prosecutors blamed the girls' deaths on the car's manufacturer, charging Ford Motor Company with reckless homicide for allegedly designing a vehicle that was prone to explode in low to moderate speed rear crashes. If the Pinto had been safe, the prosecutors contended, the 3 teenagers would have walked away virtually unscathed from the relatively minor collision. But, they said, because the car's gas tank had been located in a vulnerable position, the car erupted in a fireball that consumed them all. A pivotal issue was the severity of the crash. Neal maintained that the Pinto had been stopped on the highway and the van was traveling at 50 miles an hour. No subcompact could have withstood the assault of the van in this case, Neal told the jurors. The prosecutor, however, countered that the Pinto had been moving in the same direction as the van, which meant the force of the impact would have been much less. Indeed, a few eyewitnesses testified the car had been in motion, though their accounts varied and during cross-examination Neal sought to raise doubts about the vantage points from which they saw the Pinto. Then the prosecutor presented his star witness, the shaggy-haired, 21-year-old driver of the van, who had not been criminally charged for the crash and was cooperating with the prosecution. He testified that the Pinto had been moving at 15 to 20 miles an hour when they collided. Neal scoffed, pointing out that the distracted driver had only seen the Pinto for 1/6 of a second before hitting it. But the driver, who had 5 previous traffic convictions in 3 years, stuck to his story. In the glare of the television cameras, the prosecutor was ebullient. Feeling confident in the thoroughness of his investigation and believing Neal could offer no contradictory testimony, he defiantly challenged Neal to make good on his promise that he would stop the Pinto. Surprisingly, however, the prosecutor's bravado was short-lived. A few days later, to the astonishment of the prosecution, Neil used both negative and positive evidence to accomplish what the prosecutor was convinced he could never do. First, Neil undermined the testimony of the van's driver. The physician who had treated him for minor injuries said the driver had admitted to him that the Pinto had been stopped. That was damaging enough for the prosecution. Even more devastating, Neil then presented two surprise witnesses that police had somehow overlooked during their supposedly exhaustive investigation. Both were hospital workers who testified that the driver of the Pinto told them independently before her death that she had been stopped on U.S. Highway 133 when the van struck her car. The prosecutor was stunned. In a flash, these two unforeseen witnesses changed the entire momentum of the trial. Nobody knew anything about them, the prosecutor sputtered. They came out of the blue. Outside the courtroom, Neil was ecstatic. The prosecutor challenged us to stop that Pinto. He said, stifling a chuckle. Well, now we've stopped it twice. The once confident prosecutor, now publicly embarrassed, found himself on the defensive as reporters pelted him with questions about why his investigation had failed to unearth these witnesses. Ultimately, after several judicial rulings further eroded the prosecutor's case, jurors voted to acquit the automaker. Neil's performance, which I documented in my book Reckless Homicide, was among the most masterful I had ever seen in my years as a legal affairs journalist. His success was not the product of adroit legal maneuvering, clever arguments, or courtroom sleight of hand. Plain and simple, it was old-fashioned, dogged detective work that uncovered the surprise witnesses. Defense investigators went beyond the obvious, posed questions that others weren't asking, out-hustled police investigators, and followed the clues wherever they led. Years later, I would understand exactly how the prosecutor felt that day. I was once full of confidence that Darwinism justified my atheism. I felt I had investigated the issue sufficiently, having studied biology, chemistry, geology, anthropology, and other sciences in school and having read books that reinforced my beliefs. No doubt about it, natural selection acting on random variation had put God out of a job. When Christians approached me about the evidence for their faith, I was as defiant as the combative prosecutor on the courthouse steps. The origin of species trumped the Bible. The critical thinking of scientists overpowered the wishful thinking of theists. To me, the case was closed. But then, prompted by the positive changes in my wife after she became a follower of Jesus, I began to go beyond the obvious, to set aside my prejudices, to ask questions I had never posed before, and to pursue the clues of science and history wherever they led. Instead of letting naturalism limit my search, I opened myself to the full range of possibilities. And, frankly, I wasn't prepared for what would happen. Like the negative evidence that undermined the van's driver in the Pinto case, the facts of science systematically eroded the foundation of Darwinism until it could no longer support the weight of my atheistic conclusions. Suddenly, the intellectual basis for my skepticism was collapsing. That was disconcerting enough. But then, like the surprise witnesses who suddenly shifted the momentum at the Indiana trial, my wide-ranging research was building an unexpected affirmative case for the existence of a creator. Yes, I was stunned. Yes, I felt like the wind was being knocked out of me. Yes, it was unnerving to wrestle with the implications. But I had vowed to follow the facts regardless of the cost, even at the cost of my own smug self-sufficiency. A fresh examination of the evidence. I was reminded of the Pinto trial as I sat in my home office and glanced over at a shelf where my eye caught the book I had written on the case. As I started reminiscing about the unanticipated turnaround in that courtroom drama, my thoughts drifted to the emotions I felt on November 8, 1981. It was on that day, after nearly 2 years of intensive research, that I sat alone in my room and wrote down the key evidence I had discovered during my original investigation into the credibility of Christianity. Much of it concerned the facts regarding the life, teachings, miracles, death, and resurrection of Jesus of Nazareth, as I described in my book The Case for Christ, and the answers to the Big 8 objections to Christianity, as I recounted in The Case for Faith. But also very important at the time were the corroborating scientific facts. Even though there was less evidence than is readily available today, there was still plenty upon which to reach a verdict. I can remember analyzing the scientific research and coming to the startling conclusion that the data of the physical world point powerfully toward the existence of a creator. What seemed impossible 2 years earlier now seemed not just possible, not just likely but obvious. Like the Pinto prosecutor, I was dismayed and disoriented, and yet at the same time I felt confident and even strangely comforted by the conclusion. Now, more than 2 decades later, having spent over a year re-evaluating and updating the case for a creator by interviewing experts on the latest scientific discoveries, I sat at my desk once more and mentally reviewed the most current evidence I had encountered. I was amazed at how new findings in physics, astronomy, biochemistry, and other disciplines have added so much to the pool of scientific knowledge. As I considered the evidence afresh, I tried to honestly weigh which hypothesis, Darwinism or design, best accounted for the most current data of science.
Possibility number 1, the Darwinism hypothesis.
To start with, I considered how the facts fit the hypothesis that all of life can be explained by the undirected, purely naturalistic processes of evolution. Like all other scientific theories, Darwinian evolution must be continually compared with the evidence, said biologist Jonathan Wells. If it does not fit the evidence, it must be re-evaluated or abandoned, otherwise it is not science, but myth. Looking at the doctrine of Darwinism, which undergirded my atheism for so many years, it didn't take me long to conclude that it was simply too far-fetched to be credible.
I realized that if I were to embrace Darwinism and its underlying premise of naturalism, I would have to believe that nothing produces everything. Non-life produces life.
Randomness produces fine-tuning.
Chaos produces information. Unconsciousness produces consciousness.
Non-reason produces reason. Based on this, I was forced to conclude that Darwinism would require a blind leap of faith that I was not willing to make. Simply put, the central pillars of evolutionary theory quickly rotted away when exposed to scrutiny. For example, naturalistic processes have utterly failed to explain how non-living chemicals could somehow self-assemble into the first living cell. Not only are there no viable theories, but none are on the horizon. Biochemist Klaus Does, one of the leading origin of life experts, conceded, at present all discussions on principal theories and experiments in the field either end in stalemate or in a confession of ignorance. Science writer Robert Roybrit cast the problem more colorfully. Have you ever had one of those dreams where you try to run from a monster and your legs go round and round but you don't get anywhere?
The quest to understand the origin of life isn't much different. Stephen C. Meyer pointed out in my interview that there are insurmountable hurdles involving the origin of biological information that simply cannot be resolved by more research and effort.
In other words, origin of life scientists are not going to wake up from their nightmare. To me, this constitutes the Achilles heel of evolutionary theory. As biochemist Michael Denton observed, the idea that undirected processes could somehow turn dead chemicals into all the extraordinary complexity of living things is surely no more nor less than the great cosmogenic myth of our times.
In addition, the overall fossil record has stubbornly refused to confirm the grand claims of Darwinian transitions.
Despite innumerable discoveries since Darwin's day, the intermediates have remained as elusive as ever, said Denton. Rather than harmonize into a consistent case for Darwin's theory, the fossils are a discordant cacophony that cannot reasonably account for the monumental leaps Darwinism must make, for example, between fish and amphibians or amphibians and reptiles.
The most glaring deficiency of the fossil record is biology's Big Bang, the Cambrian explosion.
The majority or, according to some experts, all of the world's 40 phyla, the highest category in the animal kingdom, virtually sprang forth with unique body plans more than 500 million years ago. The sudden appearance of these radically new life forms, devoid of prior transitions, has turned Darwin's tree of life on its head.
Like the overconfident prosecutor in the Pinto case, Darwin predicted that new discoveries would explain away this quantum leap in biological complexity.
In reality, they have only made matters worse.
The excuse that the transitionary creatures were too soft or small to be fossilized withers under examination.
Alternate theories, like Stephen Jay Gould's punctuated equilibrium, dash themselves on the rocks of reason.
Darwin's assessment is still accurate more than a century and a half later. The Cambrian explosion is inexplicable under his hypothesis.
This remains, in my opinion, a fatal shortcoming. When I examined these and other deficiencies of Darwinism as objectively as I could, I became firmly convinced that evolution is a confirmed fact as long as it's defined as the microevolutionary variations we see in the animal and plant world. Undeniably, a considerable amount of change and diversification has taken place over time.
However, there is simply insufficient evidence from which to draw the radical conclusion that large-scale, macroevolutionary transitions have occurred.
As award-winning author Roger Lewin, a former editor with Science and New Scientist magazines, summarized a historic scientific conference on macroevolution, the central question was whether the mechanisms underlying microevolution can be extrapolated to explain the phenomenon of macroevolution. At the risk of doing violence to the position of some people at the meeting, the answer can be given as a clear no. In short, the amount of faith needed to maintain belief in the most sweeping and controversial claims of Darwinism far exceeded what I believed was reasonably warranted by the hard evidence of science. On top of that, naturalism has absolutely no credible explanation for how the universe came into being in the first place. This failure of the naturalistic and Darwinist ideas opened the door to considering the other hypothesis that both the universe and the life it contains are the product of an intelligent designer.
Possibility number 2, the design hypothesis.
A big, fundamental question, like belief in God, or disbelief, is not settled by a single argument, said physicist-turned-theologian John Polkinghorne.
It's too complicated for that.
What one has to do is to consider lots of different issues and see whether or not the answers one gets add up to a total picture that makes sense.
That's the approach I took in my investigation.
I probed 6 different scientific disciplines to see whether they point toward or away from the existence of an intelligent designer. When I opened my mind to the possibility of an explanation beyond naturalism, I found that the design hypothesis most clearly accounted for the evidence of science.
The explanatory power of the design hypothesis outstripped every other theory.
Consider some of the facts that were adduced in my investigation.
The evidence of cosmology.
Thanks to scientific discoveries of the last 50 years, the ancient Callum cosmological argument has taken on a powerful and persuasive new force.
As described by William Lane Craig, the argument is simple yet elegant. First, whatever begins to exist has a cause. Even renowned skeptic David Hume didn't deny this first premise.
In fact, atheist Quinton Smith's contention that we came from nothing, by nothing, and for nothing seems intuitively absurd.
Second, the universe had a beginning.
Based on the data, virtually all cosmologists now agree the universe began in the Big Bang at some specific point in the past. Craig stressed that even alternate theories for the origin of the universe require a beginning. For instance, Stephen Hawking's use of imaginary numbers merely conceals the beginning point in his own model, which Hawking admits is not really a description of reality. The conclusion then follows inexorably from the two premises, therefore, the universe has a cause. Even once agnostic astronomer Robert Jastrow conceded the essential elements of Christianity and modern cosmology are the same. The chain of events leading to man commenced suddenly and sharply, at a definite moment in time, in a flash of light and energy.
The evidence of physics.
One of the most striking discoveries of modern science has been that the laws and constants of physics unexpectedly conspire in an extraordinary way to make the universe habitable for life. For instance, said physicist-philosopher Robin Collins, gravity is fine-tuned to 1 part in 100 million billion 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 billion.
The cosmological constant, which represents the energy density of space, is as precise as throwing a dart from space and hitting a bullseye just a trillionth of an inch in diameter on Earth.
One expert said there are more than 30 physical or cosmological parameters that require precise calibration in order to produce a universe that can sustain life.
Collins demonstrated that chance cannot reasonably account for this anthropic principle and that the most discussed alternative that there are multiple universes lacks any evidential support and ultimately collapses upon the realization that these other worlds would owe their existence to a highly designed process.
This evidence was so powerful that it was instrumental in Patrick Glynn abandoning his atheism. Today the concrete data point strongly in the direction of the God hypothesis, he said. It is the simplest and most obvious solution to the anthropic puzzle.
The evidence of astronomy. Similar to the fine-tuning of physics, Earth's position in the universe and its intricately choreographed geological and chemical processes work together with exquisite efficiency to create a safe place for humans to live. For example, astronomer Guillermo Gonzalez and science philosopher J. Wesley Richards said it would take a star with the highly unusual properties of our Sun, the right mass, the right light, the right age, the right distance, the right orbit, the right galaxy, the right location to nurture living organisms on a circling planet. Numerous factors make our solar system and our location in the universe just right for a habitable environment.
What's more, the exceptional conditions that make life possible also happen to make our planet strangely well-suited for viewing and analyzing the universe and our environment. All of this suggests our planet may be rare, if not unique, and that the Creator wanted us to be able to explore the cosmos. If the universe had not been made with the most exacting precision, we could never have come into existence, said Harvard-educated astrophysicist John A. O'Keefe of NASA. It is my view that these circumstances indicate the universe was created for man to live in.
The evidence of biochemistry.
Darwin said, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous, successive, slight modifications, my theory would absolutely break down. Biochemist Michael B. has demonstrated exactly that through his description of irreducibly complex molecular machines. These complicated, microscopic contraptions, such as cilia and bacterial flagella, are extremely unlikely to have been built piece by piece through Darwinian processes, because they had to be fully present in order to function.
Other examples include the incredible system of transporting proteins within cells and the intricate process of blood clotting.
More than just a devastating challenge to Darwinism, these amazing biological systems which far exceed the capacity of human technology point toward a transcendent creator. My conclusion, said B., can be summed up in a single word: design. I say that based on science. I believe that irreducibly complex systems are strong evidence of a purposeful, intentional design by an intelligent agent.
B's argument has proven impervious to challenges by skeptics.
While obviously there will be future discoveries in biochemistry, Belay pointed out that they will not be able to negate the complexity that has already been discovered and which is best explained by a creator.
The evidence of biological information.
The 6 feet of DNA coiled inside every one of our body's 100 trillion cells contains a 4-letter chemical alphabet that spells out precise assembly instructions for all the proteins from which our bodies are made. Cambridge-educated Stephen Meyer demonstrated that no hypothesis has come close to explaining how information got into biological matter by naturalistic means. On the contrary, he said that whenever we find a sequential arrangement that's complex and corresponds to an independent pattern or function, this kind of information is always the product of intelligence. Books, computer codes, and DNA all have these two properties, he said. We know books and computer codes are designed by intelligence, and the presence of this type of information in DNA also implies an intelligent source.
In addition, Meyer said the Cambrian explosion's dazzling array of new life forms, which suddenly appeared fully formed in the fossil record, with no prior transitions, would have required the infusion of massive amounts of new biological information. Information is the hallmark of mind, said Meyer.
And purely from the evidence of genetics and biology, we can infer the existence of a mind that's far greater than our own, a conscious, purposeful, rational, intelligent designer who's amazingly creative.
The evidence of consciousness.
Many scientists are concluding that the laws of chemistry and physics cannot explain our experience of consciousness. Professor J. P. Moreland defined consciousness as our introspection, sensations, thoughts, emotions, desires, beliefs, and free choices that make us alive and aware. The soul contains our consciousness and animates our body. According to a researcher who showed that consciousness can continue after a person's brain has stopped functioning, current scientific findings would support the view that mind, consciousness, or thesoul, is a separate entity from the brain. As Moreland said, you can't get something from nothing. If the universe began with dead matter having no conscious, how, then, do you get something totally different: consciousness, living, thinking, feeling, believing creatures from materials that don't have that? But if everything started with the mind of God, he said, we don't have a problem with explaining the origin of our mind. Darwinist philosopher Michael Ruse candidly conceded that no one, certainly not the Darwinian as such, seems to have any answer to the consciousness issue. Nobel Prize-winning neurophysiologist John C. Eccles concluded from the evidence that there is what we might call a supernatural origin of my unique self-conscious mind or my unique selfhood or soul. The identity of the designer. As I reviewed the avalanche of information from my investigation, I found the evidence for an intelligent designer to be credible, cogent, and compelling. Actually, in my opinion, the combination of the findings from cosmology and physics by themselves were sufficient to support the design hypothesis. All of the other data simply built an even more powerful cumulative case that ended up overwhelming my objections. But who or what is this master designer? Like playing a game of connect the dots, each one of the 6 scientific disciplines I investigated contributed clues to unmasking the identity of the creator. As Craig explained during our interview, the evidence of cosmology demonstrates that the cause of the universe must be an uncaused, beginningless, timeless, immaterial, personal being endowed with freedom of will and enormous power. In the area of physics, Collins established that the creator is intelligent and has continued to be involved with his creation after the Big Bang. The evidence of astronomy, showing that the creator was incredibly precise in creating a livable habitat for the creatures he designed, logically implies that he has care and concern for them. Also, Gonzalez and Richards presented evidence that the creator has built at least one purpose into his creatures to explore the world he has designed, and therefore to perhaps discover him through it. Not only do biochemistry and the existence of biological information affirm the creator's activity after the Big Bang, but they also show he's incredibly creative. Evidence for consciousness, as Moreland said, helps establish that the creator is rational, gives us a basis for understanding his omnipresence, and even suggests that life after death is credible. This is not a picture of the god of deism, who supposedly formed the universe but then abandoned it. As Meyer explained in my first interview with him, the abundant evidence for the creator's continued activity in the universe after the initial creation event discredits deism as a credible possibility. Pantheism, the idea that the creator and universe are coexistent, also falls short of accounting for the evidence, because it cannot explain how the universe came into existence. After all, if the pantheistic God didn't exist prior to the physical universe, then it would not be capable of bringing the universe into being. Also, Craig explained how the scientific principle of Occam's razor shaves away the multiple gods of polytheism, leaving us with a single creator. In addition, the personal nature of the creator argues against the impersonal divine force that's at the center of some New Age religions. In contrast, however, the portrait of the creator that emerges from the scientific data is uncannily consistent with the description of the God whose identity is spelled out in the pages of the Bible. Creator? In the beginning you laid the foundations of the earth, and the heavens are the work of your hands. Unique? You were shown these things so that you might know that the Lord is God, besides him there is no other. Uncaused and timeless? Before the mountains were born or you brought forth the earth and the world, from everlasting to everlasting you are God. Immaterial? God is spirit. Personal? I am God Almighty. Freedom of will? And God said, "Let there be light," and there was light. Intelligent and rational? How many are your works, zero Lord? In wisdom you made them all, the earth is full of your creatures. Enormously powerful? The Lord is great in power. Creative? For you created my inmost being, you knit me together in my mother's womb. I praise you because I am fearfully and wonderfully made, your works are wonderful, I know that full well. Caring? The earth is full of his unfailing love. Omnipresent? The heavens, even the highest heaven, cannot contain you. Has given humankind purpose? For everything, absolutely everything, above and below, visible and invisible. Everything got started in him and finds its purpose in him. Provides for life after death? He will swallow up death forever. As the Apostle Paul wrote 2 millennia ago, for since the creation of the world God's invisible qualities his eternal power and divine nature have been clearly seen, being understood from what has been made, that is, his creation, so that men are without excuse. The question of whether these qualities might also describe the deities of any other world religions became moot once I added the evidence that I discovered through the study of ancient history and archaeology. As I described in my book The Case for Christ, a summary of which is included as an appendix to this book, the convincing evidence establishes the essential reliability of the New Testament, demonstrates the fulfillment of ancient prophecies in the life of Jesus of Nazareth against all odds, and supports Jesus' resurrection as being an actual event that occurred in time and space. Indeed, his return from the dead is an unprecedented and supernatural feat that authenticated his claim to being the one and only Son of God. To me, the range, the variety, the depth, and the breathtaking persuasive power of the evidence from both science and history affirmed the credibility of Christianity to the degree that my doubts were simply washed away. Unlike Darwinism, where my faith would have to swim upstream against the strong current of evidence flowing the other way, putting my trust in the God of the Bible was nothing less than the most rational and natural decision I could make. I was merely permitting the torrent of facts to carry me along to their most logical conclusion. The fusion of science and faith. Unfortunately, there's a lot of misunderstanding about faith. Some believe faith actually contradicts facts. The whole point of faith, scoffed Michael Shermer, editor of the Skeptical Inquirer, is to believe regardless of the evidence, which is the very antithesis of science. However, that's certainly not my understanding. I see faith as being a reasonable step in the same direction that the evidence is pointing. In other words, faith goes beyond merely acknowledging that the facts of science and history point toward God. It's responding to those facts by investing trust in God, a step that's fully warranted due to the supporting evidence. Oxford's Alistair McGrath pointed out that all worldviews require faith. The truth claims of atheism simply cannot be proved, he said. How do we know that there is no God? The simple fact of the matter is that atheism is a faith, which draws conclusions that go beyond the available evidence. On the other hand, the available evidence from the latest scientific research is convincing more and more scientists that facts support faith as never before. The age-old notion that there is more to existence than meets the eye suddenly looks like fresh thinking again, said journalist Greg Easterbrook. We are entering the greatest era of science-religion fusion since the Enlightenment last attempted to reconcile the two. To many people, including physicist Paul Davies, this is a shocking and unexpected development. It may seem bizarre, he said, but in my opinion science offers a surer path to God than religion. Added nanoscientist James Tour of Rice University, only a rookie who knows nothing about science would say science takes away from faith. If you really study science, it will bring you closer to God. Astrophysicist and priest George Coyne put it this way: nothing we learn about the universe threatens our faith. It only enriches it. For Polkinghorne, who achieved acclaim as a mathematical physicist at Cambridge before becoming a full-time minister, the same kind of thinking he uses in science has helped him draw life-changing conclusions about God. No one has ever seen a quark, and we believe that no one ever will. They are so tightly bound to each other inside the protons and neutrons that nothing can make them break out on their own. Why, then, do I believe in these invisible quarks? In summary, it's because quarks make sense of a lot of direct physical evidence. I wish to engage in a similar strategy with regard to the unseen reality of God. His existence makes sense of many aspects of our knowledge and experience: the order and fruitfulness of the physical world, the multi-layered character of reality, the almost universal human experiences of worship and hope, the phenomenon of Jesus Christ, including his resurrection. I think that very similar thought processes are involved in both cases. I do not believe that I shift in some strange intellectual way when I move from science to religion. In their search for truth, science and faith are intellectual cousins under the skin. He added, however, an important distinction. Religious knowledge is more demanding than scientific knowledge, he said. While it requires scrupulous attention to matters of truth, it also calls for the responsive commitment to the truth discovered. According to McGrath, the Hebrew word for truth suggests something which can be relied upon. Thus, he said, truth is more than about simply being right. It is about trustworthiness, he explained. It is a relational concept, pointing us to someone who is totally worthy of our trust. We are not being asked to know yet another fact, but to enter into a relationship with the one who is able to sustain and comfort us. The facts of science and history, then, can only take us so far. At some point, the truth demands a response. When we decide not merely to ponder the abstract concept of a designer but to embrace him as our own, to make him our true God, then we can meet him personally, relate to him daily, and spend eternity with him as he promises. And that, as a young medical doctor and his wife learned, changes everything.
From science to God.
No one was more surprised by the scientific evidence for God than the soft-spoken, silver-haired, 77-year-old physician who was sitting across from me in a booth at a Southern California restaurant. His story, like the one Craig told me earlier about the Eastern European physicist who found God through cosmology, is yet another testimony to the power of science to point seekers toward God. However, it's something else: two-way road map for how you might want to proceed if you're personally interested in seeing whether faith in God is warranted by the facts.
Viggo Olsen is a brilliant surgeon whose life was steeped in science.
Graduating cum laude from medical school, he later became a diplomate of the American Board of Surgery and a fellow of the American College of Surgeons. In fact, his name has a whole raft of letters after it.
MS, MD, Doctor of Literature, DH, FACS, and D.TM, and H.
He attributes his former spiritual skepticism to his knowledge of the scientific world. "I viewed Christianity and the Bible through agnostic eyes," he said.
"My wife Joan was a skeptic too. We believed there was no independent proof that any creator exists.
Rather, we believed life came into being through evolutionary processes."
The problem was Joan's parents, both devout Christians.
When Viggo and Joan visited them in 1951 on their way to starting his first internship at a New York City hospital, they got an earful of religious propaganda.
In late-night discussions, Viggo and Joan would patiently explain why Christianity was inconsistent with contemporary science.
Finally, in frustration at 2 o'clock one morning around the kitchen table, they agreed to examine the Christian faith for themselves. Olsen implied his search would be sincere and honest, but inwardly he had already hatched a plan. "My intent was not to do an objective study at all," he recalled. "Just like a surgeon incises a chest, we were going to slash into the Bible and dissect out all its embarrassing scientific mistakes."
At their new home, Viggo and Joan labeled a piece of paper, "Scientific Mistakes in the Bible," figuring they could easily fill it.
They worked out a system under which they would discuss with each other what they were learning in their investigation.
At the end, there would always be more unanswered questions. While Viggo was working at the hospital, Joan would research the issues left hanging.
Then, on alternate nights and weekends, when Viggo was off duty, they studied together, analyzed, discussed, and argued.
Problems quickly emerged, but not the kind they were anticipating. "We were having trouble finding those scientific mistakes," he said.
"We'd find something that seemed to be an error, but on further reflection and study, we saw that our understanding had been shallow. That made us sit up and take notice." Then a student passed along a 1948 book called Modern Science and Christian Faith. Each of its 13 chapters was written by a different scientist about the evidence in his field that pointed toward God. Even though it was published before many of the eye-popping scientific discoveries that I've described in this book, the evidence was nevertheless sufficient to stun Viggo and Joan.
"It blew our minds," Olsen said. "For the first time we began to see there were reasons behind Christianity. Deciding to believe would definitely not be committing intellectual suicide. The adventure of a lifetime."
They devoured that book, plus many others that were cited in its bibliography. As they analyzed the evidence, they came to several conclusions.
First, they knew on scientific grounds that the universe was not eternal.
Rather, it came into being at a certain point. Since the universe is packed with power, heat energy, atomic energy, and so forth, they reasoned that it must have been brought into being by some mighty force. Second, they looked at the obvious design of the universe and the human body, all the way down to organs and cells, concluding that the power that brought the universe into existence must also be intelligent. Third, they decided that as great as the human intellect is, there is something even higher: the ability of people to empathize, to love, and to have compassion. Since the Creator must be greater than his creatures, he must also be imbued with those same qualities. Based on evidence and reasoning independent of the Bible, they were able to answer the first of the three questions that formed the basis of their investigation: is there a God who created the universe? They surprised themselves with their verdict: yes, a personal creator God does exist.
With this established, they began exploring their next two broad questions. Did God reveal himself to humankind through the Bible or other sacred scriptures? And is Jesus the Son of God, deity united with humanity, and can he help us as he claimed?
The investigation continued into those topics. One day, while Vigo was working at the hospital, he formulated what he thought was a powerful argument against Christianity. I was really proud of it, he told me, reliving the scene as if it were last month. I spent all day mentally honing it. I couldn't wait to tell Joan. At the end of his shift, he walked the 3 blocks to their small apartment. To this day I remember the thought that struck me as Joan opened the door and gave me a kiss. What a neat little pregnant wife I've got. He walked in and closed the door.
Standing in the entryway, he explained his new objection to Christianity. Finally, he asked, "What do you think?"
There was silence for a moment, he recalled. Then Joan looked up at me with her beautiful blue eyes and said, "But, Vic, haven't you, after all our studies, really come to believe Christ is the Son of God?" There was something about the way she said it and the way she looked at me that almost instantaneously knocked down all the barriers remaining in my mind, he said. The evidence was no longer obstructed. All we had learned came together into a wonderful, magnificent, glowing, fabulous picture of Jesus.
I hesitated, and then I said, "Yes, I really do. I know it's true. I do believe." I hadn't believed up until that point, but with the barriers torn down, I knew she was right. We moved into the living room and sat down on the couch. I said, "So what about you?"
She said, "I settled the matter several days ago, but I was afraid to tell you. All the things we studied and learned finally convinced me about the Bible, about Christ, and about our need for him."
A few days ago, I knew I was completely convinced.
She had already prayed to receive God's gift of forgiveness and eternal life. And that started the biggest adventure of our lives. Wanting to maximize the impact they would have, Vigo and Joan prayed a bold prayer in which they asked God to send them to a place devoid of both Christians and medical care.
He obliged, and they ended up spending 33 years in the poverty-racked nation of Bangladesh.
There, they founded Memorial Christian Hospital as a center of medical care and spiritual light, where countless people have found healing and hope.
They and their colleagues helped establish 120 churches.
They were warmly embraced by the people and the government of Bangladesh. In fact, Vigo was honored with visa number 001 in gratitude for his contributions to the country. It must have been difficult to live in an underdeveloped nation like that, I said.
Actually, he told me with a smile, it was the greatest adventure we could ever have. When you're in a hard place, when you're over your head again and again, when you're sinking and beyond yourself and praying your heart out, then you see God reach out and touch your life and resolve the situation beyond anything you could have ever hoped. His eyes sparkled. That's living it up, he declared. There's nothing that can match that. We got to experience that again and again and again. We wouldn't have missed it for the world. In
my opinion, finding the purpose for which God made you, whatever it may be, and then fully pursuing it is simply the very best way to live.
Vigo eventually wrote 3 books about his experiences.
I especially like the title of one of them, "The Agnostic Who Dared to Search," because it suggests there is a risk involved with investigating the evidence for God. At some point, the truth you uncover is going to demand a response.
And that could change everything.
You were designed for discovery. Though Vigo Olson has a stronger science background than I do, there were definite similarities in the way we both approached the issue of faith and science.
We read hooks, we asked questions, we tracked down leads, and we pursued the evidence regardless of where it was taking us.
We investigated systematically and enthusiastically, as if our lives depended on it. And in the end, our lives, our attitudes, our philosophies, our worldviews, our priorities, and our relationships were revolutionized for the better. If you're a spiritual skeptic or seeker, I hope you'll resolve to investigate the evidence for yourself.
Actually, Olson's 3-pronged approach would provide a good outline to follow. First, is there a God who created the universe? Second, did God reveal himself to humankind through the Bible or other sacred scriptures? Third, is Jesus the Son of God, deity united with humanity, and can he help us as he claimed?
You'll soon find that the universe is governed by both physical laws and spiritual laws. The physical laws point us toward the Creator, the spiritual laws tell us how we can know Him personally, both today and forever. After all, He's not just the Creator in a broad sense, He's your Creator. You were made to relate to Him in a vibrant, dynamic, and intimate way. And if you seek Him wholeheartedly, He promises to provide all the clues you need to find Him. In fact, you may even have sensed as you've been reading this book that He's already pursuing you in a subtle but very real way. You were, as the research by Gonzalez and Richards suggests, designed for discovery, and the greatest discovery of your life awaits you. So I hope you'll pursue scientific knowledge, but that you won't stop there. Don't let its allure become a destination. Instead, allow it to guide you beyond itself to the incredible implications it offers for your life and eternity. My suggestion is this: take a few quiet moments to soak in these closing words, so eloquently expressed by Alistair McGrath, and then become an impetus toward your adventure of a lifetime. Many have found that the awesome sight of the star-studded heavens evoke a sense of wonder, an awareness of transcendence, that is charged with spiritual significance. Yet the distant shimmering of stars does not itself create this sense of longing, it merely exposes what is already there. They are catalysts for our spiritual insights, revealing our emptiness and compelling us to ask whether and how this void might be filled. Might our true origins and destiny somehow lie beyond those stars? Might there not be a homeland, from which we are presently exiled and to which we secretly long to return? Might not our accumulation of discontentment and disillusionment with our present existence be a pointer to another land where our true destiny lies and which is able to make its presence felt now in this haunting way? Suppose that this is not where we are meant to be, but that a better land is at hand? We don't belong here. We have somehow lost our way. Would not this make our present existence both strange and splendid? Strange, because it is not where our true destiny lies; splendid, because it points ahead to where that real hope might be found. The beauty of the night skies or a glorious sunset are important pointers to the origins and the ultimate fulfillment of our heart's deepest desires. But if we mistake the signpost for what is signposted, we will attach our hopes and longings to lesser goals, which cannot finally quench our thirst for meaning. Appendix: a summary of the case for Christ. Here is a summary of the historical evidence for Jesus Christ from 13 leading experts who were interviewed for my book The Case for Christ. Can the biographies of Jesus be trusted? I once thought that the Gospels were merely religious propaganda, hopelessly tainted by overactive imaginations and evangelistic zeal. But Craig Blomberg of Denver Seminary, one of the country's foremost authorities on the biographies of Jesus, built a convincing case that they reflect eyewitness testimony and bear the unmistakable earmarks of accuracy. So early are these accounts of Jesus' life that they cannot be explained away as legendary inventions. Within the first 2 years after his death, Blomberg said, significant numbers of Jesus' followers seem to have formulated a doctrine of the atonement, were convinced that he had been raised from the dead in bodily form, associated Jesus with God, and believed they found support for all these convictions in the Old Testament. A study indicates that there was nowhere enough time for legend to have developed and wiped out a solid core of historical truth. Do Jesus' biographies stand up to scrutiny? Blomberg argued persuasively that the Gospel writers intended to preserve reliable history, were able to do so, were honest and willing to include difficult-to-explain material, and didn't allow bias to unduly color their reporting. The harmony among the Gospels on essential facts, coupled with divergence on some incidental details, lends historical credibility to the accounts. What's more, the early church could not have taken root and flourished right there in Jerusalem if it had been teaching facts about Jesus that his own contemporaries could have exposed as exaggerated or false. In short, the Gospels were able to pass all 8 evidential tests, demonstrating their basic trustworthiness as historical records. Were Jesus' biographies reliably preserved for U.S. World-class scholar Bruce Metzger, professor emeritus at Princeton Theological Seminary, said that compared to other ancient documents, there is an unprecedented number of New Testament manuscripts and that they can be dated extremely close to the original writings. The modern New Testament is 99.5% free of textual discrepancies, with no major Christian doctrine in doubt. The criteria used by the early church to determine which books should be considered authoritative have ensured that we possess the best records about Jesus. Is there credible evidence for Jesus outside his biographies? We have better historical documentation for Jesus than for the founder of any other ancient religion, said Edwin Yamauchi of Miami University, a leading expert on ancient history. Sources from outside the Bible corroborate that many people believed Jesus performed healings and was the Messiah, that he was crucified, and that despite this shameful death, his followers, who believed he was still alive, worshipped him as God. One expert documented 39 ancient sources that corroborate more than 100 facts concerning Jesus' life, teachings, crucifixion, and resurrection. 7 secular sources and several early Christian creeds concern the deity of Jesus, a doctrine definitely present in the earliest church, according to Gary Habermas, the scholar who wrote the historical Jesus. Does archaeology confirm or contradict Jesus' biographies? John McCrae, a professor of archaeology for more than 15 years and author of Archaeology and the New Testament, said there's no question that archaeological findings have enhanced the New Testament's credibility. No discovery has ever disproved a biblical reference. Further, archaeology has established that Luke, who wrote about 1/4 of the New Testament, was an especially careful historian. Concluded one expert, if Luke was so painstakingly accurate in his historical reporting of minor details, on what logical basis may we assume he was credulous or inaccurate in his reporting of matters that were far more important, not only to him but to others as well? Like, for instance, the resurrection of Jesus, the event that authenticated his claim to being the unique Son of God. Is the Jesus of history the same as the Jesus of faith? Gregory Boyd, a Yale and Princeton-educated scholar who wrote the award-winning Cynic Sage or Son of God, offered a devastating critique of the Jesus Seminar, a group that questions whether Jesus said or did most of what's attributed to him. He identified the seminar as an extremely small number of radical fringe scholars who are on the far left wing of New Testament thinking. The seminar ruled out the possibility of miracles at the outset, employed questionable criteria, and some participants have touted myth-riddled documents of extremely dubious quality. Further, the idea that stories about Jesus emerged from mythology fails to withstand scrutiny. Said Boyd, the evidence for Jesus being who the disciples said he was, is just light years beyond my reasons for thinking that the left-wing scholarship of the Jesus Seminar is correct. In sum, the Jesus of faith is the same as the Jesus of history. Was Jesus really convinced he was the Son of God? By going back to the very earliest traditions, which were safe from legendary development, Ben Witherington III, author of The Christology of Jesus, was able to show that Jesus had a supreme and transcendent self-understanding. Based on the evidence, Witherington said, did Jesus believe he was the Son of God, the Anointed One of God? The answer is yes. Did he see himself as the Son of Man? The answer is yes. Did he see himself as the final Messiah? Yes, that's the way he viewed himself. Did he believe that anybody less than God could save the world? No, I don't believe he did. Scholars said that Jesus' repeated reference to himself as the Son of Man was not a claim of humanity, but a reference to Daniel 7 verses 13 to 14, in which the Son of Man is seen as having universal authority and everlasting dominion and who receives the worship of all nations. Said one scholar, thus, the claim to be the Son of Man would be in effect a claim to divinity. Was Jesus crazy when he claimed to be the Son of God? Gary Collins, a professor of psychology for 20 years and author of 45 books on psychology-related topics, said Jesus exhibited no inappropriate emotions, was in contact with reality, was brilliant and had amazing insights into human nature, and enjoyed deep and abiding relationships. I just don't see signs that Jesus was suffering from any known mental illness, he concluded. In addition, Jesus backed up his claim to being God through miraculous feats of healing, astounding demonstrations of power over nature, unrivaled teaching, divine understanding of people, and with his own resurrection, which was the ultimate evidence of his deity. Did Jesus fulfill the attributes of God? While the incarnation God becoming man, the infinite becoming finite stretches our imaginations, prominent theologian D. F. Carson pointed out that there's lots of evidence that Jesus exhibited the characteristics of deity. Based on Philippians 2, many theologians believe Jesus voluntarily emptied himself of the independent use of his divine attributes as he pursued his mission of human redemption. Even so, the New Testament specifically confirms that Jesus ultimately possessed every qualification of deity, including omniscience, omnipresence, omnipotence, eternality, and immutability.
Did Jesus and Jesus alone match the identity of the Messiah?
Hundreds of years before Jesus was born, prophets foretold the coming of the Messiah, or the Anointed One, who would redeem God's people. In effect, dozens of these Old Testament prophecies created a fingerprint that only the true Messiah could fit. This gave Israel a way to rule out impostors and validate the credentials of the authentic Messiah. Against astronomical odds by one estimate, one chance in a trillion, 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 trillion Jesus, and only Jesus throughout history, matched this prophetic fingerprint.
This confirms Jesus' identity to an incredible degree of certainty.
The expert I interviewed on this topic, Louis Lapides, is an example of someone raised in a conservative Jewish home and who came to believe Jesus is the Messiah after a systematic study of the prophecies. Today, he's a pastor of a church in California and former president of a national network of 15 messianic congregations. Was Jesus' death a sham? And his resurrection a hoax? By analyzing the medical and historical data, Dr. Alexander Metherell, a physician who also holds a doctorate in engineering, concluded Jesus could not have survived the gruesome rigors of crucifixion, much less the gaping wound that pierced his lung and heart.
In fact, even before the crucifixion he was in serious to critical condition and suffering from hypovolemic shock as the result of a horrific flogging. The idea that he swooned on the cross and pretended to be dead lacks any evidential basis. Roman executioners were grimly efficient, knowing that they themselves would face death if any of their victims were to come down from the cross alive. Even if Jesus had somehow lived through the torture, his ghastly condition could never have inspired a worldwide movement based on the premise that he had gloriously triumphed over the grave. Was Jesus' body really absent from his tomb?
William Lane Craig, who has earned 2 doctorates and written several books on the resurrection, presented striking evidence that the enduring symbol of Easter, the vacant tomb of Jesus, was a historical reality. The empty grave is reported or implied in extremely early sources, Mark's Gospel and a creed in 1 Corinthians 15, which dates so closely to the event that they could not possibly have been products of legend. The fact that the Gospels report that women discovered the empty tomb bolsters the story's authenticity, because women's testimony lacked credibility in the 1st century and thus there would have been no motive to report they found the empty tomb if it weren't true. The site of Jesus' tomb was known to Christians, Jews, and Romans, so it could have been checked by skeptics. In fact, nobody, not even the Roman authorities or Jewish leaders, ever claimed that the tomb still contained Jesus' body. Instead, they were forced to invent the absurd story that the disciples, despite having no motive or opportunity, had stolen the body, a theory that not even the most skeptical critic believes today.